When the last video for this, huh? Long time video.
Oh, okay.
Mm.
Hah? Mulai exam. Ingin buka model farm.
Oh, ஆமாம்மா நீ செக் அவுட் பண்ணும்போது terus ada gitu. Hello, morning.
Morning.
Sorry, late already.
Ah, no problem. This is an evaluation form just going to fill up before cross switching.
Oh, okay, sure. Okay, open already. So, new project or?
You use S3 or? Yeah.
Okay.
Because yesterday we haven't controlled the motor yet, right? We just do the communication. We won't do any programming for the motor.
Right.
Using Profinet.
Yes.
Okay.
Yes,
We do that first.
Yeah.
Then, after we finish, we for that the same this one because they connected to that PLC, right? We do this program. Okay, we do FC by FC lah, by one program.
Okay.
Then we can do SCADA.
Okay.
Okay. Then in the SCADA, we can do the alarm trending. So this PID will have a trending.
Okay.
Everything one by one will go. Once we finish this, lastly, we try to do the Modbus.
Okay.
Yes.
Can do.
Can do because I see it shows can do, but mostly in the manual it shows more to Modbus RTU, Modbus RTU.
Oh, okay. We try.
If
We
we
cannot
try,
At least
then we can do this one.
Okay.
Just to understand that.
Yeah, sure. Okay.
Alright. Okay. So, we do the motor first. Later I will explain this.
Okay, sure. This is a transmitter.
It's just it's a controller.
It's a controller.
At the same time, it can convert the temperature value into 4 to 20 million.
Oh.
You see, 15, 16, 4 to 20.
And it can use a direct.
Yes, to power up this one.
Single phase
To power up this temperature controller.
temperature controller.
This is a temperature controller. It's not a. At the same time, it can show the value.
Export the signal.
Yes, then
420.
yes, 4 to 20 and can use 485 also. Modbus also can.
Oh.
For this one.
Okay.
Okay. But Modbus RTU lah.
Okay.
Okay.
Got it. Okay.
Right. Okay. Go to open project view. Okay. Open project view.
Oh.
So we just continue that on it break.
Okay.
Because I already have 50 minutes break. So you already check out already.
Yeah, already check out.
Right. Okay. Now, so as the drive is working, we already configured the drive, right?
Yes.
Okay. So no error. No error. Okay. I think. Okay. Now, we go back to the device and networks. Okay. You click on the drive. here, right click properties. Properties. Okay, open this. Okay. So you go to the Ethernet address. So this is the the drive Ethernet address lah. It's using network. Network is the PNIE, the Profinet.
Okay. This is me. If I connect with this Ethernet port, I have to choose P and IE.
No,
No.
not because of that. It's actually subnet means you click here. They're talking about this subnet.
Okay.
This subnet you bring it down a bit. Can you see? This subnet name is a Profinet ID.
So no matter what, if here now I name this something, I can name it.
Yeah, can name it here.
Oh, okay. So I named it this. This is a new Ethernet.
Profinet lah.
Profinet, sorry.
Yeah.
Profinet.
Okay.
Oh, okay. I just name it this.
Yeah, I think no error.
Oh, I have to save.
Not I think no space. I think so.
Oh,
New Profinet.
okay. I name it new Profinet. Something like that.
Just enter.
And
See got error. Okay, no error.
no error.
Yes.
Okay. So
You go
when
there.
when I go here, property,
Must open the drive because the property is for the CU. Yes.
okay, then I must choose. I am
Yes.
communicating with this.
Okay. Why? Why this one? Okay. Let's say, for example, you have a PLC, you have a Profinet network, at the same time Profibus network also you have. For example, you add a Profibus module.
So probably I have two communication.
No, not here. What I mean is, let's say here I add a one Profibus connection here. Okay. Let's say that I have another drive that is using Profibus. So if I configure the drive, I must use Profibus subnet. Now this one, I must choose the Profinet subnet. So it depends on, from the PLC I have two communication. One is Profibus, one is Profinet. So when I want to add any device, I need to choose where I want to add.
Okay.
Got it? No, okay.
I think I got it is maybe the PLC has a lot of different communication.
Yeah.
But not necessarily. But when I add this one, I must ensure that
Yes.
he is
Which
communicating
communication
through
I'm
the
using?
correct communication.
Which connection I'm connecting?
Okay.
Let's say, because sometimes in the same PLC I can have two Profinet. If let's say I add another module.
Oh, okay. The reason is because you can have multiple Profinet. But
Yes.
can possible.
Can you can add a Ethernet module here. So I configure one for some devices, one for some devices.
Okay, if I really do that, okay, this new Profinet, this thing, I think I got the lesson already. And one PLC now is a 1-to-1, right? If in the situation I have 1 to 10 devices, each of the communication have a different name.
No. All
Segment.
must go to the same Profinet.
Okay. So this is a, then how come we have at what situation he will have two
Okay.
different communication,
Okay.
two subnet.
You double click here. You just try to click one to the go to the hardware catalog. Communication module.
Super.
Profibus. Okay, I have Profibus. Okay, go to industrial remote. Yeah. The first one you click here. I want to see what is the model. Yeah, it's Ethernet module, right? Go down here. You see what is the module. Okay, SIMATIC additional Ethernet phase. Additional tele control protocol. Okay, RDC. Go down. I'm not sure this one can support Profinet. Okay, never mind. You go here. Okay. Okay, for example, you add one drive, dynamics.
What's a serious and
Series is a soft starter.
Oh, serious and soft starter.
Yes.
Okay, I add this one.
I don't know whether it support one, Ethernet or what.
Bus bar communication.
I don't think so. I'm not sure.
Oh,
We go to Siemens easier. Because why? I'm not sure which one support Profinet.
Yeah.
Ah.
Got it.
So Siemens J, okay.
G.
Yes, G120. Sorry, G120. Control unit. And this one also only Profinet. Yeah. Okay, just add drive and put it here.
Okay.
Now you try to connect this to this. Yes. Okay. Go back. Okay. So is that another connection, please? So I can put Profinet 2.
Okay. I want to ask. Okay. Let's
Yes.
say we add my profit into.
Yes.
So what's the other again?
Okay.
Okay. Done already.
Okay.
And then as my device is 0.2. This is 0.2. I use this one, right? 0.2, 0.1. Oh,
I think we need to change this one. The new Profinet.
why?
I don't think so. Can have. But okay, never mind. Never mind. You go to not assign first. You click here. You select Profinet interface. Which one? Profinet 2, right? Okay. You click here. Because it's not assigned to this, because why? I think this one is not Profinet connection. Because it's still asking you to assign. Okay, you click here to assign. I have only one. The arm from the controller. You click here. Okay, can you see? So I ask you to modify, because if you connect to that earlier, if you go to the first one. Okay. You see, it connected to this one. Because this one is not a Profinet. Like just now.
Okay. So this is
It's
not
not a
effective
Profinet.
communication.
It don't support. It's a different protocol.
Okay.
ANP3 or something.
Can we try to like add a correct
Profinet.
module? Yeah. Like maybe we delete this one and then we add a correct com module. That is support. Because just wondering
Okay.
the question is this at what situation, right?
I will have two.
Yeah, you
That's
have
the
two.
question.
Yeah, that's the question.
I understand. Okay. You close this one.
Or
You off this one. You cannot see.
is it would never have a two different Profinet communication? That's the question. Because let's say this one, let's say even it's only one, right? And
I
then
understand.
I go to a industrial switch and I go to 10 device.
Of course, it will be still the
Still the
one
same
lah,
one, right?
Okay.
So
okay,
so
but
what is the
now,
situation?
because the thing is, okay, you open this. Because this one don't have additional Profinet.
Oh, there is no additional Profinet card also.
For this module lah. You click
Oh,
here.
this module.
Yes, you click here. But this is not a Profinet. You click here because you see it's just support interface. Protocol is the DNP3 IC telecontrol. Okay, you click this one. You click here. Okay, this one for GPRS, GSM modules. Go down.
whatever, this MQTT or RTU everything they will pass through here.
Yes. Okay. No, profit bus, I have, okay. Maybe what we can do.
I mean, if you cannot do that, never mind. I mean, just
Never mind, I try here and I show you.
okay.
Maybe I use different model.
Okay, but
If there are two Ethernet port models, maybe I can try that.
yeah, I just want to know if you have a two internet,
Yeah.
different internet, then what does it mean here in terms of configuration? Yeah. Okay, so I remove this one first.
Just remove.
Okay.
Yes. Okay.
Okay, so now
We go back to
how
here.
to change the line to
No, because it's showing that Profinet to this one, like this Profinet to you.
oh, okay. Okay, done.
Yes. Okay. Open this. Okay. You the drive. Okay, open. So for the drive, you go to the Telegram configuration. Okay, you click here. The drive. Now, this one can close. Okay. So you remember? Yesterday when we do the drive commissioning, right? So we were selecting the motor type, like everything. So there's one place we select the standard Telegram one. That is, it shows PZD 2-stroke.
Yes.
Okay. So that is here, the standard Telegram one. Okay. So 2 means 2 input word, 2 output word between the PLC and the drive.
To be very sure, this is only for Siemens to Siemens.
Yes.
Anything other brand to Siemens or Siemens to other PLC can't do this.
Cannot do this. This is for the profit bus or for Profinet communication.
Okay, only
Okay.
for Profibus.
Profit bus or Profinet. Okay. If I tell Profit bus, Profinet means any other drive support Profit bus the same way.
Got it. Only a Profibus.
Profinet, Profit bus, they give you like this.
PN here means Profinet.
Yes, because the module is a PN module. That's why it's a what? They have a Ethernet port. Yesterday I show you another one is a DP module.
DP is Profibus. Okay. Okay, get it.
That is a DP module.
Okay. Oh, I see. Thank you. Okay, got it.
You can see the part number 250S DP.
Oh, so inside here both have the IO module.
It's the same thing.
Here AI was here, DNE was here. Okay.
So your yesterday AI is here.
Yeah, okay, got it. So this is a CU250 DP.
DP. This one is you can see PN.
Okay, get it.
Okay.
Yes.
Right. Now, so the standard Telegram one is offering you 2 input, 2 output. If you want to use more, so you need to know which one, how many input. So let's say the PLC give you some values, right? Means for your PLC is an input. Okay, correct?
Yeah.
From the drive to your PLC is the input. Okay.
Yes.
So you need to know the first input is what, second input is what, third input. That one you can get from the SIMATIC manual. So it will give you the status whether it's running, stop. Okay. Second one, it will give you the speed. Third one, you want to read the torque, you want to read the temperature, all that can. Okay. But we do the standard Telegram. I just need 2 enough. The speed and the status.
Okay, so you are saying that I have option to choose standard one,
Yes.
and Siemens
Yes.
this
Correct.
one.
Yes.
I have to read the manual to know that
What data you want to extract?
what data. So if I choose 3, in the manual it will say standard Telegram 3 means that you are
You choose
giving in and out.
3. Yeah, you choose 3. So So can you see? It gives you 9 words. It's the I. So you can see drive to the partner is the PLC. So if you choose Telegram 3, so it will give you 9 words.
Starting address is PZ, so this is our variable.
No, this is our variable.
Oh, this is our variable.
Yes. So they're telling starting with PZA1, then until 9. So it gives you 9 words. So it means I256, right? What is the address?
256.
I256. Okay? And it shows what? It's a word, right? So it will be IW256.
So 256, 257.
No, W. So 8, 10, 258, 260, 262.
Right. So that I have 9 words, right?
Yes.
So I have I'm going to use up 9 times.
18 bytes, lah.
18 bytes, right?
Yes.
18 bytes. So
Yes.
it's a 1 word is a 2 byte.
Yes.
So I'm going to use up 18 bytes here.
Yes.
Okay. And then from each byte, maybe
Each
some
word.
of the byte is speed, some of the byte is something.
Yes, not
right?
by word.
Word.
They use word.
Or it's one word by one word.
Yes.
not one by
So
one,
that's
right?
why they say words, right?
Okay.
Like they're using words also. The first word is status. Second word is code, the speed. And third word is something. Fourth
Okay.
word is to
Let's say I say first word is status only. It's a run status.
Yes.
But normally run status is a boolean. You don't need to use a byte so long.
Okay, I understand.
And then when I want to extract, actually I don't have to use IW. I assume 256.
No, you must use IW.
I still use must.
Why? Because they already tell you the first word is the status.
Okay.
It means is it run? Is it stop? Is it error? Is it forward? Backward? Everything is there.
Or it's a 1 and 0. It can be.
It's a value.
It's a value. It's
Yes.
a long value.
Yes.
Okay, so I must respect their format.
Yes.
They give you
Yes,
IW,
yes.
you just use the IW.
Yes.
Don't change it.
IW.
Okay.
Okay. But later I will show you how it works. The IW.
Okay.
Okay. So it is easy to understand.
Okay, so this telegram, just how it come here.
Yeah.
This is
Telegram 1, 2.
I have this
It's
because
under the drive manual. The drive property.
yes,
Under the drive.
I choose Profinet.
Under the drive.
Under the drive.
Yes. You will have 2 actually. One is send, one is receive.
Or send is a standard telegram format. Receive is
Same.
they follow.
Yes.
Okay. So just I go back to one.
One
wait.
is running now because
Okay.
just going to use 2.
Okay, then I have 2.
Yes.
This is communication through the
Okay.
Profinet.
Okay, wait. So it means so from the drive to the PLC IW256. So IW258, right?
This is I choose because
It's automatically gives some address, but you can change according to which address is available.
okay, got it.
Got it?
Yes.
Now, so when you open the manual and see, okay, I will tell you, this is the status word. Okay, they call this. Why I use this name? I can tell this is a other than status, what name I can. Maybe the condition, the motor condition.
Okay.
Okay. Why I use this name? This is the standard name they use for the drives. Even is any drives you use, even as a Modbus protocol or Profibus protocol,
Everyone will receive one word.
yes,
status
it's
word.
similar words.
Okay.
So like a status word.
Okay.
So the same thing for this one, they call speed word. No, sorry, that is. This one is they call actual speed. Okay, actually I can use the name current speed. Correct.
Okay.
The motor current speed.
Yes.
But I use the actual speed because this is the term they use in the manuals. Any drives you open. They similar words like they will tell like the actual speed or the current speed, something like that.
Okay.
Okay?
Okay.
Okay. When you go to receive,
This I Ascend now. Okay, ascend now. This is the copy.
This is from the drive to the PLC. That's
Drive.
what is an input. Similar to your analog.
Send from the drive
Yes.
to the PLC.
Yes.
Okay. Yes, specific very clear.
Yes.
Here is received
PLC.
from the drive, received from the PLC.
Yes, that's why. So
Okay.
it's a queue address.
Okay.
Okay.
I have
So
got
it-
two.
256 QW 258. One is send, one is receive.
Two word.
Yes.
QW. Okay. I
Okay.
received two word.
Yes.
Mm.
So the first word is the control word.
Mm.
Second one is the speed word. So actually this is the one controlling. So like I know just now similar question just now.
Mm.
Motor you want to on and off, you just need a boolean.
Mm.
Correct.
Mm.
But why we need the one word?
Mm.
Because I use the same word to send different command to run, stop, forward, backward.
Oh.
Okay? Okay. So I will tell you this one. Okay. First, this one have a very basic controller. Forward, backward, stop.
Mm.
If any error, reset. Okay. So this is where the hexadecimal we will use. If you see the manual, okay, in the manual, what you need to do, you need to send this value 47F to the control word, then the motor will run.
Mm.
Okay, 47F, 47E, 4FE, C7F. Okay.
Mm.
Why this number? If you see like this, it look like what is this number? Okay, actually this one all if you convert to binary is 101010 something like that.
Mm.
Okay?
Mm.
Okay. So what happened? Inside here is what? Is a 25 7.0 until 257.1, then 256 0 until Q256.7.
Mm.
Correct?
Mm.
Because we know it will use the first byte first,
Mm.
then only the second. The second byte, then we go to the first byte. That's how we break down. Okay.
Mm.
So each of the bit actually that's a meaning.
Mm.
So there's one bit for enable run, one bit for speed.
It's a combination. Actually.
Yes, the speed. Enable the speed. One bit is for enable the set point, something like that.
Another way to say.
Yes.
So if I want to really hack their code, I go to manipulate the
Manual.
Q boolean.
Yes.
I just change I can do that. But
Can.
not advisable.
Can also not like
Oh.
can use. I've seen some program last time I go to Kuantan Port to do training. So Apex. So one of the guy he know about the PLC programming and everything. So I went there 2 times. First they request for SIMATIC manager training. Second the same batch they request for Siemens TI motor training. Okay. So one of the guy he know how to use the PLC troubleshooting lah. Okay. The last day I teach this one. Then normally I will teach only use these words lah.
Mm.
Very simple. If you want to move forward, I use the move function. Move this value to this address. The motor can run.
Mm.
Okay. Then what happened? He go to his program and look for this address. Cannot find. Why? What happened? Because they were using the bits. Because what happened? Because if let's say you want to just run forward and stop on it.
Mm.
So you see, you take these two and check which bit is on. If you see, only one bit is different. Correct? 47E, 47F. Only one bit is different. So let's say some of the bit is on. You can do that. This is just an example. Okay, let's create like one function called always on. then you see some of the bit, which bit you want to on something. Okay, then when you press start, you on Q256.5 for example, because that particular bit only is forward. If you on forward, if you off, you stop.
I think I get what you're saying.
Yes.
So probably like this combination 47F is a forward move,
Yes.
or backward move,
Yes.
forward stop, backward stop.
Yeah.
And then I can have something like I press the stop button, but if it's forward, it will stop. If it's backward, it will not stop.
Yes.
Something like this.
Yes.
But I have to know exactly
To
Which
enable
bit?
which bit.
yeah which bit is what it means. Yeah.
Yes.
And then I can manipulate the bit here.
Yes, correct.
Okay, I got it. Yeah.
That's how it works.
Okay.
Okay.
Yeah.
That's how normally the drives goes. Because why? If I even the Profibus, even the Modbus also same. Modbus also same. Because
What pass also same.
same. Yes. Why? Because sometimes what happen, the Modbus they will already give you the bits.
Question. Modbus, this format is universal. Byte, word. Modbus also communicating with this byte.
Word also can, bit also can.
Bit also can. So
Yes.
Modbus also using a same format. 8 bit become a byte. 8 byte. 2 8 byte become a word. Two
Yes.
words become a
Yes,
double
yes.
word.
But normally, Modbus don't start with byte. They will have bit straight away word, double word, real.
Okay, times 2.
I mean straight away 16 bits lah. There's no 8 bits.
Oh, okay,
If you ask me
okay.
lah, I think no 8 bits. in
Okay,
Modbus
okay.
lah. They have boolean, word, double word, real.
Okay, get it.
Okay.
Yeah.
Okay. So this is the one. So this data from the manual you can get lah.
Okay.
Okay. At the same time, if you want to control the speed is 0 to 4000 in hexadecimal.
So I have to conversion.
No need. Of course, you need to do the scale.
The scale, yeah.
Normal scale X lah.
Right.
You convert into RPM or hertz.
Okay. Because you say 0 to 4000 hex, right?
I can key in hexadecimal X number 4000 or I can key in 16824. Need to convert lah.
Oh, okay. I give a decimal also can.
And
Okay.
just need to know when you key in, you must know what is the is it what hexa or decimal. So if you key in decimal, just key in like this. If you key in hexa, you need to put any value in hexadecimal. You must key 16 hashtag. Here is the X value.
Oh, this
Because
is
why?
how to do in programming.
Yes.
If I want to key in a value, actually it accept any value. It accept binary, it accept
Yes. If you want to put binary also can.
Oh, but default is a decimal.
If binary is this number lah.
Oh. So
Binary. Actually, if you put decimal, you can put like this also.
but it is same lah.
But normally decimal, we just put the decimal value only.
So let's say today there is something that I have to give a integer. For example, the I lah, the I. I think the I we say that when we receive AI is a 22,000, right?
27,000.
27,000, yeah.
Yes.
0 to 27. And then something that we have to do either is I can key in 27,000 to activate this something, or I can key in the hex of the 27,000.
Yeah. 6C00.
60.
6C00.
60. So I can key in 16 hash bracket 60,000.
Yeah, that's what we want to
Then you
achieve.
can understand this.
Yes, of course.
Okay, got it. Yeah.
Okay. So, very simple. Here we set the speed. Here we set the value. Then we can go. Okay.
Yes.
Then actual speed, same thing. When it's running is 0 to 4000 hexadecimal. Then the status word, this one I always forget one. What is we can check like forward, backward, and when it's in stop mode lah.
So the 0 to 4,000 hex is essentially is a 0 to 100%. And what is the limit of 0 to 100% is how we do the configuration.
Yes.
Okay.
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 We do a simple program. Just to start, stop, forward. Later this data we can put in the SCADA.
Okay.
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 So the whole day we will just doing programming in this project only. This
Okay.
PLC project only. All the project we can do.
Okay.
You go to PLC. You go to program block. Okay, you just add one addition. Yes, you put dynamic control. Function. No. Have you used FC lah? Subroutine. Yeah. You put name dynamic control.
Okay.
And use ladder. But that day we use this. I show you the SCL function, right? The structured text. You do the calculation.
Yes.
Okay. Ladder. Okay. Another one is a FBD.
We never use function block. Okay.
FBD is I can do one
Right, the question.
simple one.
Let's say we do a ladder, right, for this function block. Let's say we do already, and then later I come back to see it. I want to view it with FPD. Can you? Cannot. You cannot.
Cannot. SIMATIC can.
Oh.
Actually, that's how I learn the ICL function. What I do, I create a simple program in ladder. I convert to the SCL.
In the old software can now.
Yes, cannot. Now this software cannot. Okay, why? There's actually everything. There's a meaning. Okay, why? Because you see, why there's no function here? Because SIMATIC manager one line. Let's say multiple branches lah. I don't care. It's one line. Okay, can be put in one network only. Okay, if you're doing another run, they call it a run lah, right? Must be in another network. So if that one I want to convert into SEL, so it will be in one network. So at the same time I can create a program in SCL and I can convert into ladder also. Because why? In one network I can do like one SCL function which is similar to one line. But in TI portal 1002 and 1005, one network I can do multiple lines. So that's why I cannot convert them. Convert because sometimes what happen in 300 or so, if let's say I create a SCL program in one network, let's say I create like multiple line programs, I cannot convert into ladder also. Because ladder means one network, one line only. So in SCL, let's say I created like multiple lines, I cannot convert. So that's why here I cannot do that. Change the language.
Okay.
But in the ladder, I can add SCL blocks also. Click here, right click. Right click. Insert SCL. So the first network will be ladder, second network will be SCL also.
Can we try one function block? Just one.
FBD.
Yeah, FBD.
Can. Later we do one simple program on the FBD.
Okay, yeah.
Not function block. Block, this is the FBD language.
FBD is, what is the full name of FBD?
Function block diagram.
Function block diagram.
Yes,
Okay.
it's a language.
Okay, language.
Our normal function block is a function block.
Okay.
Now, here, we do a simple program. That is, first I want to do the speed convert. Okay, you take instruction. You use the norm x, scale x.
Okay, scaling.
Yes.
Norm
Norm
first,
x.
then scale.
Yes. And scale. Okay, click this. Okay, But okay. At the same time, we learn the DB as well. Wait, you put this one first. Select the data type.
This is an integer.
Integer.
No, it's real, right?
This one must be real. Okay.
And
This one real. Okay, this one is integer. So do you want to do scaling for actual speed? Input first or the output?
Okay.
Okay. What we do? This one make it smaller. Okay. Now this one can bring it down. Okay. Now we do for the feedback lah. Then later the set point we do here. Okay. You can just copy paste these two here.
Oh, copy paste now.
Hmm.
How to copy paste?
Yeah, okay. Copy paste.
Okay.
Now before that, okay, what I do, I go to add new block. I add data block. Okay, this data block is a global. Okay, this one I want to because this is what data I want to show in the HMI. Sorry, in the SCADA.
So this is a mapping to the SCADA.
Yes, later we want to use this data block. Okay, SCADA. Just put name SCADA, and but can put any name. Okay. Global DB means similar to my memory. Okay, similar to my memory. But why I'm using global DB? Because whatever I want to show in the SCADA, I can list down here. Okay, you click OK.
6 today I'm not using WinCC, I use some other.
Can some other same thing.
Same thing, I create a SCADA DB first,
DB.
and then I
Export the DB.
Export the DB. Oh,
Yes.
Okay.
Okay, good question. If you are using some different brand of SCADA,
Right.
it's better to use DB. Because whatever I want to show in the DB, I mean in the SCADA, I list down in the DB, then it's similar to your memory lah. M0.0, MD0, all that. Then wherever I want to use in the program, I can use, then I export. Because sometimes you cannot export only memory. Because memory will fall under PLC tag. So if you export the PLC tag, means you will export all the tags, not only the particular memory. If DB means I only export whatever I want to show them.
This selected,
Yes.
maybe the whole program has a 1000 whole variable,
Yes.
but I only want to choose to communicate with 100
Yes.
item only.
Yes.
Okay, got it.
Okay. So this DB is a global DB. Can you see? I have only static. If you see some instance DB, that day remember when you have function block, you will have a DB.
It is only functioning within the function block.
Yes.
Okay.
That DB only keep data from the function block.
Okay.
So when you open that DB, you can see the input, output, in, out, static. These four you can see. Because
Static means global.
not static means global. Static means okay. It's it's just a variable. It's not an input. It's not an output. Okay, you can use as an input. It's just like a relay lah.
But static can change, right? I mean, can be changed through a function, right? Static is something that
No. Okay, I know what you mean. Static means you don't think about the static data.
constant.
Yeah, no.
Static is not
No,
constant.
not constant. It's just the data type. I mean, not the data type. The what do you call? The function is a static means is you can use as a input. You can use as like a memory lah.
Can you can we have a quick example? What kind of things in the program you would use it as static, for example?
Okay. Normally, if you use the function block, okay, the timer, the counter, all will fall
this
under
is
the
on operating,
changing values, because the timer and counter inside timer counter itself is a function block. Inside that block is already have a input, PT, Q, ET. So already have the data of input output. So that's why it says static. You cannot define that as an input or output.
So what is static?
Static.
Yeah, just like you say, what have to be defined as a static?
The timer, the counter, whatever memory I want to use inside the blocks.
You mean the counter? Let's say I
I
count 100 bottle. So the count of 1, 2,
No,
3, 4.
not necessarily. Okay, I will
Okay.
give you one example. You go to add new block, go to function block. Okay. Just block one later can delete like a problem. You okay? Okay, you bring it down here. So this DB, if I call this function block, right? This function block have a DB. This DB will keep the data of input, output, in, out, static. Okay?
Okay. Input, output, in, out. Okay.
You understand?
Right.
Okay. Static means is just inside the blocks for this particular function block. Okay. Whatever timer I use, I will go under static. Whatever counter I use, I go under static. Whatever memory I want to after the timer, the memory one, that I use the memory to other place, correct? That one will go under everything is a static. It's like a memory.
How about the temp?
Temporary is, it can be in the same line from here to here. You cannot jump the temporary. Okay, temporary mode to keep value. It cannot keep the status of 1, 0. Okay,
I
you
feel
don't
this
get,
is an important concept.
okay, you don't get, no problem.
Yeah.
What we do, you just put start, stop.
Okay.
No,
This
you
is-
just start. Put start.
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 Okay.
And
This is
our
a
output motor.
output motor. Okay. This is a run. Okay.
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 Static, you don't do anything first. Because later you open. Put it.
You mean?
Yeah, just close.
Okay.
You put start.
Okay. Here.
Yeah.
Let's start.
Okay. I give you one example. The example will have all the constant and everything. Try to do that. Okay. Start. One output. You latch the output. Okay. No need to use that. Normal. Motor. Okay.
Okay.
You latch the motor. No. Yeah. You're correct. But must put yeah. Okay. Normally open. Close branch. Okay. Next, you just put it here. Okay. The motor, normally open the motor.
Motor.
Yeah, motor.
Okay.
You add a timer. No, TON. Okay. Wait down. We use the multi-instance. Okay, because it will share the same DB from this. Okay. The name don't care after login. Okay. Now you open and see here. Okay. The timer data will go under the static. Okay, why? Because you open the timer. Because timer will have like all these data.
So one timer function block, it will create
One static.
one static. Actually, one static essentially it has a multiple variable
Can
inside.
have multiple variables. Okay. Another thing. Okay, you close. Okay. You add. Okay. You go
Is
to.
it, can you say like this? Every time everything is seen within the function block.
Yes. All. Okay. What that is
All is
number one.
static.
Or that is number one. That is correct. Or whatever inside a function block. If you add another function block, then if you wish to use 1 dB. For both share 1 dB, it will go under static.
Okay.
Okay, that's number one. Okay, number two is, let's say I want to, after this timer, I want to use this queue and cut off my motor, right? Okay, you open this. Okay. Actually, temporarily, what is the function of temporary? Temporary means it's inside the blocks only, right? Correct. Okay?
Or Q is something inside the block only.
Not queue, which queue?
Oh, sorry. Temporary.
Temporary.
Yeah.
Temporary is inside the block.
Not even outside of the Q before the I, before the E.
No, what I mean is inside this function block.
Inside the function block.
Okay, I know where you want
Oh,
to.
this one also inside the function block, isn't it?
Okay, wait. You go to main. You drag this function block, put it here. Okay. Just DB1, no problem. Okay. What I mean is only input, output, in, out only will show here.
Can't change it.
What change?
Oh, okay, good. No, this is calling. This is calling.
Okay, the calling, okay. The static, the temporary, the constant will be inside the block.
Oh,
Okay.
okay.
Wait, I haven't finished. Okay. Now, you go to this DB, this DB2, you go to DB2. This DB2, what you can see input, output, input, and static. Okay? Temporary and constant, you cannot access, you cannot see the value.
Static is inside the block.
The static is inside the block, but in the DB, you can monitor the values. Okay? But
Static
temporary
is inside the block, and you can
modify
add
it.
to the DB.
When you add a DB, you can see in the DB, you can add it in the DB.
So if I create a DB, I can have a DB to show, just as I say,
Because
the
okay,
timer.
you make it bigger. This one. Yeah. Okay. Now, you see here, I got two type of DB here. Okay. This DB is for this function block.
How this DB come up? Because when I create
Because
the
when
function
you
block,
call this
automatic-
one DB,
it will automatically create.
yes, this DB called instance DB.
This is the instant DB because this is serving the
The
function block.
function block. Whatever data you see here, all from the function block.
Got it.
This DB is a global DB. You can see. If you open, you only have statics only.
So
No input, no output, no input output.
I understand. So let's say I try to understand the concept here. Let's say we have an instant DB. I have created a new timer.
Okay.
Okay, I say this IEC timer finish.
Okay.
And the IEC timer has these four
Yes.
variable. This is my static. This is my static folder, block one. I now created a new SCADA. Actually, I can call, not to say call, I can include this variable, this static variable from this function block to my global DB. Can I do this? Can, right? Right? Or cannot? Let's say I want to always know.
Okay. Can use also.
But that's not the purpose.
That's not the purpose.
Okay.
Okay, number one. Then I want to show you something. You
Okay.
open the function block first. Okay. You add here another static motor off.
Okay. Motor off.
Yeah, you just follow me. I will do a
Okay,
proper
got it.
program. Then you change this to boolean.
Okay.
Okay. Now you close this first. Now you add here normally output motor off.
Okay.
Okay.
And this is static. Because
Yes, it's a static. Why? I cannot use temporary. Okay, I will tell you where I can use the temporary. Motor off. Okay. Because this one I don't need any output. This one is just to cut off my motor, right?
this is only functioning inside the.
Inside the blocks only. Okay.
Okay.
Okay, you go upward. Okay, you put normally close here, motor off. No, normally close. Okay, you can change. Okay, motor off. Okay, now go down. I show you the example of constant and temporary. Okay? Constant and temporary. Okay, you go up. I mean here, you go to here. Go to input. Input. Okay, you click here. No, here. Timer in.
Okay. Timer in is something I get from outside.
Outside lah, the timer input value. Okay. Okay. But I don't want to use the data type time. Okay. Okay. I want to use integer.
Okay.
Integer. int. Okay. Okay. Now, what? Okay. We know timer is time means 10 seconds. Okay. If integer means I need to give 10,000.
Okay.
In decimal, correct? Okay.
Yes.
Okay. But what I want to do, you close this one. You go to calculation. Next function. Multiply. Yes. Go down. I try to do a proper just nice. Okay, you click here, bring this to here. Okay. Multiply. Okay. Here you put the what? Start the input.
Time in.
Time in. Okay. This one I want to put constant. Okay. You close, open this. Go down. Go to constant. Okay. You add multiply. Just put data one.
Okay.
Enter. Okay. Make it integer. Okay. Then you put a default value 1000. Okay. So
here I put.
here you put the data one.
Okay.
Okay. So can you see it's default 1000?
Right.
Okay. Then I take the output. Okay. The output I put in temporary.
Okay. Time second something like this.
Yeah. This one is
Okay.
time value. Just
Time
put
value. Okay. Time value.
Okay. It is in integer.
Okay.
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 Put it here time value. Okay. Then you see here, because time value is an integer, right? But for my timer, I must use double integer, correct? You close this. You go up. Okay. Here we need to put double integer, double quote or time. Correct. Okay. But my calculation is integer. I cannot put it here. So what I do, I don't change. You close. You go to conversion.
Conversion.
Operation. Yes. Convert. Take convert. Okay. You put it here. You put integer to double integer. Okay. Time value. Okay. Time value. Okay. Then I create another one. This one later you can want to use. Okay. Current timer or something like.
Okay.
That is the tag I want to use it here.
Okay. Okay. Current timer lah.
Current timer lah.
Okay. So
Okay, enter. You right click. Define tag. Okay, I define as a local temporary. Okay. Temporary. Okay. Define. I use it here. Temporary. Okay.
Okay. So
Okay.
this
Now you open this. You see. You make it full. You go down until the end. Now you see which one is the temporary, which one is the constant, which one is the static. You go up. The input output you understand lah, I know. Okay. Okay. Static. Okay. Why this one? I don't want to use temporary. Okay. Because temporary means if I want to use what? Because the temporary, I also doubting the current timer can it work or not, because sometimes a different network it cannot work. Okay? But this one, motto of Boolean, means if it is in the same network, I can use temporary. If I'm using in different networks, I cannot use temporary. I must use static. Okay?
So probably your current timer will not work.
Yes. Because why? Why this one? Because why this a difference? The motto, okay. Because when I can use Boolean as a temporary, can use when you know like when you do a pulse. When you do a pulse, here is the tag right? Here sometimes we put the memory. Right? We only use here only. Any other place we don't use, correct? This is you can use the temporary tag. Okay, because it's a Boolean. Only one place. Okay. If the temporary tag, Boolean tag, if the temporary tag you want to use as an output, then you want to use as an input. Normally open, normally close. You want to use as a coil and also a contact, then you can use temporary. You only can use as a contact or coil only. So if you want to use like a contact and coil, this one we call like a auxiliary relay, right? Must use static. So only because static only can be changed, can on and off.
It seems to be a
temporary mode to value, keep the values.
If I create everything, I just name it static.
Can also.
Can also actually.
Can also. But the thing is, but this current time also I'm doubting. Okay, what we do, we need to test, then only we understand.
Okay.
So you go to Dynamic Control.
Okay.
You delete first that one.
Delete.
Delete later we can do it. I mean just delete network. Because if big error I cannot download. Yeah, just delete. Okay. In the main already add. Right click. Update. Yes. Okay.
So I have a time in. Of course, my time is 0 here.
I just put I 0.0 here. I 0. Okay. Then Q0. So actually we don't delete this one, okay? The time just put 10.
10 seconds. So question.
No need second, that's the thing. Because it's an integer, right?
Okay.
Okay.
Question.
Yes.
Okay. This is the only place I always key command. I mean,
Yes.
let's say it's a programmer or me. If I do this, I will be easily forget already. As it means here.
Yeah.
So this is the only place, right?
Yeah. The comment, you can put the comments.
Okay.
Function blocks. Okay. You download first.
Download.
Yes. Continue without synchronization.
Okay. So the PLC refresh already. Finish. Now all the light is off. Okay.
Okay, now monitor.
Okay. Fine.
Okay, you double click here. No, I just want to see. Monitor. Whether the value is working or not. Okay, go bring up. Close. Can you see? Temporary, it's supposed to here got value, right? Can you see? I cannot see. Because, but this is a temporary, right?
So,
Time value is temporary, right?
so at least a clear difference is static can cross the network.
Yes.
Temporary cannot cross the
It's
network.
within the network can.
Okay.
If I take the whole thing, put it here, then I think it should work.
If this run is happening here,
Then it should work.
then it should work.
Yes. What we do, you go offline.
Okay. Offline.
Offline. You right click the current timer.
If I have
Oh, cannot. No, cannot rename. What we do,
here to move
go
it.
down. Yeah, just move it. Can move. You just cut, paste that. No, cut the whole thing. Paste. Okay. I still need to download. Okay. Actually, this is a very good example. You can keep this one so you know which one temporary, which one is constant, which
Right.
one. Actually, I created one for my laptop. One what? Maybe I can share with you the file. Check. I have all. What I did is I created a few programs. One is for PID, one is for alarm, one is for FD sample, one is scaling sample, one is the SCL sample, one is the function block.
Or like
Just
a
keep-
tutorial for everything.
Just like in case I forget something means I can always open the file and see. So I can share with you the file.
Okay.
Okay. Now you want it. No, if it is this one, I need to click it. There only. Click the arrow. Yeah. Okay, you do reset. No, need to close and open. Close this and open again. Okay, open again. From here. Can you monitor?
Okay, so now it's working.
Mm.
So this is a clear definition.
Yes,
That
okay, you go
can
off.
and- Yeah.
You go offline. No, offline, go offline. You can just put a comment here. Temporary tag within network. Tag variables within network. Okay. Static can cross network. Easier way to understand that, right?
Yes.
Yes. Okay.
Okay. Okay.
Easy.
Okay. Yeah.
Okay, you save this. Understand this?
Understand this.
Okay.
Clear already.
So the motto of this one is a static, right? Instruction static. Okay. Okay. Why I tell you this one is because one is the simple thing is that static means can cross network lah. That is one. Okay. Okay. Another one is static means that it's like as I say it's like an internal relay. You can on it, then you can use it anywhere else.
Within the function block. Okay.
Within the function anywhere. I mean, of course lah. This static, this particular static within the function block. But whatever we create in this DB is a static, right? It means that it's like a memory only. Anywhere, all the blocks can use.
So global DB should not have any concept of temporary.
No, it won't have.
Because it don't have temporary.
Yeah, one is don't have temporary. It cannot have the temporary.
But in essence, it can only have a static, right?
Yes, only F and F statics. That's why inside DB is only F static.
Oh, okay.
Don't
That's
have-
why it's only have static.
Don't have input, don't have output. This is like a purely like a memory, but it's a DB. Similar to your memory.
But you can't have constant there once. How come you cannot have constant? It should have.
Constant.
But okay lah, no
Can.
meaning for it to have a constant.
No, can have. Let's say I want to put here, I can put a start value, I can retain the value.
Oh, okay, that's define it as static, but actually it's functioning as a constant. Right?
Yes.
Okay, I got
Okay,
it. Yeah,
got
I
it.
got it. Yes.
Now what we do, we put it here. VFD set point, RPM. Okay, enter. Do you want to set an integer or real? It's up to you. The RPM number. Integer lah.
Okay, okay.
Just choose integer. Okay. Then VFD feedback RPM. Okay. Then you set feedback. Okay. Later on, if you want to add, we can add. Okay. Edit, because later on I want to do this temperature value also. Okay. Okay. Just put current temperature. Okay. Whatever you want, I want to show, I want to put it here. Current
temperature. Okay.
Current temperature.
Okay.
Maybe you can put real current temperature. Okay. Then for the VFD, I want to start forward, start backward, stop, reset. This 4. But this 4 is a boolean. No, boolean.
Oh, boolean.
Because it's a push button.
Yes.
Okay, just you drag, and go.
Okay.
Okay, good. Okay. So later on, when you want to use, then again you can do. Okay, go to dynamic control. Okay, now you put the normax scale X. Okay, normax put in front. No, normax in front. Yeah, easy. Okay, same thing. Just put integer. Integer real integer. Okay, just copy these two. Okay, put it down here. Actually, you can use the Control C, Control V, or like a normal one. Can use. It's the same thing. Okay, can close this. Okay, this one is the feedback. Okay, so the feedback is where you go to the value.
Go to the value. This is from
Okay, you can put
IW.
IW to file. No, don't have, because we haven't created any tags yet. We haven't created any tag table.
And to go to the PLC configure.
No need. You can use in the tag table.
Oh, table.
Remember, in the tag table we will create the start, stop, moto. So from where actually we get the address. This one you just can put one name.
Okay, I get your point. I just start from that place. I
can directly
key in, or I
So-
create key first. Yeah,
Yeah.
it's a set.
Yes. But in this one, if these two you change name, because
Just now we do the example.
just now the function block example, right?
Yeah.
Just put start motor. Start and one motor. Okay. Because I want to do this program as a full sample. Whatever we learn, everything will be done. Okay.
PLC tag only include in I and Q only.
No, memory. I, Q, M.
DB is
No, I think maybe you can follow me first.
okay,
Then maybe you can understand.
Okay, got it. Yeah, let's do it.
Yes, okay. You go to dynamic control. Or maybe, okay, you go to show all tag.
Okay, let's do it.
You key in all this.
Okay.
So status word. tell, no problem.
Okay, status word. Okay.
Status word, okay. Put integer. INT IW256.
I we know because there's some configuration is C already.
Yes.
IW256.
Okay. Then you add no. Don't put status word, just put control word. These two I want to put in other place. Control word. QW256. Okay. You can create here, also can. In the program, also can. You just create IW and later on rename.
Okay.
And another place is, you go to the, go up. I think the configuration is here, the drive configuration. You open the properties. Okay, the property. You see the drive property. Okay, go to the IO tag. Oh, don't have IO tag. Okay. Go to general. Okay, because you cannot add in the IO tag. So only place is the tag table or in the program.
Okay.
Because if you go to the you go back to the drive. Go here. Yes. Open the PLC. Go to the IO tag. Because PLC I will show all the IO tags here. Here also you can add the names.
Yeah.
Okay, I want to add the name for IW66. You put it here. You click here. Okay. IW66 is your analog.
Right.
These two analog input.
Analog. Okay.
Yeah.
You want to use. You want to
66.
give something to this analog.
Yes, the 66 is your temperature value.
Or temperature. Okay.
Yeah, you put AI temperature. AI temperature. AI temp, yeah.
66.
66. Because 64 is this one. Because you have two, right? Okay. So you can put it here. You can put it. The names lah. You can put it here. Can put it in the program or can put it in the tag table.
I forgot one thing. This analog input, word or double word, it always is a word.
Analog always is a word.
No, never a double.
Never a double word. Similar to our VFD, the data we take, right, is always word, no double word.
Double word only happen when we have some
When
kind
we
of
do
format.
programming only, normally
Programming.
double word we will use.
Oh, like this one.
Yes. If you ask me, any data we take from any instrument,
Always is a word.
always is a word only.
Always is a word.
Always.
Okay, got it.
Because maximum value word is 65,000.
Too much already.
So it's too big already the value. So why I want to take?
Okay.
Okay.
Okay, got it.
Got it?
AI always. A is always a word.
Yes, okay. Then go to show all tag. Okay. So you add these two words, actual speed and the speed word.
Speed.
Speed word. So you check the address is correct or not. Okay. This actual speed is IW258.
Okay.
Okay. Now you go back to the where is it? Siemens. Okay. Click here. Close this. Okay. Now you do the scaling. So this is you put the feedback. The name here. No, here. Put feedback, and this one is the current speed. Okay. Here is the current speed. Okay. So the feedback is what?
Feedback speed is something.
Oh, sorry. Set point.
Set point, okay.
Maybe the first one set point. Yeah. Okay. Now set point. I want to set in my SCADA.
Right.
Correct. Do we just now we created the tag in the SCADA, right?
Yes, you use a tag.
Okay. Now what do I do? Okay. Now man, just put double click. You click here. click on the SCADA TV. Yes. Then choose which one. VFD set point RPM. Yeah. Yes, click that first.
Okay.
Enter. This is similar to I'm using a MW0. Okay, but this one don't have address, right? The DB address. Okay, if I want to know the DB address, if I want to create a DB address, what I need to do is go to SCADA, right click the SCADA, property. Okay, under the attributes, optimize the block access. Means I don't want to optimize, means anyone can access.
Okay.
So if anyone can access means I need a DB address. If I optimize means only the Siemens only can access. Within the Siemens only can access. Actually, for now, we don't need to do so. Okay, but I will do this. Okay, click this, click OK. Click OK. Go back to the dynamic control. Now can see DB1. Okay, question mark because I haven't compiled. You right click the SCADA. Compile. Whatever I add in the SCADA, I need to compile. Okay, this one can bring it down.
This DB1 dot something is a Siemens language.
Go down.
Okay.
No, this one go down. Fully go down. DB1.dbw. Why? Because it's an integer. Similar to MW0. Okay? I can use this DB1, DBW0 or MW0. Both are same only. Only difference is DB means can retain value. Memory can retain value. When I reset the memory value, when I do resetting, right, the memory value becomes 0. The DB value can keep the value.
Reset mean to say in the PLC.
The memory, yes, reset button. Yes.
Okay. And it will not retain the value.
Yes. Or if I download new project, not download new project. Okay, I do some modification and I download. So what happens? Sometimes the memory value becomes 0, but the DB value still will keep the value.
Okay.
That is the difference. Okay.
Okay.
Now you do 0 to 1310, right? The RPM. Put the minimum and maximum.
So this is a
0 minimum. Then the RPM for the motor actually yesterday we see 1310.
okay. So we follow this up 1310. So we will key in the RPM value. Okay.
Okay. Now the output. Here I can use the MD. Also can use, or since this is a FC, right? FC also have a temporary, right? I can use a temporary tag. I can use the temporary tag also. You see, this one don't have static tag. Okay. The FC don't have static tag.
You mean I don't have to create a memory, just give a name here.
Give a name norm X, norm X1 and norm X2. Norm X2. And both make it real.
This is in my F. This is actually in my FC1.
FC1, yes. I just use temporary data.
This is a view.
Real. Okay. Can you close this? Okay. Now we put it in norm X1. Then this is 0. Okay.
1310.
No. This is your. Okay, you put it here, the actual speed, then you can understand. You put here first. So this value I convert to the speed word.
Yes.
QW25. Okay, what is the value of QW258? You read it? No. Right click read it. People. I think you only define this, and this. Other two we haven't defined one. We try to go and define to other places. Maybe the address wrong, is it? Okay, then I think go here. QW. You're wrong. This one is correct. Actual speed is correct. This one is supposed to be 8. Wait. No. Wait.
This one did it.
Yes, you delete the whole thing. Then this one change the name. The one you take out.
Okay. So this is already.
Okay. So what is the value?
The hash.
So it's up to you. You want to use the 16824 or 4000.
Okay.
We want to use 4000. 16 hashtag 4000. No, why? No bracket. No bracket. I put bracket here because I want to show that.
Oh, okay.
What is
Okay,
that?
just 16 hash 4000.
Yes.
Okay.
Because if you put 4000, what happened? It will read as a decimal, which is not correct value.
Okay.
Now go down. Okay, here. Here is the current speed. The current speed is?
Current speed is a feedback, so it's a 4000.
Yes. The IW258 16 hashtag 4000. Okay, here. Actually here you can put 16 hashtag 0 also can, 0 also can.
Okay.
Because extra 0 and decimal 0 are same.
Same thing.
Yes.
Okay.
This one is the IW258.
258. Okay.
Oh, sorry. 16. No, this one correct. This one is 16. 384.
Oh, okay.
This one is Normax 2. No. This one is for the SCADA one.
Oh,
SCADA
it's a
feedback. SCADA feedback.
I choose the SCADA first.
Yes.
Okay. Feedback. Okay. So it automatically name this to db1.db2.
Yes.
You see question. This norm X here. Can it be also named to be something like
In the DB.
Yeah, this is a function. This is a
FC.
oh, this is not a function block. There's no function block here.
No function block.
Okay, so there's nothing here.
What nothing here?
I mean no DB here, no DB here.
No need DB.
No need
Actually,
DB.
even the function block also no need DB. Okay, you don't confuse. Okay.
Because this one, let's say
This one also same thing only. I'm using the time value one. It's a temporary only one. It's the same thing.
okay, because
This is just inside the block.
I know. Yeah, because I try to say this one. When you convert this, it can give a sort of a address to it already.
Yes.
Now it has an address.
Yes,
For
yes.
db1.dbw0.
Yes. Yes.
What can have address? What cannot have address?
Okay.
Normax is a temporary. Is it temporary?
Yeah, it's a temporary.
Okay, it's a temporary. So
Yes.
it cannot have an address. Only static can have address. Only memory static can have address.
Okay, you're correct. Memory can have address. Static is, this is a global DB static.
Global DB.
The
static.
DB lah. We talk
Yeah.
about DB. Okay.
Yeah.
This one here, I I can use the temporary, the internal tag, the local variable, a very simple term.
Yeah.
I can use a local variable, I can
Yeah.
use a memory, I can create a DB for that also can.
Yeah, but now we are using
temporary.
temporary, so there is
No
no
need.
tag. No need tag.
No need,
Okay.
okay. Why? Actually, I don't need memory because I don't want to waste my memory.
Right.
I don't need a global DB
Got it.
because I'm not going to use this value
Not going
to
to
somewhere
save it
else.
for something. Yeah.
Yes.
Okay.
This is just to transfer from here to here. So that's why I just do it. I put as a temporary.
Okay.
Okay, good.
Fine. Okay.
Good. Now go down. Okay. Now here. Okay. We just do this for all this for a simple program. Okay. What we do? We go to show on tag. Okay. The start we already done. Okay. Okay. You put here. Start forward. Here. Okay. Start forward. Okay. Enter. Make it boolean. Okay. Then you put IW 0.1. So is it IW I 0.1. I 0.1.
I 0.1.
Yeah. I also too confused. I 0.1.
Oh.
It's a boolean. Push button. Push button.
Okay, the push button.
Yes. Okay. Then you put start backward, stop, reset. Just follow lah, just follow. Stop, reset. No, stop only.
Okay.
Another button is reset. Okay.
Okay.
So we can use the second button, third, fourth, fifth.
Okay.
Okay.
Yeah.
2, 3, 4, 5. Okay. Now go back to the dynamic control. We just do a simple program. That is, okay, when I start, what happen? I put normally open. Then start forward this one, 0.1. Okay. Then use a move function. Move. Okay. Actually, if you know what is the move name, no, move is here in the other. Okay. Okay. Wait. Don't take. If you know this name, what to use move. Okay, if you know already, actually you can use the empty box. You put the empty box, just type in move.
Oh.
Also okay. Just
Like
MOVE.
you automatically search for the function block.
Yes.
Oh,
Okay.
faster.
Yes. Okay, you put 16 hashtag 4F. This value. 16 hashtag 4F. Sorry, 47F. 47F. Okay. So where I need to transfer? Control word, right?
Yes.
Okay, put control word. QW256. Okay. Enter. Okay. Now you just copy this block. Just copy paste. Copy paste. There is a copy. Okay, paste that. No, paste here. Then only paste below. Okay. Now this one change to start backward. Okay. Then C7F. You click network for paste. You do the same thing for the stop and reset. F 472, okay, and this one is the reset. This one is a 4FE. Wrong. 16 hashtag.
Oh, okay.
Yeah. just basic controller, just on and off everything. Okay. If you want to do something like programming, like when I start run, okay. So means when I start, I just move this value to here, okay. Then do some what timer everything. When I want to stop, I just move the value on the stop. Where is the stop here? Just move the stop. Okay. Or you identify which bit is to on and off. Just now we discussed like the Q, some bit, right? Then you choose that particular bit. Then you use like a normal motor on and off.
Okay, question. This QW256, this is the one going to the
Right. Yes.
Yeah. In default, when we just start the PLC, initiate the PLC, it is 0 inside.
Yes.
It's 0 inside.
Yes.
So it's giving him a signal.
Initially it's a 0, right?
Yeah.
What you have to do, you have to send the stop signal first.
So I have to define the default value is the stop signal.
No need.
No need. But anyhow, if it receives 0, it will not do anything also.
Won't
Because
do
you
it.
don't understand what is it.
0 means because not all the bit on one.
Oh, okay.
Why I tell you put the stop first, you press stop first means when I press stop, some of the bit is already on, means is like standby, on, ready to run, all that will be on. Then when you send the start value, only one of the bit will going to change, it become 1. Then you can forward.
Okay.
If you send a backward value, means everything is same thing, like your start, one of the value called set point invert, that one become 1, that particular bit.
Okay. Okay.
What you mean is correct, just sending values only.
Okay.
You download
anyhow, this one will work. Yeah, initiate, you will not do anything.
Yes.
Yeah.
Okay, now you download the program.
Oh.
Download. Before that, you go to main.
Oh, because this is a queue. Okay.
Okay, go to main.
Me. Okay.
You call the dynamic control block. The FC, put it down, and only can go.
Okay. This is.
Okay?
Okay.
Okay.
Yes.
Download. Okay.
Okay. So monitor. Always running. Go to the dynamic control. Monitor. So
Okay.
nothing is push.
Thing is push. Okay. First you go up. Okay, go up. Okay. You put the value first.
Set point value.
Set point value first.
So I can change it.
Yeah.
Modify the value to 500.
Okay.
So,
Okay. So you send some value to this, right?
Okay. Now he received my set
You
point.
see, right? But it's in error, right?
Yeah, it's blinking fault.
Okay, fault. Okay, I'll tell you what is the fault. Okay, go down. Go down. Here, go down. Go down to the drive. You click on the drive, go online. No. Click on the drive, go online.
Oh, you have the online.
Then only we can know what is the error.
Oh, you mean when we do online? And
Open
online
this.
is a single device by single device, not all together.
No, because you just click the PLC download means it's your online PLC.
Okay.
Okay, you go down.
Go down.
Open the drive, online and diagnostic.
Oh.
Okay, but I think so the error will go. Okay, go to diagnostic, active alarm. No alarm. Okay. Currently no alarm. I mean the set point timeout means that when you download the new program, there's no value in your set point just now. Means there's no value in IW258 because zero right initially, and just now only you create 500.
Yeah.
That's why the error. Okay. Now what you do? You reset.
Give a reset.
Give a reset signal. So
So
start
1, 2, 3,
forward,
4.
backward, stop, reset. Okay. You reset.
And then we observe here. This 1, 2, 3, 4. This is the one.
Reset already.
Okay.
Okay. No active alarm. Okay. Okay. Now you go back to the dynamic control. Dynamic control. FC. Okay. Now currently what value? Go down. 1278. Okay. Because it's showing in decimal lah. That's why. Okay. Now you press start.
Start
Forward.
button.
Forward. Yeah.
Okay. Oh, not latch. Okay.
It's not latching.
Even not latch.
No, because you already moved this value to here.
Ah.
So it will always this value until someone moves some value to here.
Okay, so the new value already stored inside.
Yes.
Okay. Okay.
Unless you do some programming lah. Okay, it's like always go there. This is just a simple one.
Okay.
This
It
is
received. It always stored inside already.
yes. This is considered input 1 coin, something like that.
Got it.
Okay.
Okay. Got it. So now it's running.
Yes.
So this one F move the signal to Q. Q
Yes.
is always giving out already. I stop it.
Yeah. No, you just stop. That is backward.
Oh, you can directly change from forward to backward.
Yeah, because it's at one time only one value you send, right? That's why it's changed.
Okay, but it's not good. Okay.
Yeah.
Stop is on 3.
Yes.
Okay, get it.
Okay, got it?
Yes.
So if you want to do like programming, then you do the programming like when I start, I move this value and this.
Then I have to look at the manual.
Yes.
Okay.
Okay, good.
Good. This is good. This is good.
It
Yeah.
is good. Okay, now what we do? Okay, you add all the DB just now we created. Okay, you go offline. You go up. Go down. There is one the start forward. Okay, you add a branch. Now we open and close the branch. No, close the branch.
Oh, close the branch. This one.
Yep. Okay. Here you put the SCADA start forward. Okay. Similar to we use the memory, then the memory we use in the HMI. Correct?
Yes.
Okay.
Yes.
Same thing you do for others. Because we want to do this SCADA. Then I want to you can create two network. I mean just now the Profinet, right? You can create. But make sure that PLC have 2 PN.
2 PM.
Yes. Okay, save first. Okay, can you come here? I show you.
Okay.
So I selected 2 p.m. Okay, so if 2 p.m. means so
This is a PLC.
yes, this is the PLC, just a CPU only lah.
Okay.
So can you see it shows one is X1, one is X2.
Okay.
This two is like a switch. Okay, but if you see this one, this is one port, this is one port. Okay, so what I did is, can you see? This one is 192.168.11. This one is 192.168.01. Different subnet. Then this one under the 11. Sorry, 11 lah, 12 right? And this one is
0.
the 01 in the another Profinet.
So it means one PLC can controlling
Like two subnet.
devices from different subnet.
Yes.
Not necessary it can control one subnet only.
Yes, but make sure
provided that
have 2 PN.
only this model can have this function.
Yes. So if unless not this model, like this model. Let me see. 3 PNDP. 3 PNDP.
Something with 2 PN.
3 PN means 2 Profinet, 1 DP. So if this one can have 3 network. 2 Profinet network, 1 Profibus network. And this one 4 DP. 4 DP I think. This one have 3 Profinet network, 1 DP.
Interesting. Okay, I get your point. So if we choose the right order,
Yes.
2 PN, 3 PN,
Yes.
you really can have. So that green cable, that green one is really the name of the subnet lah.
Yeah.
The name of the subnet.
But this one also when you, but everything must see properly. Okay. You see here, it shows 4 interface, right? This one. The first interface is a Profinet. Okay.
Name of the interface. Okay.
Yeah. First, you've got four communication.
Mm.
Okay. First one is a Profinet. Second, Ethernet. Also is a Profinet. Third one is not a Profinet. It's just a gigabyte Ethernet. So I don't think so much you can use as a Profinet. Maybe you can use as a Modbus. Okay. Then fourth one is the Profibus.
So it's the name, the correct terminology is name of the Profinet.
Yes, must if that particular port support Profinet, then it's Profinet.
Okay.
That's why just now when we add,
Name of the interface.
yeah,
Okay.
that's why when just now we add, it's not a Profinet module, just an Ethernet module, right?
I cannot force it.
Cannot make it as a Profinet interface.
Got this one. Okay, now it's clear already.
Okay.
It's very clear. Alright. So one PLC can have multiple interface working together,
Yes.
including even you have 2 different Profinet interface.
Yes, right.
Okay. Okay.
Alright.
Okay. So now it's
Done. Okay, now you go offline. Save first.
Okay.
Really, yeah, save and download the PLC program.
Okay.
DFT. Yeah. No. What I want to do? No. Go offline. Okay. Now PLC is on. Okay. Now I want to add a SCADA. Click here. Just leave it open PLC. But if you close also nothing happen lah. Nothing. Okay. But why I go offline? I need to go offline. Then only I can do the communication. Okay. Okay. Add new device.
Device. Okay.
PC system. Okay, so if you're using the industrial PC, must have the Siemens one lah. Okay, SIMATIC one. Okay,
These are the server.
the Siemens one. Okay, but now I want to use our laptop, right?
Yeah.
So we can use the PC general, okay, PC station. Is it okay?
Okay. So this is the new device here. Okay.
And the others all the Siemens device lah.
So this is others. Everything is if you buy a dedicated server. from
Siemens, yes, Siemens. This one is an embedded controller.
Okay.
All that.
Okay.
Okay. For this, I add a communication module. So between my PC and my PLC is Profinet, right?
Yes.
Okay, choose Profinet. Okay. This one is all special Ethernet modules. Okay, but now we are using our normal laptop. Correct. Normal laptop, the normal Ethernet port, the built-in Ethernet port. Correct. Okay. I just choose the IE general. If you're using the Siemens PC, they of course they will use their own Ethernet port. Okay. Now the HMI application, you go to the application. Yes. Now, actually got runtime advanced and professional. Runtime advanced is the same thing like SCADA, but is have less components. Okay. Professional is the SCADA. Okay, both actually need to do in the PC only. But we try this professional first, because when professional, sometimes we do one button and try to open, because what happens, sometimes got error, sometimes it will just hang. Professional. We try first, it cannot be used the runtime advanced.
Okay.
Because both are same only. Okay. So just add a runtime professional. Yeah. Double click. Double click. Because if runtime advanced, only within it will open the run screen within this here only. If one WinCC professional, it will open another, they call WinCC runtime.
Okay.
But never mind, we try this first.
So this one added here, essentially it is not a hardware, it's a software.
Yes.
Okay.
It's just we are adding the runtime. Okay. Now go back to here. Just connect to the network. My network. Okay. Now close this one. Go to HMI runtime.
Yes.
Yes.
What is our PC?
Okay, go to screens. Screens.
I have a quick question. It's not a very deep one, just like imagining is a cloud system.
What is it?
Cloud system.
Cloud. Okay.
What is the possibility of doing this? Let's say PLC, everything is inside the factory, right? Probably I have a data center to store the server rack and everything. My WinCC RT, I keep there.
Okay.
Not necessarily to be next to the factory. It
Okay.
can be
Okay.
it can be somewhere at the Iskandar, but my factory is here.
Okay.
Yeah, it's a different place, or it's in the headquarters, something
Okay.
like this.
Okay. I understand.
So communication, I know that's going to the networking already,
Yes,
it's going
yes.
to the networking, but it's definitely is possible to do. Definitely is possible to do. So it is not directly, it's not directly using
Connected.
this.
Yes.
It
Yes.
is not directly using a physical cable.
Yes. Correct.
Okay, maybe that's too much already. So probably the TR bottle
I know what
have an
is
interface. Yeah, I'm just wondering how it looks like.
how it goes. Okay, I show you. I just later I show you. Just one I will show that, then you can understand.
Okay, got it. Yeah. Okay.
Okay, go to screen first. I show that, no, screen. Add new screen. Double click.
So very sure thing is runtime you can install on any computer as
Yes.
long as it's good enough.
Yes, it's
install
a
it.
professional, WinCC professional, yes.
Okay.
Okay, you remember that day we do the HMI, right?
Mm.
Same thing, you see? Only different is addition and extra, you know,
Buttons
extra
and so on.
objects lah,
Yeah,
that's
okay,
all.
okay.
Even the runtime advanced also similar, but a bit less, like it's piping all you cannot see.
Got it.
Okay, now go to runtime setting. What I want to do, I just okay. Oh, go to screens. I want to make sure I don't okay, all these settings you can use now. Okay, close. Disable function. Okay, I don't want full screen. Okay, never mind. Okay, now I go to screen.
Mm.
Let me just go to screen here.
Right. Delete this one.
Never, don't delete. Later we can use. Screen one.
Okay.
Now that's good. What you do, you take this one. Yeah, just take and put it here. Okay.
Display switch.
Yes. Double click. Property is here. You just bring it up. Okay. Tag. I hope you remember that they all use PLC tags.
Mm.
Then we go and choose start HMI, stop HMI, timer input, everything, right?
Yes.
But go up. Now our SCADA, whatever you want to put in SCADA, where is it?
In a TV.
So go to program block, SCADA DB.
Okay. Yes.
You make it bigger, this one,
Okay.
and you can clearly can see. Yes. Set point. Okay. In out. Okay. This digital don't care. Just leave it this one enough. I want to test whether it's working or not.
Okay.
Software. Save. Okay. Now what you do? So I scan.
Runtime here.
I scan this one cannot work. It cannot work. That's why.
So I have to use the advanced.
This one works. Is it okay?
Okay. So we delete the runtime software.
Why cannot? Okay, don't save. We try first.
Okay.
You right click. That's the problem. Actually, mine is not working. Something is missing. Right click. No. Okay. Okay, no, not here. You click here. Just click here again. Go to online. No, not right click. Just click again. Simulation. You go to simulation.
Oh.
Okay, start. Wait, please uncut, but there is no access of the. You click here, something is happening. No, I want to see the message. Okay, something is missing here. Okay, now mind. You delete this one. Use the advanced. Okay?
Okay.
Use the advanced, yes.
Delete.
You go back to the div. Okay. Go down. Double click here. Then you use the advanced. Next, go here. Screens. Add new screen. You see the difference here.
So less item here.
Less item. That's the difference. Okay.
Okay.
Okay. You click close here first. go to runtime setting. I want to off the full screen. I don't want full screen. Because later it will become a full screen. You go to screen 1. Same thing, you put this one, and you see this design is different. Can you see? Right?
Oh, you mean the graphic design?
Graphic design with different compared to SCADA. SCADA will have like a very basic graphics.
Okay.
Graphics not like very like high-end graphics, 3D graphics. They got, but they more do like simple graphics.
Okay.
Because if you put more high-end graphics on the memory will become big. So it might slow down your system. That's why sometimes you see SCADA, your HMI graphic sometimes is very nice. But in the SCADA, like more to, we have graphics, but more to basic graphics only.
You mean from the PC?
No, that one you
the
can
PC.
have all the graphics you have.
But you say which one cannot have all the graphics?
No, I mean what I mean is, it's SCADA is more to like, if you have like this, right, like a simple number, a simple without a border, everything. But you can make it, you can design also like a border, everything. Okay, why? Because in SCADA we do a lot of graphics there.
Right.
So when each graphic is high resolution, will occupy the space.
I mean, this is something that I always want to know. Because I've seen many types of SCADA, right? Some of the SCADA design, to be honest, very, very beautifully.
Yes.
With like very real life. Some of it is so ugly, can be so basic also.
So basic, yes.
Yeah.
It's depend on the software.
And yeah, okay, depends on the software. And also, some of it function very, very fast. You can do a very fast control. Click, change, click, everything goes very fast. Some of it, you click one time,
It takes some time
you wait for a few seconds,
Yes.
down here, refresh. Then you click it,
Yes.
refresh. Then you key in something, tuck, and then something very, very slow. It can be this kind of
on the
difference.
software.
It's, the main difference is what? Software.
The software.
Software, you mean the runtime.
The WinCC or whatever or Aveva.
It's like some have faster speed, some have
Some
slower.
of the faster refresh rate, some is the slow refresh rate.
Is it something that you can set or not? Because you say it's a software as well. If you think about this way,
sure. But
you
should
use a very
can be.
powerful PC.
Yeah, of course, that's why they use powerful PC.
Then normally this is not the case already. Unless really, I don't know lah. Is it the main, usually the main problem is
And also,
really they buy a
the
very low
communication.
spec computer.
no, not that. And also the communication protocol they use.
Protocol.
Yes. Okay. Let's say I have example. I have WinCC SCADA. This WinCC SCADA controlling Siemens S7-1500. All my devices are connected using Profinet. This WinCC SCADA is connected to S7-300 using 1500 using Profibus. So Profinet and Profibus, the speed is different. Slightly different.
Okay, one possibility is they are really using a Profibus.
Profibus or that one, or sometimes they use OPC.
OPC is faster, so there's a good point.
That one also, OPC also, is depend on what type of communication you're using. Still the communication is there. Because if you ask me, OPC will be slightly slower compared to direct Ethernet. Because if I let's say I'm using Profinet, I have this SCADA is talking to my PLC, this PLC sending Profinet data. It's just direct. Okay? If I use OPC, this SCADA connected to the OPC. OPC is connected to the PLC.
Yes.
So OPC to PLC is one connection. Let's say it's still Ethernet connection. So still we have a small delay compared to the direct Profinet.
I think I get what you're saying. I just wondering, do you think there's something like you can paint it?
Paid.
No, paint.
Ping.
Yeah, just try to see. I mean, in the real life, just like try to you have solo SCADA. You try to find out what is the problem. Is it the problem is the networking is slow, or is it problem is whoever designed SCADA, he not experienced that he make the SCADA very heavy and slow to run.
Yeah, that one I also don't.
Yeah, so it's like anyone would like, oh, I try to ping the SCADA server. Oh, the speed fast, and it's a SCADA designer's problem.
Yeah.
Oh, the ping the server is very slow. For 2 seconds come back, then it's not the SCADA design problem.
It's
It's the network problem, yeah, communication problem. But okay, anyhow, yeah. We have something here.
Okay, done.
Yeah.
Okay, we test this first. You right click. You save first. I think this one can save. Yeah. This one can save and so okay lah. You right click then start runtime.
Start runtime, okay.
That's why just now on the WinCC something problem. No. This one is a set point or what?
I think I choose the feedback.
Okay, never mind. You put it here, you go here. Go here, go to runtime. You press start. You press forward. Start forward. Yeah, because it's a backward.
Oh,
That one can change direction, no problem. Okay, can?
okay. But it somehow is displaying this. This is not a display. It let you somehow. It looks like a key, an input box.
Yeah, because you didn't choose output only.
Oh, okay.
Go to screen.
Oh, I have to choose output box. Okay, something like this.
Okay.
Yeah, so then it will be.
Then never mind. What we do, you just put a start button, start, stop. Start forward, start backward.
Button.
Yeah. Take a button.
This is a button.
Yes, you put it here. Okay, you do one design first. You put start. You go to event. Okay, this event I just press release or this right. If it is WinCC professional, this one will have a mouse right click, mouse left click or then left.
Okay.
Okay, you just put press.
Where's this one?
Press also can, click also can. But if because it's a
Oh,
push button.
one is a press in, and then you
Release.
have to release somehow.
Because I want to do like a push button right.
Okay.
Okay, click here. Just set bit. Right? Just key in set bit. Okay.
Set it.
Okay, then here you choose from the DB. DB. No. Cannot. You must choose first. No, the other one is program block. SCADA DB. Okay, start forward. Okay. Then release reset bit. Yeah, put reset bit. Okay. Start forward, yeah. Forward. See? Okay. Just copy paste. Just change the tagging only. No, this one is change the name, start forward. Okay. Okay. Then for start backward, then you choose the. So you do same thing for the. No, cannot.
You always have
First time you need to do. Second time, now you can type because why?
You already found it. You already transfer it to here.
Transfer to the HMI tag.
Oh.
First, because our HMI tag is always empty one.
Okay. Okay, now we have this already.
Okay, start for, I don't know, we do a proper project. Start, stop, reset, stop and reset. Then later we do alarm and trending also. Okay, done?
Okay.
Okay. Now this value you take and put it here. Okay. Then you add another one. Or maybe copy paste also. Apa nama? Okay. This one go to property. This one is the set point. No, you must choose. Yes, okay. This one input, output. Choose input.
Or into output.
Yes. Because then only can see and at the same time can change the value. Okay. One is put the name, one is set point, one is the feedback.
Okay.
Here.
You mean key here?
I mean the name. Attack. The comment. Set point. Okay. Yes. One is the feedback.
Okay.
Now, save. Now, now, you ask me that is this one is in a different place, my PLC is in different place. What to do? Correct.
Yes.
Go to connection. So this HMI connection is when we do the linking, right? This one come out like correct. Okay. And when I do the tagging, go to the tag HMI tags. Show all tag. So whenever I add from the DB, okay, shows that okay, this is the connection, correct?
Yes.
Okay. Now go to connection here. Okay.
This HMI connection, this name here is our interface, right?
Is our interface, the
That is the
communication,
one from
the PLC and the HMI communication. Okay. Okay. That's it. All this is from here. There's one data from one cloud server or something. Okay.
Yeah, that's good one. Yes.
Okay. Go to connection. I need to add another connection. Same thing. If let's say I have 10 PLC to monitor all the PLC again. Okay. Since this one is in the same file, when we do this linking,
Can Okay, this is the place, right?
Yeah, when we do the linking, right? Here.
If I go to the, okay, right.
Yes. When we do the linking, yes. So you
This
can
is the name, okay, but here it doesn't name the,
no, it's not, it won't use this name.
okay,
It will create its own connection. You go to connection, it will create its own name. The main, most important is the driver.
okay,
Communication driver at the station. Okay. Now you add new.
here,
Hmm.
okay,
Okay. The name I don't care. You go to the driver. Okay. What type of driver I have? 300, 400. Let's say it's from a different PLC, right? Okay, go up. Library, Mitsubishi, TCP, IP, Modicon, RTU, TCP, Omron, Osling. Okay. If a cloud, then I use OPC.
okay,
Yes. That's all. Then I need to select which OPC. Name of the OPC. You go to right.
go to,
I think, but you go to local server. I don't know what OPC in this chapter what I have. Wait. Okay. Let's say I have Capware OPC.
okay,
So here I select the Capware OPC everything. Then maybe that's all finish.
okay,
Okay, go down. Anything to click OK or what? Go down here. Full. Okay, that's all. Okay, so no more OPC. Okay, finish.
okay,
None. Now, of course lah, from the OPC, from the cloud service, I need to send the data to the OPC first. From the OPC, I can extract here. Okay. Now you go to tag. Show all tag. Okay, add new. But I have nothing in the OPC. Okay, you click here. Choose the second connection. Yes. So the data type is what? Boolean, date, or that. Okay, for example, Boolean.
how come it's not the Boolean as a, this BOL already, it's called ET dash Boolean?
Because of the what? It's a Capware. It's a OPC term, right?
Oh, this is a OPC term.
That's right. It's a
Okay,
variable.
okay.
Okay. Then, of course, then you need to do. You go back here. Go to right. Then I need to check the address. What address here? So what type of OPC I'm using? Everything. So first I need to add the OPC first lah. Into set up the OPC first.
Okay.
From the OPC, then I can select. Go ahead. Okay, then under the OPC, of course, we will have the tagging lah. But for now, don't have anything.
Okay,
We
okay.
haven't done anything. Okay, go here, Capware.
So,
Suppose if we configure the OPC, then we will have the device here. Then from the device, the particular tag we can choose.
got it. So I understand it. If it's a one-to-one, like let's say one SCADA runtime connect to one PLC, very straightforward. One to many PLC sounds to be the same way also.
No, you must add the multiple connection just now. In the connection here, right? You need to add
Yeah,
the multiple connections.
yeah. But I mean, we don't have example lah. We don't have example of. How I say this? I think I should go to say that this is a Siemens, right?
Mm-hmm.
Look at the level here. here, I have one thing I connect to the PLC already. Probably I have something, Modbus come straight to the SCADA.
Same thing. I cannot do anything here.
You cannot do anything
I cannot do
here.
anything here. You go down.
Or can you say these are Modbus can manual come straight to the PLC?
Can.
Actually.
Go down first. Everything under connection. You need to establish the connections first.
Okay.
Go to add another connection. Okay, choose Modbus.
Oh, should not.
Modbus TCP or RT.
Okay, let's say it's TCP right here.
Yes. Then it doesn't allow me to do this because I need to add another Ethernet. Because my current Ethernet is a Profinet.
Yes.
I already choose as a Profinet, it's a Profinet.
But I mean, so let's come back to the question. Can it bypass the PLC? Cannot. Let's say I know that, let's say that I have a device that I say it's a controller lah. For example, it's a controller for some mechanical equipment. It's a controller by itself. It can support Modbus. So you see, I have to control all this stuff, whatever program to run the mechanical equipment. I say it's a compressor lah.
Oh, okay, I know what you mean.
Yeah. Of course, I can connect to the PLC.
No, it's actually not a PLC problem here. Sorry, it's not a PLC problem.
Yeah.
It's my laptop.
Okay.
I already configured the port as a Profinet in the earlier this one, right? Now I choose Modbus, it will have a conflict.
But I mean, I still need to use this PLC
So
for
that's
other function.
that's why what they do. If it is all same network,
Yeah,
let's
all
say
in
all in the
yeah.
Profinet, right? Then my laptop go to one by one. Okay? If let's say the SCADA is one is Profinet, one is Modbus,
Yeah.
one is this one, one is the Profinet Modbus, let's say these two, or Profinet, Profibus, Modbus,
Right.
RTU, Modbus, TCP.
SCADA.
Okay, four right.
Yes.
So my laptop cannot read all these four protocols.
Okay, the laptop cannot read it.
What I do, all these four protocols go into one PLC, which can support all these protocols.
Just to translate on it.
Yes. That's why sometimes SCADA can communicate to all PLC or just one PLC.
Is it must be a PLC?
Yeah, of course PLC. Because if you go for DCS, then it's become DCS.
I know. I mean,
Because that is what DCS do.
the DCS what can it do is it can translate multiple.
Because the DCS controller can connect Modbus, can connect all these communications. Then from this controller go to your screen.
Yeah.
The same concept we use for SCADA also.
I know. I ask this because you are right. But in my last project, I've seen this case as in the controller, the mechanical equipment controller. Indeed, that one is report to the PLC first, then the PLC report to the SCADA.
Okay.
But there are also equipment like DPM. It's not going to any PLC. It's
Okay.
straight go to the SCADA also.
Okay, in that case, what
Yeah.
I can do, I can use like OPC. Okay? OPC, what I do, inside OPC, I can add multiple devices, different communications.
So the OPC is a translator here.
Yes, so OPC gather all the data from different devices, and then I send into my SCADA. In this case, I only add one PLC there.
OPC is a
open platform communication.
It needs a computer.
Of course, it's a software based.
It's a software.
It's a
based.
software. No need. It's not a hardware. It's a software.
So I mean, let's say we put this to an industrial application.
Okay, you can.
I mean,
Actually, we can try it here, but we cannot try it, but I can show you here. You delete these two first because I don't want to make it. I mean, the whole thing. Yeah.
okay, delete.
Delete. But just now you see how the OPC works, right?
Yeah. So just now, I think just now we say that it can only.
No, it can read the profile and also OPC can read. No, this one. Because OPC is not a protocol. OPC is still using your Ethernet port only. It's still an internet protocol lah.
Okay.
When you change into Modbus, then Modbus and Ethernet is totally different really. They have different language.
Okay.
That's why this one got conflict. Okay. If OPC, no problem. Okay, minimize this. Minimize the TI button. I think the OPC software is there. Okay, click here. Okay, cap server. This is one of the OPC software I commonly use.
This is our OPC software.
Yes, okay.
So the OPC is not I would say, it's a software. Anyone can have the software. Siemens can have an OPC software.
Yes, Siemens their own, so they also have OPC. Siemens OPC.
Okay, okay.
Okay, now here I can add the modules. Okay, there's one device here, right? It's already added that day. Okay. I mean, go to file new. Yes. Okay. Click to add channel. Okay. What channel? Just put one PLC.
Okay.
Go down, go down, go down.
Okay, so can I try this backnet?
Okay. Next. Channel 1 next. But I never used before. Next. No. Go back, go back, go back. Go back, go back. Normally adapter you need to choose your network adapter lah. Because from which one you connected. This one. Your Ethernet is 2 right? Your laptop Ethernet.
Okay. Choose.
Your laptop adapter. Okay, next. But of course like it won't show any value now. Okay, next. Next. Finish. Okay. Then click to add device. Okay, device 1. Okay, next. So I'm not sure about the backnet how it works. So it's add some ID number and everything. You choose the ID number. Okay. Next. 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 Okay, next. Next. Okay, I'm not sure how change of value. Okay, unconfirmed. Okay, so okay, next. Import the tag, right? So I need to import the tag. Okay, I'm next. Check format tag generation. Okay, next. Okay, this one you must get the data from the backnet lab. Okay.
Okay.
Next, then I finish.
Okay.
Then under the back device, okay, there is a text, right? So you right click here. No. You right click here. Import. So whatever the backnet something you have, right? You export all the tag. You can import here.
Okay.
Okay? Can?
Yes. Yes. Says if this is okay, if you say this so maybe the next one I add this PLC.
Yes.
This is
So you go to connectivity, new channel, Siemens. Go to S. Go down. Okay, Siemens display. Ethernet. Okay. 1002, 1005, 200, 300, okay, next. This is the IP address lah. You put the IP address. 255 is not. Just put some random IP address. 192.168.0.1. Zero. Okay, fine. I am okay. Next. But the settings all you must do a proper settings lah.
Okay.
Then here you can add the
So I export the DB in CSV, I come here, I import here.
Yes. Okay.
So that is my map already.
Here I do the mapping. Means
Okay.
because very simple. OPC is what? OPC is a server.
OPC is a server.
So your client is your SCADA and your PLC is the client.
Okay.
Okay. From one client I already, because that's why I said browsable by the clients. Okay. So one client setting I already done. I have two clients. Okay. Now I go back to the TI portal. Now I add OPC there again. You choose OPC.
PC.
Yeah. Then you choose the cap server from the local.
So
Yes. Let it search. Maybe let it search. Okay. Choose the cap server. Cap where? Okay. Finish. Then you go to the tag table. Show all tag table here. Yeah. Show on tag table. This one just not the OPC, right? This one we choose, right? Correct?
yeah.
Okay. And here, not here. Go back here. Go back. Go to here. Okay. Choose back the connection. Okay. Connection to Boolean, whatever lah. Okay. But this one need to explore lah. What is that? Okay. Go down. Go to next.
Go to the
Okay, here the tagging. Okay, the address. Click here. Okay, channel 1, device 1. Okay, here we have the tag, but for now don't have. You just click here. System. So here supposed to have all the tags. Whatever tag you imported.
I get your point. This is still within the SCADA.
Yes.
Okay, I get your point.
Okay.
I have a concept.
Okay, no, I know what you mean. Okay, this one you understand, right?
Yeah.
Okay, now the same OPC, you go there, go to the OPC. There's some data called like IoT gateway. This IoT gateway, I'm not an expert on this. These IoT gateways or MQTT is the one connecting to your cloud systems.
Okay.
So you need to do the setup everything from the cloud. You want to take one data from the cloud. Then same thing in the TI portal, just choose the OPC, choose the particular data type. You just need to know how to do the mapping.
Yes. I know what you say. Just that, yeah, how to do the mapping. Actually, it's a very big question here already. I mean, like, the concept is that, first, imagine I am the SCADA developer. I build the SCADA. And I say this, likely to be, I build the SCADA. I will not have any of the PLC program in it.
Yes, no need.
It's all separated, right?
PLC program you know it.
Yeah, I don't need. I only need to know that what is the requirement.
What communication I use?
Yeah.
What Okay.
communication I use, and what the list of I/O I want to control and display.
Yes.
Okay,
So
probably.
all will be import export only.
So yeah, import export only. So say in this way who build this DB this first, DB this. Probably from I just assume on it because I don't know. I assume there are some meeting, there are some communication. Say programmer and a SCADA developer and whatever, and there are so many different programs, right? I have a programmer 1, programmer 2, programmer 3, programmer 4, and so on. And I have someone is no programming but defining. There are 50 controller, there is a 60 DPM, there is whatever, all is outside of the PLC. All have to come to the SCADA. All have to come to SCADA. SCADA probably is a team or whatever. And then they have meeting. Okay, I agree with you. This is a list of I/O. You're going to display it. And you, this is a list. And you give me your list of device, and we are communicating through OPC.
Yes.
Yeah, OPC, and so on and so on. Then we have full master list already.
Yes.
This is a master list of
The
SCADA
communications you want to
communication.
use. Yes,
Yeah.
that's the most important.
Yes. Then this SCADA team, how to start? Because he don't have any file with him. He don't have any CSV with him now.
Yes.
He do not have.
So normally what they do,
Yeah.
they will do the design first.
They do the graphical design.
Yes.
Okay, finish already.
Finish ready because everything I need to give the tagging.
Okay.
Right. I need
Yes.
to give the taggings.
Yes.
So once done, once the graphic everything done, then I do the connections. Whatever connection I want to use.
You say you do the connection. At that point, you can't do, right? Why you can't do? Because you are simulating from the laptop. You are not at the site. The construction site is zero. There's nothing for you to
No,
simulate
okay.
at all.
If I want to do simulating, I don't need tag word.
Okay, so let's say that is a point I
I
assume
just simulate.
this is
I just what I do because normally SCADA will have a simulation just like to see button on or off. Lamp can change color or not. I can keep value around.
so says this is a WinCC tier portal. So the tier portal, when other people almost finish the work my graphical also design already. So we integrate the PLC will come in, this one come in, with all the communication
Yes.
set up already. Okay, this one, although we are not on site, we are using a Profinet. So this is a Profinet.
Yes.
Even the configuration, the address, all is set already.
Okay.
This is defined by us within the automation team. We have a IP address list, master list.
Okay.
Everything is correct. Even the devices, we have IP address set already. And we say all this is through the OPC. But OPC, that is a really big question. And then, okay, this OPC part is something that you cannot simulate. Program PLC you can simulate because it's within the tier portal. Right. OPC part.
Okay.
Then how you import the
Actually,
CSV?
what
and
you
everything?
want to simulate?
It's not that I want to simulate. It's like if
Okay, you are talking at what stage of this project? Is it
the
The
design
stage-
stage only. the
design stage
only.
okay? I'm not going to company. I haven't go to the
Yeah,
company.
you're designing.
Designing
you want to
stage.
finalize the data. Yeah.
Designing stage. I don't need any tag connections first because of course I won't get any tags connections.
Yeah, I mean you finish. Let's say it's a simple. I put it this way. It's a simple. You are integrating a tank farm. The tank.
Okay,
farm,
understand.
all this control. But you have some external controller to control special equipment. I say it's a special whatever special equipment. That one you need an external vendor.
Okay.
Yeah. That one they have to integrate to you.
Yes.
They give you. They say, oh, sorry, mine is not a Siemens, not so advanced. But I can give you a OPC.
Okay.
Now, or Modbus.
Modbus, yes.
Modbus also can. And then how do you want me to communicate to you? Then I say, oh, then you go to the OPC server lah. Let's discuss, or we say the final communication method is OPC. Okay, then I finalize the design.
Okay.
What is cannot be done is, let's say he said I have a 100 IO. Then I cannot say, oh, okay, fine. I will come to the site, then only a one by one add in one IO by one IO. Okay, do that also. You must be in the beginning, you already finalize it, all
Yes,
your
okay.
SCADA already addressed, or you have a 100 IO. You tell in advance your IO what is the address. You have a CSV file, and then this CSV
Yes,
file.
he give me the CSV file. I load that CSV file in my OPC.
But you say that your OPC, what it means by your OPC? Because the question is,
My OPC means the OPC I have in my laptop. That guy don't need OPC.
okay,
You
so the
understand?
OPC will be, okay, not the OPC, the CSV file will be following the SCADA file, following the,
It will be inside the same laptop.
will be inside the same, I mean inside the, I want to be exact, lah, inside the AP18 file. Inside
No.
No. Inside where?
Under your OPC file.
Because your OPC is
Now
not
we are
the one
talking
going
about-
to the field. Yeah.
Okay, you
Your,
see,
your field, your field whoever installed the new OPC, whatever lah.
I don't care that guy is a OPC or not. The most important thing you need to understand is, let's say it is a Mitsubishi. Okay, I don't have Profinet. I cannot directly communicate. Then I check Modbus. If Modbus I need to add module, I don't want Modbus. Okay, for example, we just simple, make it very simple. I have one PLC Siemens is using Profinet. If I have 10 PLC or one PLC, same thing.
No problem.
Okay.
All this no problem.
All this data I already get.
Mm.
You already give me the VB, everything done. Okay. Now, the other guy is a Mitsubishi. I cannot use Modbus.
Okay, as simple as that. Okay.
Okay, I only can use. Then I check which way I can use. Then I find out, okay, OPC can use.
Okay.
Okay.
That's a good example.
Now, I need to know whether my OPC can take data from that Mitsubishi PLC or not. Okay, that Mitsubishi PLC is using what communication? Using Ethernet communication or RS232 communication or RS422 communication. I know already. Then just now in the OPC I add the device, right? Once I add the device, I need to take the tagging, the Excel file. Okay, the Excel file I will import, right? He will send me the Excel file. Okay, it will be in my laptop. Then I open OPC, I load the Excel file to
So-
the OPC.
So when you say you open and load, this is to simulate.
Not simulate.
Okay.
No simulate. I need to load to my OPC. Once I load to the OPC, then only in the TI portal I can see the taggings.
Then you finalize your SCADA
Yes,
mapping. Okay.
mapping. Yes, which tag, which tag.
Okay. So and when I identify this is from Mitsubishi. So this communication is through OPC.
Yes,
And this is the address.
Yes.
I don't know how is whatever. Okay.
Yes.
Then I have a mapping finished already.
yes.
Okay. So I say up to this point, SCADA job finished,
Okay,
ready to deploy.
yes.
So the site start construction
Okay.
and finish everything. Okay. The server is installed, whatever is installed, the network is done, and then all the cable is already pulled.
Okay,
Then somebody go to install a runtime
okay,
on the server.
okay.
Yeah. And then he naturally he have to install the runtime here. He have to, I don't know how is the name here, copy paste the file and then just open the file or something like this.
Okay, let's say for example, we
Yeah.
work with TI portal.
Yeah,
Okay.
we work with TIA portal. Yeah.
TI portal, because you need to choose what software you install. You want to install just WinCC, SCADA,
Okay.
the professional version.
Right.
So you need to install in the server, that software.
Okay.
TI portal,
So the
WinCC,
yeah.
professional.
So the server install the TIA portal,
TI portal,
WinCC,
WinCC.
runtime install. Okay.
Install already.
Okay.
Okay.
Install already. Then what's the next
Yeah,
step?
okay. Then I have this file, this AP18 file.
Yes.
Because this AP18 file is the one carrying this WinCC runtime.
Yes.
These two. We just focus on this only. We don't care about the PLC.
The screen
The
file.
screen file.
Yeah.
I copy, I put it there.
So the runtime can open the file and run the file.
Runtime can open the file.
Okay.
No problem.
Okay.
Can run the file.
Yes.
It can get the Siemens PLC data, but Mitsubishi PLC data it won't get.
Right.
Why? Because that server don't have that OPC.
Yes, exactly.
So what I do, I need to install that OPC, the capware inside that server. Okay?
So you must use the capware because when you do the program.
Because
you are
when
using
I design,
capware.
I use capware.
So there is a point here. There is a point I don't know. Because you said OPC is a software
Yes,
based,
it's
right?
a software.
Is it something like so simple? It's a freeware, or
No,
professionally
not
people
freeware.
will choose for something is a reputable, or I must use a Siemens OPC.
Not like that.
Oh,
All the capware software is very simple, similar to your SCADA software. It means you buy the license. Means how many data, how many tag you want to use.
so it's something that come together, not to say come like when you design your SCADA, when actually it's right. When you design your whole SCADA, your whole system, you already have to think of what OPC you want to use already. Then we have to buy the software in advance. And when you're developing a SCADA, you have to use the OPC to develop together. So when you deploy on the site, you also install the
Actually,
OPC.
Siemens also they have their own OPC.
Okay.
But I never done before.
Okay.
If the Siemens, let's say we talk about OPC, Siemens OPC, let's say the Siemens OPC can take data from the Mitsubishi,
Okay.
then I don't need the capware.
Okay. Let's say that, okay, I say this is a Siemens. So you say that whatever is not from Profinet, is it true or cannot say that this also?
Just tell me.
Whatever is not from Profinet, you must use the OPC.
Not necessary. Okay.
Because
I need to know the other protocol is what protocol.
let's say it's more fast.
Then cannot. Because my laptop port, I have only one port, one Ethernet port. I already tell I want to use a Profinet system. So I cannot use Modbus.
I just try to think like, probably in the end, will it be the answer? The answer is, you want to be very simple architect, network
Yes,
architecture. Everything is, let's say it's a Siemens to Siemens. Everything just go to one PLC, monitoring PLC.
Yes.
That is the simplest
That's
way.
a bit simple thing. That's why sometimes they were what they do, like they use the 1005 at that point. 1005 or 400. Okay? Because I can connect to all the PLCs using Modbus, TCP, RTU, Profinet, Profibus, all that. You see just now the additional modules I can, communication modules I got so many. Ethernet. One is the Ethernet normal, just the Ethernet, it's not a Profinet, it's just a normal Ethernet. One is for, so that normal Ethernet protocol I can use as a Modbus. One is for LTE. One is for the GPRS, GSM module. So different communication protocol is available. So if let's say all in the same protocol, is very simple. All different protocols. So you must have one controller where I can get all the different protocol data here. Then I just no need to do, but this PLC no need to do any programming. Any logic. This PLC is just take the data, convert into a DB. Take data, convert into a DB. Then this all the DB go into one SCADA. That's the best one. Or there's two ways. One is using one centralized PC. One centralized PLC to read all type of data.
Yes.
Okay? Or you can have one OPC to read all kind of data.
Yes.
Yes. Then my SCADA only take data from the OPC only. So what happens in the OPC, I will have all the connectivity. One is the Siemens, one is Bradley, one is the Omron, one is the Modbus, all that.
Okay. Yeah. Yeah. I don't have anything with me because all is assumption also. Yeah. But I get what you say. Easiest way is if you have a lot of different protocol. Of course, let's say this is a Siemens.
Because then what if you want to test, we need to have all the protocols, then only we can test it.
Yeah, I get what you're
You need one PLC with Profibus, all these can support. Then, what protocol I can add? One device enough.
Yeah, of course we still saying it's a Siemens to WinCC lah. I say still Siemens because Siemens are most
you use that.
most people use lah. It will not be normally will not be other brand. But this WinCC not necessary.
Yes.
So let's say it's to other
Whatever.
brand.
Let's say you are using
One to
Arewa, the same thing only.
Then let's say Aviva also can choose. Then during the development of the Aviva, you have to decide, you have to know already.
First, when you do Arewa, the connection.
Yeah.
So, from which device you want to take data?
I know in my last project the network architecture like I say we have over, to be honest, there is over 70 PLC. Just go to many different switches. And in the end, all the switches connect, go to a core switch. One cable only. And this one go to the data center. But how does it go to the data center? That is the one I don't know. That's the one I don't know. I don't know if it's a physical big cable, fiber optic, or this is go to the cloud first, or can coming down. But I know that in the end,
It's very far, is it?
it's definitely the server is at the opposite factory.
Okay.
It's like not like next. It's not in the next room or whatever.
Okay.
It's quite far lah.
Okay.
But in the end, there's a cloud. There is a cloud server.
Okay.
Everyone opening the vSphere
Okay.
is through the cloud. So you can open it at home. You can open it anywhere.
Okay.
The question is, how they did this?
Okay. Good
Yeah.
question. Okay. Good question. Now, this is a factory.
Right.
In this factory, I need to have a computer there. Okay? A computer there.
Yeah, a server computer.
A
Yes.
server computer. And you set all the 70 PLC go to switch, and one master switch and connect here. Okay? Then what server what I'm using is similar. It's the same concept like the OPC. I mean the SCADA again. Okay? Let's say I'm using one cloud. Okay? That cloud, let's say because the last time I did before IBM cloud.
Okay.
It's a cloud. IBM. I did draw here using okay, because when you be using clouds, I'm not sure whether the cloud can directly connect to PLC. I'm not sure. Okay, but I know because very long time already I didn't do the cloud program. Okay. Now this is the cloud. Now I need to add a OPC here.
Must have a OPC.
It's depend on the cloud.
Okay.
Because I can't remember this one. But last time I did what I did is I used the IBM cloud connect to a data feed OPC. It's not a software name. OPC, and this OPC I connect to a Siemens PLC. I can connect to a one is using the LAN cable, this one is using the COM cable. Okay?
Com cable, what is the com cable?
RS232.
Oh, okay.
Okay? Then put RS232. RS232. This one is Ethernet, not.
So you write the data feed. So the OPC job, one of the main thing is everyone have to give him a S7-1200.
Yes, because of course you cannot type one by one the tagging, right?
So you have to import a file.
Yes.
Everyone.
Let's say this is the temperature control. Okay? Temperature controller are using the Modbus. Okay?
Okay.
All these go to the OPC. Okay? Then in the OPC, that's all finished. Now, open the cloud. In the cloud, it's the same thing like what you do here. Okay? When you open this, what you did, you add one device. The device is Modbus 485. Correct? Then you add another device that is Siemens PLC. Then you add another device that is Omron. What communication? RS232, Ethernet, TCP/IP. Okay? The same thing when you do here. So when I go to the cloud, in the cloud I need to add one connection. One connection from where? From the OPC. What OPC? This is the OPC.
I have a question. Let's say this side here, your interface is all Siemens, all Siemens PLC, nothing else. No Modbus, no nothing. And then left side,
It's the cloud.
no, it's an Aveva. I don't say it's an Aveva cloud or not cloud first.
Okay, it's a
It's just
SCADA.
not the PLC. It's not the PLC.
Okay, it's a SCADA.
It's a SCADA. So you have a list of PLC to connect to one SCADA non-WinCC.
Okay.
So in this is a simplified situation.
Okay. I understand.
Yeah, then only you need to give him is one single CSV file.
Okay. This go to the switch.
Okay.
Then this one go to the PLC1.
Yeah, this is a situation.
Two,
Let's say this is a situation.
PLC3.
Yes.
So just do the in the Aveva, I need to add all the PLC the connection. Like just now we do the connection, right?
In the
Yeah,
Aveva, when the people design the Aveva, he have to
Add all the PLCs.
configure. This is PLC1,
PLC1, PLC2, PLC3, what is the IP address, everything. When you do, then from there you can import.
and then he import all the CSV file.
All
PLC1, CSV file, PLC2, CSV file.
CSV file or DB file, depend on how they communicate, how they talk. It's not necessarily CSV file.
Not necessarily.
Yes, because why? When they design Aveva, they know that okay, this Siemens I want to take data. I want to take data from the DB only. So I must use the DB format. If this PLC only can Excel, so I can use Excel.
Let's say okay, so we have option. At least I know that we have option
Yes.
You can
But
use DB.
most common is CSV lah.
of CSV.
Not CSV. If it is different format, but each software they make sure that format is the PLC can support that format.
Got it.
Because sometimes it's AML format, .db, Siemens I will talk about Siemens, or CSV file,
CSV file is quite considered
common.
universal.
Yes,
Different
yes.
brands also can.
But the thing is, you don't no need to worry because when you talk about Aveva, they design that, okay, they know Siemens. Aveva know how to take data from the Siemens. So no need to worry.
So go to the next one. Let's say we're during developing SCADA Aveva. He designed, finished already, and then he based on this. This is a final, how to say, final DB file. This is a final DB file. I already match all the DB, this address to this button, this one to this display, and so on, all done already. and then go to the site when we deploy. There are changes, probably miscommunication. Probably this SCADA and this PLC have an update or something, he didn't tell him. There's a mismatch between
Yes.
the mapping.
Mismatch between the tagging, yes.
Right,
I know.
right. Then what
That one
happened? How to
common.
do? Yeah.
Okay, what you need to do is ask him to, because you already designed one, you can
Yeah.
change the design. Maybe he change only one or two tagging in the DB or add new DB. Because why this one happened, I know, because I have done the same, because the same concept for that HMI also.
Okay.
That HMI, you cannot directly connect. You must using DB. You export the DB, then in the HMI need to import the DB and use. If there are changes in the HMI, what I do, because I already designed my graphics. So I cannot go and change my graphics. Or I already mapped the taggings. What I do, I export again, I import again. So it will automatically update.
So that's the way lah.
Yes.
To update the SCADA mapping, you have to import a new
Import.
DB file or import a
Import
new.
again the DB file, then here, export the DB file from the PLC. From however, you need to import again the file. So whichever is the same name, it will automatically update. Anything new, it will become new.
Okay. Okay. Got
Okay.
it. At least got it. Yes.
Yes.
At least got it.
Now, in this case also, let's
Mm.
say the Awewa F cloud service, which you can, this SCADA you can load into the cloud, something. Then you can use the
Okay.
Awewa SCADA.
But that is on the SCADA side, like the pure SCADA. Networking is like this first. Yeah.
Yes, yes.
Okay.
Like, it's correct what you say. And because this is the issues you face, correct? Sometimes the can communicate data wrong. Can
Right,
have value.
right.
So this is the way. If there's a new version, because your PLC, very simple, like your SCADA, you program, the tag they give is version 2. But now the PLC become version 3. So the tag is not same anymore.
Right.
Because this problem will happen when the PLC are communicating using taggings. Because tagging is important. If I communicate using address, let's say, I take all the PLC tags. Because this PLC become tagging already, this Siemens. Let's say we talk about Mitsubishi. Okay? Mitsubishi no taggings. They running on address. So if they do any changes there, it won't mostly affect here.
Maybe this is the one I try to understand. Let's say using this diagram is a good diagram. From the PLC to the right hand side, is a few devices already.
Yes.
So a common documentation or common coordination file is IOLs, right? Because you see the IOLs, you know that go to which rack from which device, what one year, and so on and so on.
Yeah.
This is the IOLs here. From the PLC to the SCADA, what is a common engineering file? I don't know. People looking at this is for example, a mapping file, or there is no such thing. Nobody cares about
Not
this.
like that. You should have the mapping, the IO mappings lah.
Mapping.
Yes.
So the communication is the SCADA have to receive a mapping, or you have a PLC, you have an update for this IOLs whatever, because they have a change in update in program. Please update to me your latest mapping file or
Yes.
something like this.
Yes.
Which means it's the CSV file
Yes.
or it's the DB file.
It's your IO, your taggings lah, your tagging.
Tagging.
Yes.
And that file is a CSV. You pass to me, I will update into the SCADA. Then my SCADA, either I have to do a minor tweak on the graphic or do not. Then it will be updated.
Yes.
If you don't pass to me, whatever you change, you add a new temperature
temperature.
sensor or whatever. I will not see it. No matter how I do, I will not see it.
Yes, of
unless
course.
you give me a new file.
Yes. Unless you give me the files.
Okay, so the communication file is that mapping file.
That mapping file.
Mapping file is essentially is what is your communication method and what is the address, what is the data type. Do we, I think we go a little deep here. Do we have example of this file, or we can like we have a PLC program already, right? We can try export that because I know that we are saying that very easy. I'm not to say it's very easy. We are doing this quite fast because it's Siemens to Siemens. We save a lot of hassle here actually.
Yes.
But if it's
Actually,
not
you
the
can
Siemens
export.
to
You can
Siemens,
export.
then there's a
Go to PLC. Go to PLC program. Go.
PLC program.
Go. Scroll up. PLC. Okay. Then go to program block. Right click your SCADA.
Okay, this is a right click.
Generate source from blocks. The last one. On the left hand side, last one. Yes. Select block value. Okay, can you see? DB file.
Right, DB file.
The save as. Can you see?
Yeah.
Okay. Click save. Okay.
So let's say I've done this already, and then I have a
This file.
DB file here.
Yes.
So this file is the file to pass to the SCADA. Please update
Yes.
the DB file.
Yes.
And actually, I cannot can open with cannot open with.
Some PLCs right. You go to PLC tech. Yes, my left PLC tech. No, PLC tech. Okay, right click default tech table. Yeah. Export.
So it cannot export in
PLC tech.
no export
Excel.
in an Excel file or export in a CSV file.
No, check Excel. Because I don't DB file can export.
Okay, from the PLC, the TIA portal can read the DB file.
Yes.
However, I assume they can read the file so that they open the file, they can come out a table.
Yes. I can use this one. AML file.
But anyhow, so that is the mapping file.
That is mapping file. Sometimes what happen when you want to import something like, for example, this is right? Configuration. I need to create tag because I didn't choose the tag import. So the portal exporter file. If I want to import, I need to use this file. Okay. Okay. What I do? This is a different software. I need to install this software. I don't think so. It's an additional add-on software.
Okay.
You use that software, whatever, to export the tag using the AP version 18 file.
Okay.
You read the version 18 file, it will export.
Okay.
So it becomes a TPE file. Then here you just use the TPE file to import.
Okay. Or if you're using a OPC lah.
Same thing. Anything also same.
Okay.
Because you see, they know already. Okay, this SCADA, I want to communicate to, because I know like Alabama,
Okay.
they export in CSV file.
Okay. Their native file export is CSV.
CSV file.
Okay.
So what happens is, so when you do use Avewa, the Avewa know, because you already selected Alabama, right? So Avewa know, if I want to read any tag, must be in CSV file. So it will request for a CSV file. At the same time, the Avewa, when you choose this 1200, right,
then it will
it
request
know
for DB file.
DB file just or the TPE just now.
Yeah.
TPE file. It won't
Okay.
request for your CSV file.
Okay, got it.
Because Avewa know, Siemens cannot give TSV. Siemens can give the DB. Three files actually, if you ask me. One is the DB file, one is the TIA portal exporter, one is the version 18, TIA version 18, that file, the whole folder.
Okay, got it. Okay, so at least this is the format lah.
Yes.
How SCADA and PLC
They're
communicate.
talking to each other.
Yeah. through this file here, this mapping file.
Yes.
If you don't have this mapping file, then essentially you can communicate.
Yeah, cannot communicate. So you need to know how to create that mapping file, that file particularly. So like just now you said, we try to import is a TI portal tag importer
Right.
or tag exporter something, a tag exporter file, right?
Yes.
So my original TI portal don't have that. So you need to install the tag exporter. Let me see my laptop.
So if we have a like whole ecosystem is all using Siemens, it's very easy.
I don't have. Actually, this tag exporter you can download from the Siemens website.
Tag exporter.
Yes.
So if you mean this is a to convert this to some other format,
Yes.
like convert the DB file.
Not DB file, not especially DB file.
Okay.
Okay, DB means it's only DB.
Uh,
Tag exporter means it's the whole tag, the PLC tags.
okay. Okay. Got it.
Got it?
Got the concept. Okay.
Yeah.
Yeah. Okay.
That's the thing. Whatever, it's very simple. Whatever SCADA or device we use, we need to know how to communicate, what protocol I'm using, and from there, actually, whatever we see, right, this TPE file, all that, right, in the manual they have. So let's say you're working on CAPware OPC, okay?
Okay.
Download CAPware OPC, then you go to the Siemens one. Under Siemens, because CAPware OPC, they will give all the manuals they can find. Then they will show you how to do that as well. Then you go under the Siemens one, or maybe CAPware, they have different manuals. CAPware Siemens, CAPware and really different manual. Under Siemens, they have this 1002, 1005 all that. Then you go to the 1002. Then they will show you how to do the adding the device, everything, how to import everything.
Okay.
Sure, yes.
Okay. But this is the point. Generally,
Yeah.
we do. Not to say we generally, if the factory is only doing this simple SCADA to control PLC finish, you
Yes.
do not need a OPC by right now.
Right.
Because I understand, unless you want to integrate a lot of very advanced things, not to say advanced, but integrate a lot of different kind of systems, like
Yeah.
SAP, MES, then it needs a very complicated
Yes.
OPC. Yeah. Okay. Yeah.
You see, like I said, the Siemens, I mean the CAPware, and you go to click user menu, they click all the user menu. Just need to download which user menu you want to use.
Okay.
Everything here. Tag import, how to import the tag, everything is here.
But I think that OPC is more to be a
No. Why I tell you OPC is the what is it called? The concept is the same thing with your SCADA.
okay.
Only thing is OPC just take data from here and give here.
Yes.
SCADA is same thing. I take data and I display.
Yes.
It's the same concept. Similar to your HMI. HMI also same. I take data, I display.
Because maybe what I'm confused is not this. Let's say we go back to the first diagram. In the second diagram, Aviva is quite straightforward, right? Because it's a direct to PLC.
Yes.
So we already finalized and say that. Then the final answer is Aviva, you have to take or import different DB file.
Yes.
As long as you finish importing a DB file, you identify your communication.
Yes.
All are coming, the DB file all are coming through Profinet.
Yes.
We say Profinet.
Yes.
Then you cannot say Profinet, right? Or can say because this is not.
Let's say we talk about Siemens, yes, of course, it's Profinet.
Yeah, but because Aviva is not a Profinet, right?
No, it's not like that.
It's not like that.
Okay, it's still Profibus.
Still
Still Profinet. Why? When you go to Aviva, you choose Siemens.
Can choose Siemens Profinet.
Siemens
Or he
PLC, but
understand
it
the
won't
language.
tell Profinet. It will tell TCP.
Okay.
Like just now we do what?
Yes.
The OPC.
Okay, that long list, right?
Yeah, long list.
So
So when you do OPC just now, when you add the 1200, it didn't tell you Profinet, but it's tell you TCP.
Yeah, okay, I think that is the exact thing
Yes.
I'm trying to understand.
Yes.
So this SCADA Aviva, he understands a lot of language.
Yes.
And I chose Siemens Profinet.
Yes.
Then TCP, sorry. Then he immediately, okay, I understand this language.
Yes.
And from this language, these are all the DB file
Yes.
you associate to
Yes,
this
it's asking you to
language.
import, yes.
Yeah, import. So DB1, Siemens Profinet, DB2, Siemens Profinet, DB3, done. Then this
Okay, and in this case, you don't call Profinet.
you call TCP.
Just TCP only.
TCP.
Yes,
Yeah.
because why? It's not a Siemens. The
It's a
SCADA is not
common language.
Siemens.
Yeah.
You are not doing the networking.
Okay.
When you do networking, then only we call as a Profinet.
Yeah.
Because in WinCC, the SCADA, here we do the networking, the configuration.
Yeah.
So that's why we choose the same thing like TCP or Profinet, same thing. But we choose Profinet.
Okay.
But in Awewa, you are not doing the networking.
I got your point.
That's why they call just TCP. only.
Just TCP only.
Yes.
So now we expand a little bit. We say that Aviva not directly communicate to Siemens PLC. There is a middleman here, which is called OPC.
Yes.
And because the OPC, the function of OPC is translation. You talk to Siemens or you have a TCP Ethernet. I talk to him, you are Modbus guy. I talk to you, you are whatever. But in the end, I talk to multiple person. I will translate to one unified language.
Yes.
And I pass it to Aviva.
Yes, correct.
So Aviva, when he want to talk to OPC, he has to choose one language only.
Yes, only one.
And that is depending on what OPC software I am going to install.
Yes.
It can be a
Capware,
Capware.
data feed, or
data feed. There is a multiple software.
yes.
I don't know. I only know that the middleman will do the job.
Yes.
How we translate, I don't care.
Yes.
In the end, he will come up with to me is one file only.
Yes.
Okay, that is a part here. If there is a really OPC integration to do like this, somebody really have to take care of this work scope here.
Yes.
Yeah. Set up the OPC, PLC1, PLC2, Modbus, whatever, you have to feed to me, give me all the CSV file first,
Yes.
or DB file, or whatever
Yes.
file, parent ready file. And then I will do the conversion. I have to pass this file to the SCADA guy,
Yes.
so he can do the job.
Yes.
And very likely, this information not only to the SCADA, this information I have to pass to another IT server for
Yes.
his programming.
Yes.
I have to pass to him.
Yes.
So this is a what I see is this is a big scope here. It's not a
Yes.
small scope,
Yes.
and it's not a scope of automation. It's
Yeah.
it's a networking scope
It's a
already.
networking.
Somebody have to do this job here,
Yes.
and then it's consider if the SCADA is configured to fit from the OPC. If it's fit direct from the Siemens or from PLC, which is I see it's a simpler lah. I see it's
Yeah, of
simpler.
course.
If
Yeah,
fit
right.
from the OPC, there is a lot of things that the SCADA guy wouldn't know. You wouldn't know how he's going to translate. He cannot predict how is the final language will come out looks like what.
No, very simple.
Yeah.
Because you see, we're talking about data.
Yeah.
Data means it's a data type.
Yeah.
That's all. So for SCADA or display anything, I just need to know what data type. That's all.
There is a point here. So,
What protocol, I don't care.
so there's a
Actually,
question
it's
here.
not language, it's the protocol. We're talking about protocol.
I'm talking about both.
Yes.
Because you see, Modbus, Profinet, they are all different
Protocol.
protocol.
Yes.
They're talking in different language.
Yes, correct.
So I assume assume that I must use a OPC in the middle.
Okay.
So I want to do the SCADA.
Yes.
Can I finalize the SCADA without the OPC configuration? I don't know how the OPC going to translate whatever. But I will get you are either ready, you are PLC, you are Siemens, you are Modbus. You give me your DB file or you give me your CSV file. I do everything
I
here first.
cannot.
Can I do this first and then
Oh.
finally go to start deploy, or I just add a manually?
Oh, cannot.
Cannot also.
You must have the OPC first.
You must have the OPC first.
You must import all the data. Feed
From
the data to the
OPC.
OPC first. From
And
OPC
translate it
only,
first.
I take the taggings.
And then I import to the SCADA.
Import to the SCADA, then do the report.
So I cannot bypass him first. And
But I
say,
cannot bypass the.
Yeah, I assume first I
OPC.
use a
Yeah.
database file. I assume with a AML file. Cannot do that.
Cannot do that first.
Interesting.
You
Yeah,
need
that's, so
you
that's
need
the
the
mapping.
time.
Yeah.
Yes. Actually, in automation, if you ask me, the most difficult part is the networking.
Oh. Okay.
Sharing how we want to take data. In the end of the day, that is the most important part. It's not the
That's
controlling.
an interesting
Correct or not?
insight. But
Correct.
I agree that networking, I try to learn networking. Networking is not something, I mean, how to say, I see that in the future, the networking is going to be bigger and bigger. More
Yeah, of
and
course,
more.
bigger and bigger.
Yeah.
The thing is, but the concept is very simple. I have one device, I have another device. It can be PLC or something, this one can be your computer or server, anything. How they going to share data? That is the most important. So, what type of communication you want to use, what type of protocol you want to use.
Right, right.
That's all. Then how I'm going to take data. Actually got so many way to take data. Even like remote data I want to take. You can use the MQTT. So involving in software, everything.
If it's MQTT, how does it work?
Yeah. MQTT means it's like a
You add a card, right? MQTT card, right?
no, MQTT is a module.
Okay.
MQTT I don't have, I think don't have a card. It's a module. Then this MQTT, okay, is still the go back to the same concept. That is, this MQTT is similar to your OPC also. It means I mean this what they call not MQTT, it's a IoT gateway, IoT device. This IoT device still go back to the same concept like OPC. That is, this IoT where you connect Siemens. You choose Siemens, you connect. What data you want to take? Okay, you take the data, you keep here. Then MQTT is a software. Then I go to the software, I configure the software, then I tell, okay, this is the IoT device I want to extract the data. Then you just give all the IoT device the information needed for the MQTT. Then from the MQTT, where I want to pass. So whenever you do in the middle or something, right, everyone need to configure first. Because so many things, like for very simple example, PLC send data to your iPhone, for example. Okay. Let's say I want to use MQTT. So I need what? Just for your just to get the idea.
Right, right.
Okay, so can I get this? Okay, nah?
Oh, yeah.
For example, this is the PLC. Is connected to a IoT device. Okay, can be Siemens, can be different brand. Okay. This is the MQTT.
Okay.
Then from the MQTT I go to info. Now this one is just using the wireless signals, okay? Wireless. PLC just controlling your machine. Actually it's the same, everything is here, it's a similar concept. In the PLC you do networking for the machines. Networking is the mapping to the project.
The IoT lah, okay.
The IoTech lah, right?
Yes.
IoTech is considered like a networking, right?
Yes, yes.
You don't go to the networking, but just like I network, okay, you are sensor 1, you are sensor 2, you are stuff like that.
It's
So
actually
something like
networking work,
this
yeah.
is a similar concept. do that. Finish. And now this guy want to take data from here. So I need to configure this guy. Okay? Now this guy now want to take data from here. Then I configure this guy. Okay? Then my phone I want to take. So in this case what I do, here itself must have another software called node rate. Node rate. So what means, you see, PLC program done. That's why the programmer do. Okay, IoT, there's another guy come, or maybe the PLC guy, he know how to do this one. Okay. He configure this PLC, take all data, he keep. Then MQTT, I configure this one, from here I take data. Then in Node-RED, I configure the MQTT, from here I take data. Then in the phone, I configure the Node-RED, from here I take data.
Okay.
So that's it. If you able to take, then you can able to pass also. So you send here, this one send here, this one send here. So at the same time, want to control something, you send here. It's the same concept. Like the OPC, like the SCADA, all that same thing.
I get the point. High level concept is there, but go to on the ground, how to do this.
That's why I say all is based on configuration only.
Right.
That's why I give you exact example. Whatever you SCADA or something is very simple example HMI. You want to show your machine status to your HMI. How?
Yeah, then this is a very straightforward and
Very simple. You open the HMI software, you configure the PLC first. You add the PLC. But first you choose the HMI model, of course.
but you see there's a good point. Because we did the example with this is a Siemens, that's why so fast, right? If you are doing using another non-Siemens HMI, then you have to do the same thing. You have to
Export, import.
import the memory
Yes.
file.
Yes.
Okay. Get the point. Okay. I think I get the high level.
The idea,
Idea.
main thing how it works.
The main thing is that language
Yes.
Because I don't want to just go through the TIA portal. I know that of course we're going fast. The reason is because he done the job already. He integrate everything. So I miss all the steps.
Just I need to choose.
But in the real life, it's not going to be so easy like this. Yeah.
Yeah, it's a different device. Then you need to know how to take information from that device. That's all.
Yeah.
So each device they have their own language. So you need to struggle. Of course, like I say, you know only one language. Want to go there?
Yeah.
They have different language. So you want to understand their language. Of course, you need to learn how to take their language or use a translator.
I got the point. So, yeah, I think I got the point already.
Yeah.
So this is their language. This is their language, and this is what you have to prepare
Yes.
in the case of this kind of situation.
Yes.
Yeah. Okay. I think I get the high level on the networking and the architecture part.
Yes.
Yeah. Yeah. We're supposed to check the SCADA. But okay, but I think we have a nice SCADA here already. Just have to test it.
Yes.
Yeah.
Done.
Actually, done. Yeah.
Okay. You just go down.
Go to the SCADA page.
Yeah. Go down. Okay. It's the PC station. Go down PC station. Click the runtime. The WinCC RT. RT is a runtime only. Start runtime.
So let's say this is one PLC, one computer, right? In the real life, your runtime is one computer, and your operator in the control room has 2-3 computers, for example. They have to install the client, and the master has to install runtime.
Yeah.
Runtime run first, then the operator continue to
Yes.
open the client to then Then you have to configure lah. We have to configure multiple operator
Yes.
computer here.
Correct.
Okay.
Something wrong. Oh, okay. Because we add the tagging right just now, the OPC tagging.
Oh, okay. So you delete.
Connection also. Because if the connection. Oh, I think connection. If it is red color, then we have to install.
So we try to output.
Set positive, negative, that one can do some calculation.
Okay.
Not calculation, there's a function called change the, then you can get the value.
Okay. The SCADA work.
Yes, that's
Okay.
So when but still we need something. Okay, move, okay, counter data I show you.
Okay.
SCADA done, HMI done. Once we come back, DB is done, but we create alarms.
Right. The alarm is the
Alarm is important also.
Yeah.
So I show you alarms.
Do you mind share about the operator client?
Operator,
I mean the client, how to get the client
the screen,
client, yeah. Or is it
I'm
not
not sure.
because it cannot be on the same
done
computer?
Never done before.
Oh, okay, never mind. Okay.
Don't have
But I get
To
to accept
explore
now.
lah,
Yeah, okay. So this is to develop on the okay.
Mm.
On it. Okay, yeah.
Then after come back, we do alarm, we do PID.
And one more thing. Do you the user level access is it done
The
from
admin.
Yeah.
In the TI folder.
For example, admin level, operator level, engineer level, they have different access, right?
Yeah.
But actually,
It's all in the administration.
yeah.
Maybe you can do one, maybe you can see. You
Can
can
I
try
do a
one.
simple one? From
Just
from
one
operating it, I know how it functions very well. But
Mm.
from developing it, I just like want to make sure I know that.
How to
how-
create that.
Yeah.
Yeah. It's just under the administration. You
Yeah.
need to add. Can you go close? So operator level means how? Okay, let's say you want to key in something.
Yeah.
You show, it will pop up the.
Okay. For example, we use this. We say operator is only can operate this wall.
Okay.
It cannot change the set point.
Okay.
Yeah.
So first, that settings all under the property. I think under security. Okay, authorization. Okay, allow operator to control. Okay, something. Okay, authorization. Who authorized?
What is two?
Active. I'm not sure.
Okay.
Later we can try out. Same things for this also.
Right. But this is already preset. Like they have already have an operator control level.
Means okay. All allow operator control means anyone can control already now.
Oh. Okay.
Now, so
Unless I choose a different level.
then later you need to add the user administration. So administrator, you later add user, then you can add operator, all that, the password,
And I have
everything.
different level group.
Yes,
Okay.
all that.
And
Then only I think I can go and do the settings here.
then I can authorize
Yeah.
who to do.
Yes. Can you see under user? Who? Monitor only, user administration, operator. Monitor means just monitor only.
Then how to log in and log out the user?
That's the thing. You need to create the user this one first.
User page. I mean, let's say I created already. I have say just two level. Operator and administrator. Two level. But when we start runtime, we start client. Let's say this is the operator PC. Operator come visit, use it.
So before you open, you must log in.
Yes, usually you have to log in first, or normally by default is if you don't log in, it's the operator level. If you log in, then you go to whatever.
Can, but need to explore.
Okay, but never. So there's a screen. There's a screen have to do this.
Screen setting or device setting.
but anyhow,
Mm.
but because I know that normally people will create a login page, yeah, or at least like a login button, you click it, then you
Then later on you
Prop
can,
up.
yeah, of course
yeah,
can do.
yeah,
You get one page to log in. Then
Yeah.
you click there, it will show the pop-up.
and then
Who
yeah,
want to
you
log
key
in?
in, then you change to your authorization is
Yes.
different already.
Can also.
But
Just need to
anyhow,
explore lah.
It's not a difficult thing like this one.
Yeah.
Okay. Okay, got it. Yeah, okay. So,
Okay, we go for break.
okay, sure.
Once come back, we can continue.
Okay. All right, see you later.
Yeah.
Oh, you had your lunch already?
Yeah.
Question.
Yes.
The PLC has a PLC sim, right?
Hmm.
That is for simulation.
Yes.
Can you show how to do it? Is it difficult or is it
Basic.
very simple? So what it means, I can create PLC software configuration
Yes, you
with
go up.
a simulated hardware added.
Yes.
Okay, okay.
Very simple. Okay, you can close this runtime.
Close the runtime.
Yes.
Okay, now this is closed. Okay,
Okay, you go to the PLC. Go up.
PLC.
Choose the PLC.
Okay,
Okay. Go to online. Simulation.
just like that. Okay.
Yeah, start. Okay. So it will disable all the existing communications like.
Okay.
Okay, click yes.
Okay.
Okay.
Oh, so it will open the PLC still.
Yes. Click here. PLC. Okay, then we ready. Once this one ready, you click here. Minimize this. PLC ready for download. Okay, just choose one of these kind of. Okay, start search. Okay, look.
CPU from okay, look.
Simulation. Connect. Look. Okay, start. Click here. Start the module. Okay, finish. That's all. Now you go to Dynamic Control, for example. Go online. Can close. Can go until that. Can close down until now. Okay, monitor. Connect.
Question. Okay. Now, this PLC is simulated. We are not using the real
Not
PLC,
using.
but we are using the real PLC here.
Yes, okay. But cannot work.
Oh, cannot work. Why?
Because you already disabled all the connection. Okay. Now your PLC is this one, the simulation PLC.
Mm.
This simulation PLC is not connected to the driver.
Oh, so the simulation PLC is contained within the computer. Or
Yes.
Whatever, even internet coming up,
It won't communicate.
it won't communicate. It's a standalone only.
Yes.
Question.
So drive I cannot. HMI SCADA, yes, I can simulate as well.
Okay. How about, so we have a simulation of a PLC here.
Yes.
Can I play with the signal inside, like the in-out signal, everything?
Yeah, can.
How to play with it? I mean, like I want to simulate this is a signal from a temperature transmitter. I inject him a 5 dBm something like that.
Okay. So in that case,
Or
bring
this.
the mouse here.
Okay.
Okay, simulation, okay, sim table. In the table. Okay. You add one. You key here IW, the address. 258. Okay.
Oh.
You click here, modify. Okay, you need to select this.
Oh.
Because it's a physical input. So I need to monitor first. Click here first. Yeah. Okay, now you Now you key value 8,000. Enter. Okay, you click here. Okay. Now you go to the program and see 8,000 is there, no?
Okay. Oh, already done. So I go to the program.
Go up. Ready? Okay.
I almost get the point. I just try to think. Say if we have a simulation here, it cannot communicate to outside, right?
Yes.
What mainly people use it for? The simulation. Probably I want to say that I want to test the program, but
Okay, that's what normally I do. When I want to test the program, so I will create the program. Okay, create the program. Then I will create
you download it, yeah.
to the simulation.
The
Then I will
simulation.
create a HMI.
Okay.
Then I will just press start and see the line is on or off.
So on the simulation side, that table is your full in and out table lah.
Yes.
And then
No, I don't use the simulation. I just use the HMI.
HMI table. Because for example, the HMI table you try to click run, okay, visual everything is correct.
Yes.
But at the same time you want to see the signal out is correct or not. So you inspect from the PLC sim.
Yes.
And then PLC sim saying that Q1.1.
I don't need PLC sim. I can use the watch table also.
Yeah, that's the point.
The thing is, okay, what is the different PLC sim? PLC sim means you can energize the physical inputs using PLC sim. Your IW258 is a physical input.
Oh, you mean here?
You can key in, but here you cannot key in. You go up. You go up. Okay, you double click here. Oh, I think this one can change the little bit.
This is my in actual value. Can change also.
Cannot, I think so. Yeah. Can you see? Because IW is a physical address, so only can change in the PLC sim. Within the program, I cannot change. So normally what I do, I don't like to use PLC sim.
Right.
I mean the table lah, the table.
Okay.
So what I do, instead of using this physical address, I will just put temporarily a memory address. Then I will just use HMI to test everything. Then later on, I change back to the physical address.
But the PLC scheme, let's say I try to get something here, as in I understand that if you want to test fully a program, you cannot change the value here for the in. Out
Yes,
you can change.
yes.
Out you change from the HMI value actually. Not to can I say like that.
Out is depend on the program lah.
Okay.
So all your I
Yeah, all my I. Actually, I can use PLCC, no problem. But the PLCC, you see, is a table. You just need to press 1, then press 0, all that.
Yeah.
So what I do, instead of using that,
You use
all the I change it temporarily, I change into memory first.
in the PLC program.
In the PLC program, then do simulation, and all the memory, whatever button, everything, I put in the HMI, I test first, everything is okay, all good. Then later on the memory is my way lah. Later on the memory I change back to the address.
Okay. But it sounds to me there is a good side and bad side lah.
Yeah.
Good is straightforward, easy lah.
Bad side is if you forget then.
Yeah. If you're only one person, you're very confident. If a multiple person doing this testing, you forget, you leave it, next person come in, and then you can get in trouble. But PLC sim, you don't have to change the program at all. You don't have to change the program at all. But you have to manually,
key in the values, manually on.
like even the full IO list, you have to manually key one by one. Oh, that is going to take a very long time. Miss out also.
That's why I do simulation. I mean the HMI. So I click all the buttons. Whichever button is on. So I make sure the sensor. Sensor I make sure like if I press on, if I press again off, something like that. Push button I press release. So I click like a simulation HMI. Just to do the simulation only. It's not the actual HMI, it's just for simulation.
Yeah. I was thinking if there is a way, somebody can, if you have a PLC sim, you can one button display all the IO already.
Cannot.
Then the testing will be fast already.
Yeah.
Okay, but anyhow, got that one already.
Yeah.
So this is monitoring, this is the PLC is running. Actually, can stop it.
Yeah, stop the PLC.
Then I close this one.
If you want to close, no need to stop.
Sorry?
If you want to close, no need to stop.
Oh, okay.
Just go offline. Do you want to say no? It will be closed.
Okay. And so we have to go back online the device.
Yeah.
So it's not simulated, but it's go online.
Connection. Why? What is it? Cannot be modified. Okay.
This one?
Yeah. You choose the direct access. That's it.
Okay. So now everything is running as usual.
Yes, but you need to download the program and do some changes. new block. Yes. FC. Temperature scaling.
Scaling.
Yeah.
Okay.
Okay. Same norm X, scale X. Yeah, that's all. So integer real, real, real. So our input now. Okay, see ya.
So this is for analog.
Temperature, yeah, our temperature input is here. Number 1 lah. Number 0 is this one. Okay? The day one, right? Okay. Then I put a resistor. Resistor will tell you why resistor. Okay? First, this one and this one is from this. The day one, okay? Com and number the first analog. Com and the second analog is for this.
Okay.
Using the same com lah.
Using
Okay.
the same com.
Okay?
Okay.
Can I? Okay. Now, why I use resistor? Because this analog input is 0 to 10 volt fixed. Correct? It's fixed, right? Can change. Unless you add additional analog input cut, that cut can change to 4 to 20 milliamp or 0 to 20 milliamp. Okay? And this one is 4 to 20 milliamp. And here is 0 to 10 volt.
Huh? Oh, so this one is.
You understand or not? This one is 0 to 10 volt, the analog input. And my device is 4 to 20 milliamp. So I cannot directly connect. Correct or not? Cannot. That's why I need a resistor in between.
With a resistor, then you can
Yes.
reach 4 to 20.
Yes. So it become what happened? It's not 4 to 20. It become like 1 to 5 volt.
Oh, this one really have to ask you to explain a little bit more.
Yeah.
It's very interesting, yeah.
Yes. Because sometimes we don't have this device or
It's a temporary fixer, but
yes. It's not here. What happened is this is my PLC, okay? My AI is 0 to 10 volt. Okay?
this is a fix because it's
Fixed
one
energy because
yes,
because it's a built-in analog input, right?
yes.
This one is my the temperature controller. Okay? This is 4 to 20 milliamp.
Output.
Yes. So for 20, so you cannot detect this. Correct? So what I need to do, I need to change the milliamp into voltage. Okay? How? In between, I connect a resistor. Okay? So how many ohm is E equal to I R? So I equal to, sorry, resistor, right? On the calculator resistor, R equal to V over I, right? So to calculate the resistor voltage is 10 volt, maximum is a 0.02 amp. So you will get R 500 ohm.
I mean, from the calculation, okay, this is the answer. But
You can convert.
physically, how it work out? Let's say the electron, I mean the electrical normally is flowing from here to here, is it? Then, I mean, this is a com.
No, it's positive.
is a COM.
Yes.
This is where I tap and connect to check the 4 to 20 BPM originally.
You must check this too.
Okay, must check this too.
Yes.
Because it is a current. Correct. I check here, right? Current only.
No, I know. You don't see the current, the amp. This is milliamp.
This is milliamp, right?
Yes, you must choose these two. If you check the load, the current, that is correct. You need to do that way.
Because I mean, if I check here,
You show the milliamp.
it will bypass here already. It will bypass here. I only can check here, then only I can tell the current what is it. I mean, put it to 4 to 20 or I mean, okay.
Yeah.
Because voltage difference because if you want to, because if this is a 0 to 10, here is also 0 to 10 and start running already. Let's say this one branch is whatever 0 to 100 degree it's a 0 to 10 volt, and then now it's a 50 degree here. So it should give a 5 volt
Yes.
going back.
Yes.
So the 5 volt measurement should be, I check here and here.
Okay.
I should read the 5 volt.
At the instrument also you can read the 5.
Yeah, here also I can read the 5
Yes.
volt, that's
Okay.
correct.
Correct.
And now I say this is a 4 to 20. This is also a 4 to 20. And then 4 is 0, 20 is 100. And then now the process is 50 degree.
Yes.
It's a 2 wire. So by right, it should be has a series of sending back 12 BPM.
Okay.
Yeah, I don't know where is the best place, but either I have to measure here or I have to measure here. But normally I think people is measuring here. I don't know, that's why I asked. You have to open the termination, or otherwise you open here, and then you not open. It's you clamp here. Yeah, clamp here.
Okay. I know what you mean.
Yeah.
But you are talking about amps, not milliamps.
EDM also use a clamp meter can measure also.
If you use clamp meter, yes, then you must clamp here.
Clamp here.
Yes.
Right.
Yes. If your multimeter can measure milliamps,
Right. If the multimeter
then
can,
you positive negative.
if you say that it's using a 2 point, right?
Yes.
Yeah. So I say if you're not using clamp, but you're using 2 point,
2 point also.
you cannot do this here, I think, because if you do this here, let's say this is your flow, your multimeter, then your current immediately from here come to here already.
So what you need to show?
So it will bypass this one already. I don't know what it shows. If this is a very low resistance, then it will be showing something incorrect already. Only place you can show is if you open up this one, and then it forces to complete the loop. And then this will show what is the current here. It's the same thing. If you connect like this, because the current it can flow to here, you also can flow to here. You will choose the easier path. But one thing I'm for sure is, unless these two has the same resistance, otherwise, what is feeding here is, and here is not the same. But I think that's another thing that has nothing to do with this one. It's just that I'm very curious to know how this resistor can convert the 420 to 0 to 10 volts here. That is something that very interesting here. Right. I mean, that's what I say. I'm not necessarily to say that I'm super correct or
Yeah.
I just really what I think about it.
Okay, never mind.
Yeah.
What do we do? Okay, I measure it because this is a current. Will just measure current in AC.
Oh, this one cannot measure. Okay.
Okay.
Cannot measure here.
8 million.
Okay, 8 million. Okay.
So 8 million is correct one. So I'm not measuring from this to this, I'm just measuring every negative one.
Okay. I don't know what's the correct one. I don't know. So you say that this is same as the range, because I will just take it as what it is first. We do
Okay,
the testing
now
first.
what happened is, because as I know, milliamp you just can measure using positive and negative. Make sure your meter can measure milliamps. Okay?
One thing I think
DC milliamps.
I know, but one thing I think is milliamp. If you use a probe, you should open the loop. You should open the loop.
But the loop means open this loop.
Right, you should open the loop. If you are parallel the loop, but of course I don't know what is supposed to be right in VM and so on, because I don't know the transmitter.
No, this one is 29 degrees.
Mm.
So 4 milliamp is 0. So it's 420 milliamp.
So it's set to
It's
so
around 8 something lah, correct, the value.
that's the point. I don't know what is a 0 it means here and 20. I mean the 4 it means here and 20 it means here. Because this is a transmit, this is a controller, right? Somebody
No.
has set it to be.
No, it's a 0 to 100.
Okay, this is 0 to 100. 4 is 0.
Yes.
4 is 0. Okay.
4 to 20, right?
Right.
So 0 to 100. So now I get, so here 50. 50 is 12.
Yes,
Right.
yes, 50 is 12.
So I get around, so 25 is 8.
8, yes.
So if I get 27 means 8 point something.
Yes, that is correct.
Yes.
So this is, you say that this 8 milliamp is correct.
Yes. Because why? Okay, actually why I put this, why I can use this system? I think I can manage it. Say this one. Still I get 8, right?
Right.
8.5. So here you can see that 28% is 88 degree lah.
Okay.
Okay, now I measure in voltage. Is that 11 volt?
Okay.
Because of this. Because it's connected to DC, right? Okay, I get 11 volt.
11 volt and 8 milliamp.
11 volt is equal to 8 milliamp lah. Okay, so 11 volt is equal to 8 milliamp means 20 milliamp. How much?
This one I cannot tell. I don't know. This one I cannot tell.
Yeah, wait. See. Connected. I'll tell you why I use this system. So if I connect or disconnect, it's the same thing, same 11 volt, right? Can you measure
Okay. And
this plus minus?
this is a plus. This here.
This plus minus.
Oh, these two are 9 and 10. Not these two.
Yeah.
Okay. Now it's a 4 volt. 4 VDC. And
Yeah, because I already connected this here.
Okay.
Connected, I mean the what? Resistor. Okay? Become half lah, half of it. Now you know.
Okay, now I connect. So before I connect, I just try to think, and am I supposed to get more than 4 or less than 4?
No, I also don't need to check.
Okay.
Check.
11.
That's right.
So still around.
So it's like, you know, it's why 11. It's supposed to be like, supposed to be 10 volt. Correct.
Yes, that should be changing lah.
Yeah, changing lah, 10 volt lah. Okay. So inside is 0 to 10 volt only. So it means it's like 0 to 10 volt. Okay. So I make the 0 to 10 volt. That's why I calculate the voltage is 10 in the calculation, right? So 0 to 10 volt, I make it into
420.
420.
Like linear relationship.
Yes. Means that is 1 to 5 volt. That's why after I put resistor, it become 4 volt only. Right now. Without resistor is just 0 to 10 volt. Okay? But after I put resistor, it become 4 to, sorry, 1 to 5 volt.
1 to 5 volt. Why is not 0 volt to 5 volt? It's a 1 to 5
Because
volt.
it's a 420 milliamp. Right? In 0 to 20 milliamp, it will show 0 to 5 volt. Lah.
Oh, so you mean, I don't know. So this is how it works. 10 volts is always equal to 20 milliamp. 0 volt is
No.
No.
5 volt
Oh,
is similar to 20 milliamp. 5 volts.
oh, that is how it is. So
Yes.
if you say like that, I ask more detail. If I have a 0 to 5 volt, I will cut up, and then I have a
Milliamp.
really something else. Somehow have a 0 to 20 milliamp device.
Device.
I also have a 0 to 5 volt device.
Okay. You want to connect?
Yeah, I connect. Actually, both is sending the same current voltage.
Yes.
Because 0 to 20 is equivalent to 0 to 5 volts. Oh, so in terms of the electric current or voltage, actually they both are the same.
Same, but if you want to, because let's say it is voltage, right? And here is current, you must use resistor then.
I still have to use the resistor?
Resistor, yes. Then I will tell you for how much, what is the resistor value.
Okay.
So that is what resistor. Okay, I will tell you.
Okay.
Now, in this case, you still use both differently. So let's say your PLC is 0 to 20 or 4 to 20, that depends, okay? And here is voltage, okay? 0 to 10 volt. In this case, you must put resistor in like this, on the positive side. 500 ohm.
The main objective is to reduce the 10 volt to 5 volt.
Yes.
So you know the 20 milliamp, you know this is 10 volt, that's why you have to put 500 ohm.
Yes.
And in the result, here you will get 5 volt instead of 10 volts.
Yes.
But this is a
Milliamp. So what happened? Okay. It will convert and it become, how to say? Okay.
so I think if you say like this, I assume still this setup, if I didn't put this, actually
It's okay. It's very simple. It will carry the voltage, maximum voltage, but the amps only will change.
say I go back to this setup here, 0 to 10, 0 to 20 here. I add the 500 volt here. For sure is, if I do a process change,
here originally supposed to send out 0 to 5 volt potential difference.
Yes.
It will become 0 to 2.5 already.
Yes.
If I measure the voltage is 0 to 2.5, if I instead of measure the voltage, I measure the current,
Yes, correct.
it will be 10 milliamp.
Yes, correct.
If I don't do this,
Mm-hmm.
it will have a 0 to 10, right? So let's say I say that this 0 to 100 degree, right? I say it really, okay, let's use that assumption first. I say it's as a, then I 50 degree, 0 to 10, 50 degree is 5 volt. So I have a potential difference 5 volt here. If I measure the current here, it should be 20 milliamp.
Yes.
What do you want? This is in a series resistance.
Yeah, the positive side.
This is
This one.
this one.
Yeah, because my peers, because I want to convert milliamp to voltage.
Oh, what you mean is the voltage to milliamp, then you do this.
Yes.
Milliamp to voltage.
But I know the
Okay,
apps,
yeah,
but I do know how the working principle is.
Okay, I think I leave it first. But we know that this is going to work. That's it.
Yeah.
This is going to work.
Yes.
Okay.
Yes, it's working.
Okay. Got it.
Okay. Now 0. Okay. Now it's not 0. Okay. Now because it's 4 to 20 milliamp. Correct. Okay. So what we need to do is this one is maximum 27,000.
This is a
Analog input.
analog input.
IW66, the temperature this one. The value. But it's not 0. 0 later we change. I mean I'm leaving later we change.
Value we use I first and this one is
IW66.
okay
Because it's a 64 and 66, right?
yeah.
I think 66 we already, yeah, it's not created the name tag already. Okay, so 27,000. 27648. 276. Okay. Then this one is norm X. Just put norm X first.
Okay. Because before we already use a norm X, right?
That is inside the other FC. This is a new FC.
Doesn't matter. Okay.
So norm
Okay,
X.
okay.
Just put norm X. Then we can make it as a right click, define local tag. Yes. Then this is 0 to 100. That is norm X. Okay, 0 to 100.
Which is the degree Celsius here.
Yeah, 0, 100.
Okay.
Okay. Then we already created the SCADA tag for temperature. Right?
Yes.
SCADA temperature.
So we current connection.
Yes.
Okay. So we use a DB.
Okay.
This is the DB
Now-
tag.
Now this one is because it is we see at the PLC side. Okay, we just ignore this. Okay. Let's say 4 to 20 milliamp already converted to PLC. It become when you come to here, it become 2 to 10 volt. Here, because 20 milliamp become 10 volt, 4 milliamp become 2.
Okay.
Right here.
Okay.
Now, so we need to know what is the value and true. Okay, what do you do? 27,000 divide 10, you will get 2764. 2764 for 1 volt. For 2 volt is
Times 2.
times 2.
So 5100.
5 something, right?
Okay. Yeah.
2764.8 times 2. You get 5529.
5529.
So just put 5530.
5530. So 5530 is essentially is 0 degree.
4 milliamp. Consider so it's a D. Yes.
Okay. So it's
Because why? Because I measure from 0 to
Right.
10 volt. But you only starting from 2 to 10 volt.
Right.
So I need to do the offset.
Because I get what you say. Because of this configuration we have now.
Yes, yes.
Okay, got it.
Got it?
Got it, yes.
Now only I can get the correct value. Okay, go to here.
Okay.
Go to OB1.
OB1, okay.
Just call the temperature block. Temperature block. Okay. Then go to download and test.
Alright. So I'm reading 28 degrees Celsius now. So maybe it's the other way around, the wire connection, is it?
Wait a minute. Why?
The wire is reversed.
No, no.
Because I thought positive, I mean 15 negative.
Oh, yeah.
Yeah, so it's 27.
Okay.
Okay, so exactly the same.
28 lah. So
Yeah.
just need to play with the 5530 and 27,000.
Okay lah, I mean if somebody want to like,
You can check it whether it's 100 is correct. Just copy it 100.
so 90, 93, 94, yeah, it's the same.
So see, it's not 27,648. Just now, right? The 27 maximum is what value? 27,338. Correct.
Right.
It's not getting accurate lah. This one
It's
is
not
mixed.
getting accurate.
So the 27,648
Okay.
we need to change to 27,338 something. 27,338. Okay. Download.
Okay. Yeah.
Now I get a bit accurate.
Yeah, near 48, 47, 47, 46. Yeah.
Then we can round up the value lah, no problem.
Okay.
There's a function called round up everything lah.
Okay.
Now we do the PID. Okay.
Okay.
Now what we do, we go offline. Go to show on that. The tech table,
Okay.
you add this one, this Q0.6. This you put what? SSR, solid state relation. Q0.6.
Okay.
Okay, now next you go up. So you go up. If you want to do PID, I need to go to admin block. Go to organization block. I need to use the cyclic interrupt. Okay. This cyclic allow you to start program at periodic interval independent of cyclic program. Means so it's not like starting the program if you like have a delay, not like your main only. Okay. So this cyclic interrupt. Okay. This is where we're going to put the PID.
So PID must be put into the cyclic interrupt.
Yes.
Okay.
Under here, under technology, the PID control, PID compact PID.
Okay.
PID compact.
Okay.
PID compact one unit. Okay. Alright. Now here set point, input peripheral, output. Okay. Now set point we want to set in the HMI. So let's say go to SCADA first. We need to create that first. You right click here.
New.
It's add row. Because why? Because we already compiled this now. The temperature set point. Real. Okay, real. Okay, you need to compile. Right click, compile. Then only you will get the address. This is the address like DBW0, DBW2.
Wait, we uncheck the
Yes.
optimization.
Yes, correct.
Okay.
Okay, now go back to the cyclic interrupt. Set point, you take the set point. The SCADA set point. No,
Let's do that first.
yes. Now it's up to you. You want to use the input after scale or the raw input, the analog value. Means you want to use the 0 to 100 degree or 0 to 27,000.
Practically you have to use the temperature then easy to
Temperature, because why? 0 to 27,000 is not accurate.
Okay.
So I use the, then here you put your SCADA current temperature.
Okay.
Yes.
SCADA. Temperature. Okay.
Then this one only. Then the output. Now output. This one is the PID output. I don't care. Okay. Now for two type of output now. Like I said.
What's a PER?
Peripheral. Yes. The raw value, the analog.
Oh, okay. So it's either choosing the integer or you want to choose a scale version.
Yes.
So output. So this is optional lah.
Yes. It is. No. You forget about this one. The input like I said, input you can use the scaled value or before scale.
Right.
Same for output. That this one you forget about this. We have two type of output. One is the output peripheral, means if you want to control using temperature anything that is analog that I use, so I use that. So I can straight away put that QW whatever. Let's say the motor. Okay? If I just want to control for this, I need to control the relay, right? The SSR. So I use the PWM, pulse wave modulation. Okay, so you put it there. Just now the SSR.
Put what here?
The SSR. Just now we create the SSR. The relay. The relay.
Yeah.
That one. Now I put first. I will tell you what is okay. PID is this one you understand, right? The input.
Yeah, understand.
Output output is you can control two type of output. One is on off, one is value.
So now we are choosing on off.
Yes. So on off is not like a normal on off. It's a pulse. So that is why we're using the solid state relay, not a normal relay.
Because the frequency is very fast.
Yes.
Okay.
Okay, you know why? Because initially the relay will be on off, but the moment it go to steady value, it become like a pulse on off, on off, on off, on off. That's the reason. Okay, good. That's all. The rest I think no need. But if you want to, store the data, you want to know what is the error, everything, we can do that. Okay.
Okay, yeah. So I think we have this, it will be functioning already, right?
Yeah.
So what this is doing is, this is going to on off the
Coil.
filter inside.
Yes, correct.
Okay.
Coil. Okay, now go here. You need to do setting. Not this one. This one is
Yes.
uh,
Close this one.
this one is testing. Okay, close. Tuning. This one.
This one.
Yeah. Wait, I have to change. Yeah, okay. Your type is not general. Temperature, right? Choose temperature. Okay, go up first. Okay, temperature, Celsius, set mode. You click the mode. Manual. I think automatic. Wait, I saw. But there's many mode lah. You can just explore. Automatic mode.
Okay.
Choose automatic mode. Okay, go to next. Okay, input, what type of input you are using? You are not using the analog, you are using this input, right?
We are using a
Temperature input.
yes.
So you must use temperature. It's right here. And okay. The input only.
Okay.
The output is we are using not using analog, we are using the PWM.
Okay.
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 Next, process value limit. Okay, so 0 to 100. 100 dB. Okay. Process value scaling only that because we are not using the peripheral. Okay. So we cannot change this one. Okay, limit. Yeah, that's the thing. You go to process value monitoring.
This this limit, what is the function for this limit here? I mean
Because that is the input limit. Because your what is your input? Because you are using input, but you are not using peripheral. Peripheral means 0 to 27,000.
okay.
Then only you can know what is your set point, everything.
Because okay, you go through first, yeah.
Okay.
Because in a normal PID tuning, you not need to key this one.
No need to key in this one.
No need to key this one.
Then what do you do? How do you know what is your temperature limit?
I mean, I deal with quite a lot of PID tuning.
Okay.
PID tuning only have three key parameters.
Okay, what's it?
P and I and D.
Yeah, of course.
Yeah. And this one, I mean, for a PID controller, he doesn't have to know.
For PID controller.
Yeah, because we are building a PID controller, right?
Okay.
Yeah.
Now, actually, this one is replacing the PID controller.
Yeah.
Actually, okay. Now, Your input is what actually for the PID controller?
It's a temperature, that's it. Yeah.
Temperature? What is the range?
It don't, I mean, there's a point. You don't have to tell him the range. For a
No,
PLC
no, no, I know,
controller,
don't
yeah.
need to tell you the range.
Yeah.
Okay. But you connect the temperature transmitter or temperature directly?
I mean,
DC.
no, I mean, this is the point here. The controller is a very simple controller is a, I mean, the concept controller is a very straightforward. Controller is, I mean, not necessarily you have to do, have to use a PLC or VFD, that is only called controller.
Yeah, of course.
Excel file you also can make a controller. Controller is essentially is every scan time, every second, say your scan time is every second, you have a difference between the set point and the process value, SP and PV.
Yes,
Then how are you going to behave?
yes, of course.
So if your set point is, I say all here we are going to, I say my input is temperature, output is percent, very simple. That is a PID controller.
Yes, yes, correct.
I say my set point is 50 degree, and then so my input is K, it's a Kelvin, or Celsius C, I say C, it's a C. My set point is 50. My process value PV is 52 degree.
Okay.
So I have a +2 deviation.
Yes,
Then what I'm going to send out the command
yes,
says, then this is the first setting I come in. I keep in my first command, my first constant is P, proportional. I say my proportional is 1% per Kelvin.
yes,
Then my output is 2%, because +2%,
yes,
because that is my deviation.
yes.
That's it only.
Yeah.
No matter it's deviate by 2 degree or 2000 degree, for a PID controller, he don't have to know. He only have to know what is the difference only.
Yeah, of course, because it's here also same, the
Yeah.
same concept.
Yeah.
But what I need to do is, because I need to tell the limit.
So I'm asking, is it this limit? He going to trigger
Not
alarm or something, or he going to cap the limit? He going to cap
Why?
the limit?
Because, not
Yeah.
the limit, why? Because, why this one got limit, everything? Because you see just now in the block, right? There's the called state.
Okay.
The state, it means if it is overflow, it will give you like the value.
So it's a capping the maximum.
Yes.
So say something wrong here, I giving the real temperature or whatever, I'm
Yes.
sending it more than 100 degree. But if you maximum, I will not read more than 100 degree.
More
right?
degree, and
So
I will
I will-
show error, and I will get you error message. What is the error
Okay,
message?
so it will trigger the error message, it will cap the maximum, it will
Yes.
cap the limit.
Yes, that is the reason for this.
Okay, so that's okay, got it.
Why we have this scaling mode.
It's mainly for these two purposes.
Yes.
Okay.
Process value, okay, because we already
Not using
disabled
this
the
one.
inputs. Yeah.
Okay.
Okay, warning, no need. If you want to use the warning, then you can use warning. If you don't want to use, just leave it, no problem.
Okay.
That's the thing lah. Then PWM limit, minimum on time, minimum off time. Minimum you put.
So this is like for this one you have
Yes.
to on. Once you on for 1 second. Once you off for 1
No,
second.
no, I mean minimum lah. Actually, no, just leave it 0 second. No problem. Okay, output value. Okay, we are not using this, so we just leave it. PID parameter. Okay.
This is a PID.
PID parameter. We enable.
Oh, enable.
Okay. So how much you want to do?
Okay.
So we just leave it the same lah.
Yeah.
1, then the time is 20 seconds, the derivative 0, and the structure is PID. Okay. That's all. Save. Okay. Then download.
Okay, download.
Yeah, download first. Then we have to create the HMI as well. Okay, let me connect inside here first.
Question.
Yes.
Just now when we do the block, I know this all this especially this part because this part is very important here.
Mm.
I see that the program block here,
Mm.
it don't have input for PMI. So I mean,
You
let's
open,
say,
you
yeah.
open, there's an arrow there. You open, no, there's an arrow.
Oh. Okay, I can. Okay, here is a part here. So I can export the alarm message.
Yes, the input warning, high level, low level, set point warning,
Right.
okay, disturbance, manual enable, manual value, error acknowledge, reset.
But I still don't have here. But I'm just asking.
You must use inside. You must do inside here.
Because this is typical, very typical. Fine tuning have to do. When we do fine tuning, then we have
Then
to
the fine tuning you have to do it here.
inside the program.
Yeah, here first. Go to download it, right? You go online.
Okay, go online.
No, that is wrong.
Oh.
Go online.
Okay.
Go to tuning. This is a tuning. Yes. Start. Start. Okay, this one. Okay, because my set point is 0, right? Need to do the set point first. Go down. That's my set point. S7 get started. Go down, go down.
This.
It's too small, I'm gonna see properly. Okay, I'll put current set point. Set point, you put the value. Not here, wait, I'm looking at you put the value, set point value. Scale input, the input value is here, right? Tuning is start. Tuning. Error starting procedure. Okay, put the program here. And put the value. You see where the key is there, set point value. No set point. Okay, never mind. You stop the tuning. You minimize first, or you go back to the screen. Okay, you add one more this one for set point. One for the temperature, one for the set point. Yeah. Properties.
Properties.
Yeah. Okay, make it bigger this one. Take 2 seconds.
I can add a small indicator to show the SSR is activated or not, right?
Can.
So probably I just add here. So have to give actions as animation or event.
Animation.
Animation.
Appearance. Yes.
So when the SSR single bit, then should single bit. SSR itself is a Boolean, right?
Yes. Add another number. Yes, below it. Yes. Okay. Now you change color. Okay.
Okay.
Yes.
So
See the arrow.
Okay.
Okay.
So this one.
Save.
Okay, done.
Save.
Save.
Then go down.
Scale up.
Go down. The HMI.
HMI.
Okay. Click the runtime.
Okay.
Start runtime. Make it smaller. Why no value?
This is on scale.
You go there.
PRD is on the circuit block.
That one we don't have. Wait.
Oh, okay.
Go to the runtime.
Set point.
No, runtime first. Runtime.
Because we can key the set point here.
Because no, why no values? Why no temperature value?
Oh, no reading temperature value.
Yes, you go here, go to the screen, double click here. What is the parameter? Go to properties.
Sorry.
It's not AI temp, sorry, wrong. You go down. It's not AI temp. You there?
Oh, it's already scaled. Yeah,
It's
yeah,
from
yeah.
the DB.
Okay.
From the DB. Program block. No, program block. Okay. This what? Set point or current temperature? Set point, right? Go down. Or the current temperature, AI temp.
Oh, okay. This is a current temp.
Okay.
Okay, this is a current temp.
Okay. Then this one?
This is a
Set point. Okay. Okay. Here.
Okay, this is a set point temp.
This one?
This is correct one.
SCADA temperature set point. Okay.
Okay, so I already.
No, this one is HMI. You close the HMI here. The runtime close.
Save the project and then run.
Save project, then go start runtime.
Go to the HMI.
No, you can click here also. Okay.
Oh, okay, this is the start runtime.
You close. No, not close. Sorry. Make it small. Small. Why no value? Okay. You go to your dynamics. Dynamic control here. Close this one. Monitor. Go up. Okay, no set point, right? Okay, you go click here. You set point. 500. Enter. Okay, then why the SP? Okay, I think the temperature scaling did you call in the monitor? Okay, why why it's not showing the temperature?
This here,
DB1,
current time is
DB4.
27.
Supposed to show the temperature here, right? Okay, close.
So that's problem.
Not SCADA problem. Wait. SCADA current temperature. SCADA current temperature. Okay. Go to the screen. Double click here. Yeah, double click. SCADA current temperature.
Input, current temperature, decimal.
It's not the input, it's a display. Output only. Current temperature.
Oh, okay.
Yes. Then the set point must be input output. Yes, okay.
Okay.
Now make it smaller. I just want to see the temperature and the set point. Okay. Bring to the side.
Bring to the side.
Bring to the side first.
Okay.
This side.
Okay.
And this one can close. Go to the PID block. Where is it? The cyclic. No. The tuning. Okay. Error start with tuning. Okay. Click here because no set point there. Now this one will move. Bring the set point. Okay, set point. Put 40 degrees.
So we have 40 set here.
Okay, start. Start.
So heat up a little bit and on.
Okay, is it heating up?
I see the light.
But is it power on and it's constant light, right?
Oh, this light is, no, this is permanent on.
I think it's very fast pulse. That's why I show you here. Okay, you start the pre-tuning.
I really start like
Okay.
there's no
First one is showing error. Okay, your error acknowledge. Okay. No, your error acknowledge.
too close to the second.
Process value is too close to the set point.
Maybe to 40 or too close. Okay.
You error acknowledge. But you can see the output, how the output goes.
Yeah.
But that's one.
So but essentially this PTW is converting the output to a pulse lah.
Yeah. But this one is the presentation. Temperature slowly increasing. Okay, go down. You upload the PID. Okay, click this. All, yeah.
Oh, this is
Okay, because it's do the tuning, right? Okay. Then go to the parameter. This is the original value lah, the end. Correct. Okay, go back to the one. Okay, you upload. You click again the upload. Why? Okay, go up. increase your set point lah to 80. Put 80.
Okay, okay. Yeah. But anyhow, this is it's a tuning, this is an automatic tuning lah. Pre-tuning and fine tuning. Pre-tuning means a bigger range, fine tuning means a small range. Probably. Fine tuning.
Let it tune. Then if you give the values for the PID,
Okay.
then we can use that. What is the temperature?
Here it is. 75. Straight input.
Go to the PID. Okay, go down. Okay, go to parameter. Okay, go back to the tuning. As the tuning finish, go up. Once the tuning finish, it will give you some values. So you can upload the value from the tuning and make it that as your values.
Okay. Interesting. Okay. So this is after tuning, can directly upload the tune value as,
Yes.
as a first PID value first.
Yes, yes.
Okay, okay.
Then we don't want to edit the values and then can edit.
I say my opinion this one because typically tuning the PID depend on what application, but a lot of time it's more than an automation engineer job.
Yeah, of course.
It's a user job. It's
Yes, yes.
it's an operation team who know the process very well.
Yes,
You
they
know how
need
to
to,
tune this, yeah.
yes, how to maintain this one.
So if you say the PID parameter on
You want to put in the
change,
HMI
yeah,
and
it should
change
be
it.
something that in the HMI, not only in the program. Yeah. But first tuning do this is good. But to fine tune it,
later on.
the user have to know, have to see, have to know it. Yeah. So this is overshoot already more than 100 degree.
Yeah.
So by right it should come out some error message. PID control block. Okay, okay. Okay, so this is we have a functioning PID block here.
Yeah.
So,
The parameters lah.
Okay, okay, got it, got it.
And this is the one that just now we set like minimum, maximum values, everything.
Right, right.
Okay, you go to the function view. Okay, you go back to the tune. Is it done? And still same. Okay, go down. Start it done. Okay, go down.
This one.
No, no, this one.
Oh, okay, okay. This one.
Go down. Okay, try to upload. Cannot. Here.
Oh, is it already done? Is it?
Fine tuning is not. Control the previous PLC parameter.
So it's still
But if you want to enter manually, you can enter here also.
okay lah. But at least know lah. This is there is a function lah.
Yes, okay.
It has to use a real process to do the fine tuning.
You tuning everything up. Okay, now what we do, we go back to the screen,
Of
close. Yeah, of course it will off until it is below.
Okay.
No, close first. Go back to here. You add one button. No, maybe inside here we. Okay. Okay, I can put it here. No, go down.
Hold on.
Okay, take the training. Put it here. Okay. Double click. Okay, go to properties. Bring it up. Up some. Okay, properties. Okay, what is the trend? Which one you want to train? Double click, choose. This one is the other one is the name. So temperature.
Oh, this name it. Okay.
Yeah, name it. Okay.
Actual like that. Okay.
Yeah, okay. And how many values you want? Is the value lah, how many values? Okay. Then this one is a cyclical real time. Click here. So when you want to use the real time lah. Okay.
Okay.
Then the source. So the source is the one from where the current temperature. Okay, so the cycle, how many seconds you want to measure?
This is the scanning time, right?
Yes, the scanning time. Every 1 second you scan.
Okay.
Okay.
Then what doesn't matter this one.
And I want another meter.
Oh, okay.
Okay.
Color. Okay.
Then from left to right, okay, then enough. Then go to appearance. Appearance, oh I don't care. I go down. Go to left value exists. 0 to 100, okay. Then right value exists, so same, 0 to 100, okay. The time exists, below is the time now. So time, how many? 100.
This is
100 seconds, okay,
Okay,
press it.
okay, just leave it up. Okay.
Okay, okay, that's all, finish.
We should have a functioning.
Yes. Save, start runtime. Make it bigger if you want.
Okay, just okay. Let's start.
Save, start runtime. Okay, here it will show the value. Okay, but it's depend on this line lah. You need to move this line. You need to move this line.
Oh, this line is what?
This is the selector lah, where which line you want to use.
Oh,
Then only, so the
okay.
below one it will show. You know what is the value?
The end but the 50-degree needle line there's nothing. This one.
Nothing.
Okay, only this one.
Yeah, yeah. Then you want to show
Yeah.
from where I want to measure. Yes. So
Okay.
this is the current temperature. color all you can change.
Okay. Still very useful. Yeah.
Okay, what you do, the SP temperature you decrease to 50. The set point. No, set point. Yes, put 50.
Okay. The PID is function. Yes. Okay.
Yeah, of course, PID is functioning. You just need to tune that. So just leave it, then you can see it go up and down, up and down.
Yeah. Okay. Okay.
Good.
Good. Yeah.
Any question?
No. Really.
Okay, another thing is anything you want to learn on the PID, right? So this address is what, this one is what. There are so many addresses, right?
Inside the PID block.
Inside the PID block
Yes.
and also outside the PID blocks, correct?
Yes.
Go to so minimize, just minimize, let it run. Minimize, go
Okay.
to your cycling. Anything, anywhere. Okay, you bring the mouse here. Okay, okay. Description of PID compact, input parameters, output parameters, static, everything here.
This is the help for how to use the
Yes.
PID block.
Yes, the main one is this one. From here you can go to the others one.
Okay. Okay. Yeah. So this will show the help file and all this information. Okay.
Then from here one by one you can see that.
Yep. Okay.
Good. Any question until here?
Oh, the PID. Good enough. Really good enough.
Okay. Actually, here right, you can put your the motor output also here.
Right. Like you've been
The motor also will become
feedback.
will
Yeah.
become the increase,
Fast and
decrease,
slow.
increase.
But this one will not affect it, but
Of course, I
yeah,
will affect
I
that.
can play with it.
Yes.
Can I ask how to trigger alarm in the SCADA?
Yes. One minute. Okay. Wait. So
We have a good SCADA running.
yeah.
This is working. Buttons is
Simple
working.
one. Simple one.
This is
Is
working.
that we do this one. So we take a 5 minute break.
Okay.
Then we continue.
Okay.
Okay. Go wash.
Okay.
DB is okay now. Yeah, okay. Then we will have another DB for the alarm. Okay. What you do? Create one DB, one global DB.
Another global DB.
Another
Not
global
SCADA.
Yes. Add new block. Another global DB. Alarm.
Okay. Alarm.
Okay.
Okay.
Okay. What? Just you go offline lah. It's better. The PLC go. So what are the alarms you want to monitor here?
Okay. I just use a high temperature.
High temperature. 2 or 3 alarms you take.
Okay.
High temp. Then maybe this one is as a because start. Yeah. Say start right. Start for this one right. Then
This is
forward,
the start.
backward,
Yes.
stop, reception or using right.
Using.
So this one for this we can make it as emergency stop.
Okay.
Stop for motor or something like. Okay.
So let me stop.
We stop.
Okay.
Okay. Temperature high, we stop. Motor high speed.
Okay.
Okay. And we see how to create. This one also is we do the programming, then we need to do something like mapping.
Okay. Okay.
Okay, thank you, thank you.
Okay, then.
Okay.
Okay, so you optimize, you off the optimize. Right click the
Optimize.
properties. Yeah.
Oh, the DB optimize.
Yes.
Okay.
See, the alarm is interesting.
Interesting to do.
Can learn how the addressing works.
Okay. Yeah. And it's from the properties, right?
Another right click the DB, right click properties. Okay. For the SCADA, actually, if I didn't do, no problem.
Okay.
But for alarm, I need to do. Because for SCADA, the DB address is not important.
Okay.
Correct? Because when you go to SCADA, you just put one button, you select the DB, you can choose from the DB. But for alarm, the address is very important.
You mean we don't have to make it up on the SCADA?
Yeah.
Okay, got it. Okay, yeah.
Right click the alarm, compile. Okay, software order. So now you get the address up. Okay. Now we create the alarm. You go up. Maybe we add another block for alarm. Let's see. Yeah, alarm. Alarm. Same thing can. Okay, think alarm block. Okay.
Interesting. Okay.
You can close this. So we have 3 alarms. So first one is the temperature. So you must use the comparison, correct? Or not?
Yes.
Okay, use the comparison. Compare.
Conversion.
Oh no, compare. Go up, above max. Okay. More than equal. Okay. And at the same time, wait, another one. You go to SCADA. You add one button below the reset. Why? Because just I use until 8.3 only, correct? Okay. Delete. Right click the right click insert row. Okay. So 8.4, 8.9 until 9.7 is available boolean.
Okay.
So that's why I'm using in between here. Okay. Put alarm reset. One button because you want to create one button for reset the alarm.
Okay.
Okay. Then save. Right click compile.
Okay, right click compile.
Yeah, every time you edit, because can you see already got the numbers. So you need to compile, then only compile, then only we get the address. Okay. So you can push it down. Okay. Go back to the alarm block. You put it here, the SCADA. Okay. Enter. Dot. Okay. Current temperature. Okay. How much you want to put maximum?
Okay, I say 90 degree.
90 degree. Okay. Only 90 degree lah. But your set point just now how much? 50 or 70.
50. Okay.
So you put like 60 lah.
Okay, yeah, easier.
Easier.
60.
Okay, then here, what I want to do, when the alarm is on, I want to set the alarm. Until I reset, the alarm will be there.
If you, okay, got your point.
So I want to use set reset. Okay.
Set reset.
I'm not using the set SR. So there's another one called SR. Go up. Under the big logic, got SR. Okay, use the SR.
This is specially for alarm.
Not facility. This one is when this one on, I set. When this one on, I reset. That's all. So why I do this? because alarm is only one. Even the motor also I can do no problem. So alarm is a simple control, so that's why.
There are many ways to do it, but this is the easiest way.
Easiest way lah.
Okay.
Commonly used.
Common way. Okay.
Then here you put the alarm.
Which is this one, say HMI.
Yes.
In the
Alarm.
block.
Yes. Alarm block. HMI. Okay. Then here you put the reset.
Which is the reset button, which is in the SCADA block.
Yes, correct. So I'm doing like the actual program now.
Actual program.
Yes. Okay. Add one more network. Right click this network. Insert network.
Copy paste or whatever.
Can. Then you can just change the things.
Yeah.
Copy. Paste. Can delete. Okay.
Just now you said this is a speed higher,
Yes.
right?
Speed. VFC feedback. Okay. So how much VFD? Let's say 1,000. But it's not real, right? Change this. It's an integer.
Be careful with this one.
Yes. Okay. So it's 1,000. Okay. Then alarm reset is same. This one change. Motor speed high. Okay. Then you create another one. Put on. Okay. Add network. No network. Insert network. One is emergency stop. Okay. Emergency stop is normally open. Normally open.
And this one?
Yeah, this normally open. I 0.5. The last button.
Oh, okay.
I 0.5.
5.
Yeah. Okay, right click, rename.
Give name to this one.
E-stop. Rename.
Question.
Yes.
Just want to keep the terminology right. Percent 0.5 is an address,
I input address.
input address. And we are renaming this. This is a tag.
Yeah, whenever we create an address without the tag, automatically tag 1.
Okay.
Automatically give a tag name. Tag 1, 2, 3 or.
Tag is a description of the.
Yes, because why? Whenever I keep address, the address automatically go into my tag table, PLC tag table.
Right. We have a tag table,
Yes.
not address table.
No address table, it's a tag table.
Tag table.
So I 0.5 is not in the tag.
Mm.
So it will automatically give a name.
So the next question, when we import, export, everything go to OPC, go to
Yes.
WinCC, we are giving out tag table, not giving out address table.
No,
We're giving out then the tag.
tag table.
Okay. Address is internally PLC, how to
Yes.
use the work.
Yes.
Tag is communication.
Yes, tag. Because the names is important.
Okay. Got it.
That is why we need to export import.
Okay.
If we are using address, we don't need to import export.
Okay. And address is everyone have a different way to do the address
Address.
inside the PLC.
Yes, correct.
Okay, got it. Tag is universal language.
Yes, but right click.
And
Right
okay, maybe
click
the
rename.
reset button.
No, right click rename.
Okay.
Yeah, right click rename. This one is an e-stop.
Ah, okay. Eh? Oh, this is an e-stop, not a
Yeah.
reset. Okay, e-stop.
E-stop. Okay.
Okay.
Then you just copy paste this one. The set reset. Okay, the alarm you change to the e-stop alarm. The reset is the same button for all. Yes. Change to the e-stop alarm you created.
Okay. Yes.
Okay, good.
Good.
Save.
Okay.
Save first.
Okay, save.
Save as. Now, download. Because the PLC side is done. Okay. Now, PLC is done, go back to the HMI. Means the SCADA. Go down. Go down some more. Okay, we add a screen first. Okay. Screen 1, 2 lah, the name don't care. Okay. Here we put the alarm. Right and put it. Okay. Leave it first. Alarm later we do. Okay. You put one button here, below or at the side anywhere. Okay. You put the reset. This is the for the alarm reset. Okay. Right click properties. Okay. Event. Okay. Press. Setting. Setting. You can type setting.
Settings. Oh, okay.
Like a normal push button. Okay, here cannot. Here go to the SCADA DB. Alarm reset. There's one alarm reset. Yes. This reset for the motor.
Okay.
Go to release. Reset button.
Setting.
Reset.
Reset it.
Yeah. First thing. Press on, release, reset. Then here is the alarm reset. Now you can type. Okay, done. Okay. Finish. This one is just to
I
reset.
still want to ask this question. Click, press, release, what's the difference?
Okay, why I use press release? Press release means okay, when I click on, when I release off lah.
You mean, okay, so if my mouse is here, this I click, I click
Press.
event.
Press.
Set the release, press.
Yes.
If I
Release.
resist, if I release, then the
Reset. Reset the off the
off the signal. So if I say I click this, I set the
tag.
I set the tag to 1, 0.
Yes.
If I select click instead of a press release, original is 0, then
Press
1. That is a difference.
Yes. Why? Because TI portal don't have function called momentary. Some HMI got function called momentary.
Okay.
Momentary means you press only is like on off. So this one only got set reset. That's why we have to do the press release.
Oh, okay. But let's say if I say
If any button, for example, any button, you press one time, okay, it's on. You press another time, it's off, right? Then you can use the click, and the big is you can use inward big. You press one time.
instead of set beat is invert beat.
Inward big. So one enough, one setting enough. So means you press, you click only, it's on. You click again, it will off. If you invert the value.
Okay. Why we want to reset? Because we don't want it to be always resetting.
Yeah, because it's like a push button, right? Or you want to do like, yeah, press, I need to reset. I press again, I to release the
I got your
value,
point.
then cannot.
You don't want to keep the one forever then.
Yes.
And the difference between press and click is it originally 0. You click, nothing happen. You release, it come on. It cannot be then the click and the release is the same.
No. Click actually is like a push button. Correct.
Okay.
Okay. You forget about set reset.
Yeah, I
click,
forget about this. Yeah.
click is actually like a push button.
Mm.
But the function I don't have for the push button.
Mm.
For the push button function normally called momentary
Mm.
functions.
Mm.
Means I just click or I just press, it's like on off. Don't have. So that is the reason we use the press release. So when I press, I set, when I release, I reset. Because I want to make the button as a push button.
Yeah. Maybe just a quick one because
Yes.
we are very clear that imagine all we start with a 0.
Hmm.
So what is a 0 behave? If we activate become 1, not activate become 0.
Okay, can.
So if I use press, as soon as I press
Press.
1
One.
and then I release, I because I didn't set anything, so
Ah.
it's keep on 1.
Yes, correct.
Okay, if I use release, I say release become 1.
Yes.
Release set it.
Mm.
Okay, I press, nothing happen. Release, it become 1. Then it will keep at 1 because I
Okay.
release set it, right?
Okay, okay.
Then the third try, I don't use press and release. I use click.
Click, okay.
Click set it 1. Then what happened here?
So if I click, then I set bit means
Right, click set it.
on only. Same like you're pressing.
So I click 1.
Mm.
I release 0.
No.
I click
Because
1. I
click
release
1.
1.
Still one because you choose set bit only one.
I mean, yeah, that's the question. If that is the case, it is the same as press.
Yeah.
Click and press is the same.
Same.
Okay, so that's it. So, I mean, it's a weird that because I thought it's supposed to be different. Click and set this is all about how it's behaving.
Mm.
Okay, so click and set is the same.
Click and press is the same thing.
Click and press is the same.
Yeah.
It's a little bit strange they are the same, but anyhow,
Okay,
yeah.
it's the same thing, but some functions, like because we want the button to act like a push button, that is why we are using that press release. Other than that, okay, I will show you. Good
Okay,
question.
okay, yeah,
Good
yeah.
question. Okay.
Yeah.
Now we get another button. Okay. This button maybe bring it down below the.
Okay, something like this, okay?
No, yeah. Then this one bring it down, below, okay, down. Okay. This one is to change the screen. Okay, you rename that main
Okay, go to the main page.
page. Okay. So for this, I just use click enough. Because why? Okay, you press click. So what is the function when I click this one? What need to do? Activate screen.
Yes.
Activate screen. So what is the screen name? Screen 1, right? Okay, choose screen 1. That's all. Enough. Because the only one function. So there's no 1, 0. I click this one must happen.
So you mean press release is because
I have
because you want to use a release function. That's why you
Yes.
choose press.
yes,
That's the only reason that
yes, that's the only reason I want to use press release.
okay. But if I don't want to use a release function, I just use a click good enough.
Click enough. Press also can, click also can.
Okay.
That's the thing. Okay.
Okay.
Let's say you want to one button, you put in there like auto manual. You click, it's auto. You click again, it's manual.
There's still a click function.
Then you can use the click function.
And this is an invert bit.
Then you choose invert bit, not like set reset bit.
Okay.
Okay.
Okay, got it. Yeah.
Now you copy this, copy the main. Go back to other screen. Okay. Paste somewhere here. Okay. So go to the alarm screen. Rename the alarm. Go to the screen 2. Okay. Rename this to alarm. Okay. Now go back to the alarm screen.
You mean
Yeah. Click on this one, the property. Okay. Go to properties. Okay, what is it to show? All the pending alarm and acknowledge alarm. So what are the alarms? Error, warning, system, or diagnostic, all that lah. Okay.
yes.
Okay. Now some settings here. Okay. Most important, go to the toolbar. Okay. Acknowledge means if the alarm is on, I can acknowledge to. If I acknowledge, then only the alarm will go off. If no, it will be there only. This is the one. Okay, then this one enough. The rest I don't need. Okay, now you go back to the alarm. You go back to your program. I think we forget one thing. Go back. Go up, go up. Go to the main. Main. Is it the alarm block? Is there? No, right?
No.
Okay, you add the alarm block and download. Then you go back to the alarm DB.
DB.
So this alarm DB is what DB4, right? DB4 DBX 0.0 is the temperature high, right? DB4 DBX because it's a boolean. Is not
Why you need the X then?
because it's a boolean. Boolean need X. Word is just W.
Okay, so the naming is slightly different because when we have I boolean, we I bit. Okay, that's
I mean just I on that, right?
Yeah. Okay, for here in DB you need X.
DB4 DBW, for example, like 2 means it's a word or integer. DB4 DBD2, for example, is a double word, double integer or real. That's why your temperature all you see will have a DBD2, DBW, right? Okay. Now these three, right, is fall under what word? These three will go under DB4 DBW0, correct? Under the word 0.
Yes.
Under the word 0, I will have 0.0 until 1.7, 16 bits.
This is the address.
Yes.
Okay.
Okay. Now, we go down. So the HMI alarm done. Now time to create the alarms. Okay, go down. Go to the HMI part. Go down some. Where is the HMI alarm? Go some more, go down. Okay, HMI alarms. Okay. So this is where we create the alarm text. Okay, you create the alarm text first.
Okay.
Temperature high. So this is the name that will pop up. Temperature high. Okay, what is the tag? Click here. So it's under the alarm DB, right? Right. Can you show? It's not showing.
Yes.
Okay. Why? Because how the alarm works is I need to choose a word. From the word, I choose the triggered bit. I need to choose the tag. From there, okay, I can choose the bit. It means I need to choose this DB4 DBW0. From here only, I can choose this particular bit. That's how the alarm works. Okay? Can?
Can.
Okay. But now DBW4 don't have. Correct. DB4 DBW0
Don't have DB.
don't have. Okay, so what to do? Close. But we know this is inside the PLC is there. Right. From here, this is the bits. We know that. Okay, but the problem is the tag we don't have. So we have to create the tag. Okay, where to create? In the HMI tag we can create. Show all tag. You can bring it down, so fully bring it down. Okay, this one can close. Close. Close here. Yes, okay. Now, this one all is automatic, right? Whenever I choose from the DB or the PLC tag, automatic add here. Now, for this, I will manually add here. Okay, put here alarm.
Okay, so there is one additional step is you have to
Manually add an alarm. It's an integer because only 3 only, right? If let's say I have 32 alarms, then it's a double word.
Okay.
I'm only using 3, but I cannot use byte, so I use word. Integer, okay, this is the connection, everything, okay, go there, okay, go to the right, go to the right, go to the right. Okay. For this alarm, right, I don't have any PLC tag, correct or not?
You have
I don't have PLC tag, I don't have a DB also, for this particular DB. Do I have in the PLC this DB?
no.
I mean,
We
as
have
a, as a
individual,
tag lah.
yeah.
It's as an individual bit I have.
Yes.
So what I do, so I can't use symbolic access. It means this one all how it communicate is communicate using the symbols, the tagging.
The tag. Okay.
So you choose from the HMI tag. Okay, you will use the same name create in the PLC tag. That's what all this one all doing.
Okay. So this is what we say. The SCADA is communicating through tag,
Yes,
and we don't have this something called alarm.
alarm. So we have to choose absolute access. Absolute access, you can choose the address. Okay? Okay. Now it's a DB4. Change DB4.
Before.
DB4. Here. Okay. So now I have a DB4 already. That is the DB4 I link to and map to the name called alarm.
Okay. I mean, okay. Understand is okay lah. But why they have to do this
Okay, why they have to do this? Because earlier WinCC is not like this. Everything, when whatever you want to use in the HMI, I need to key in manually in the HMI tag one by one, like this. Okay, start is what, like this one, right? Where is it? Start button, right? Okay, it's a DB what? DB2. Okay, DB2.dbx 0.0, something like that.
earlier WinCC
Earlier WinCC,
do not use tag, they use address.
yes.
So now improving, everything use tag.
Everything is tag,
But
but
the alarm is
alarm is
still-
still using the old method. Why? Because all the alarm is a bit.
Okay.
But if I do bit by bit, it's difficult to choose in the alarm. So what I did is, this one they use as old method lah. So you must use one integer. From the integer you choose a bit.
Fair point.
Okay?
Assuming we have so much of alarm.
So many alarms, yes.
Right. Maybe an alarm. I randomly I don't know, say 100, 200, 300.
Example lah, under 60 alarms.
Okay. Yeah. Then it depends on how I want to group the alarm together lah. I
Yes.
can use double word,
Yes,
double word.
correct. 5 double words or 10 words.
Okay.
So alarm 1, alarm 2, alarm 3, alarm 4.
So this is kind of like part 1 alarm, part 2 alarm,
Yes.
part 3 alarm.
Yes.
Got it. Okay.
Got it?
Okay. So this
Now-
is because of old method. Okay.
Yes. Okay, now go back to the HMI alarm. Now I can choose the tag. Go to the, now it's a tag under the HMI tag, correct or not? HMI tag, alarm. Okay. And what is the bit I need to choose for this temperature height? Which
One
bit?
is trigger.
No, I mean the bit, because
Oh, which
inside, yes,
So it's a-
16 bits.
HMI 0.0.
Hmm.
So I have to choose DBX 0.0. Okay, I choose also.
Can I choose? You play with the bit.
DBX starts from 1.0.
Why? So we know that inside here DB4 DBB by 0. Here is the DB4 DBB by 1, correct? So 0 until 7, then 8 until 15. Okay?
8 until 15.
Yeah. Because here 7 bit lah. Sorry, 8 bit lah, correct? Okay? Now, so the first byte is which one? This is the first byte, this is the second byte. So the first byte, bit number 0 is what? DB 1.0.
The first byte is
DB1, the first byte is the DB1.
DBB1.
Yes.
Okay.
So under DBB1 I have 7 bits.
Okay.
1.0 until 1.7.
Right.
So bit number 0, if I choose the trigger 0, it means the first bit from here. So if I want to choose this first bit, number 8.
So you say that here I should choose 8 because it equivalent to DBX.
Yes.
I get what you say, but
That's how the Siemens
very
work.
inconvenient way to do the work.
Yeah, but that's how the Siemens work lah. We cannot do anything. So this is MB0, MB1. It means here is M1.0 until M1.7. Here is M0.0 until M0.7. So the first bit is which one? This is the first bit. Starting from here. Correct. So this is the bit number 0, bit number 7, bit number 8, bit number 15. So it starts from here, the bit calculation, the bit arrangement.
Okay. Yeah. Okay. Okay, your point here. So it really.
But luckily they show you here, so we can still just increase, just can search for 0.0. If it didn't show that, finish.
Oh, okay. Okay.
Got it?
I got it. So actually, this is to check for the sequence.
Yes.
Check for which position is it.
Yeah, which bit lah?
So you can go back to 0 also.
Yes. Yeah, of course can go back to 0. You thought it cannot go, is it?
Yeah.
Oh. Because this is where we need to search which
Okay.
trigger bit.
So this is an 8.
Maybe you can make it bigger. Name, yes, trigger bit.
Okay, the trigger bit, what
Yes.
exactly it means is just that.
Which
in
bit you
this-
want to trigger?
Yeah, in this word, there are many addresses. I don't
Yes.
care, I don't know. You go to find out which one you want to
Yes.
use.
So means under the alarm, I have 16 bit. Bit number 8 is DB4
Right.
DBS. So what happens when this bit is triggered in the alarm? I will show temperature high.
Okay, I got your point. But this is how it works. This is how the work.
Yes.
At least this is as per your DB. The
Yes.
DB show is
That's the
0.0.
most important thing. Yeah.
Here is also show is 0.0.
Yes.
There's no change. Okay.
That one got nothing. Go here, then you add another one. E-stop and motor speed.
So this is all Boolean 1 and 0 only. Okay. This what I add another one.
Yeah.
Speed high.
Yes. E-stop. Second
Oh,
one is
e-stop.
e-stop. But you mix also can lah. Mix means you just play with the bit lah.
I just want the mixture. Okay, it's not like so there's text in front.
Yeah.
Okay, so this is a text.
Because this is what it will show in the HMI, the whole thing.
Right. This is a text. Speed.
Motor speed.
Okay, motor speed. Okay, that's not good.
Okay, that's all.
Okay, and then
So it's
0, 1,
automatic lah.
okay,
Okay. Once you finish until 15, then only you start the 0.
okay.
0 to 7. Okay, save.
Wait, and this I know that we didn't change anything, but actually we can change.
Yes, yes.
Warning alarm.
What is that? Is it alarm or is it a warning or something?
Okay, wait. Yeah, because I was just trying to think because
Okay,
if
what you can
error, then you have to have some action for example, stop the action or something.
No. It just show you that okay what happened is because the alarms, right, you can create multiple page of alarm. One alarm is just to show errors only. One alarm is just to show warning only. Okay, so when you categorize like that, then in the alarm screen, where is the screen to here? You double click this one property. Open the property here. Go to the general. So it can show, okay, let's say in this particular page, screen number 2, alarm only show errors. So when you create alarm text, you can categorize which one is the error, which one is the warning. Then you can create another one is for warning. Okay. Then I think you can change colors also. I think for error, for warnings. Must play lah. Go to appearance.
Yeah, but doesn't matter lah. I think this one normally people just give you a feel lah. You want to filter all alarm or you want to filter
Yes,
things
yes.
and then they show on it. Yeah. Okay.
Okay, good.
Okay.
Okay. Save. If done. Okay. You run time.
Runtime. Okay. So I have a okay. The cursor become energized cursor.
Because I can press here. Okay. You go to main first. Main. The temperature you put lah. Just now, how much we put our temperature? 50, right?
Yeah, how come we set already?
Because we just now we reinitialize the data
Because we had the data block.
data block. We do something. We add the alarm reset button.
Okay.
So we reinitialize.
Yeah. So now I add 50.
Yeah, we put 50.
Speed. The alarm.
Set point.
The alarm.
1000.
is,
We put 1000. Let's say
1000.
1100 lah. 1100.
Okay. So I put 800 first. Then try
Okay.
800 first. Okay. So now.
Your this one got error, so you reset first. Okay, start.
Okay.
No alarm.
No
Go to
alarm.
alarm.
So increase.
No, you go to alarm page and see. Alarm. No alarm. Okay. Okay. Increase.
Okay.
Enter.
Oh, enter.
Okay. Go
Put
to
down
alarm.
immediate. Okay. Acknowledge. Okay.
Motor speed.
Motor speed.
Yes.
If I acknowledge,
Acknowledge.
it will not get lost because my speed is still there.
Still there.
Okay.
Because you haven't reset yet. So you reduce the
So 100.
go back to alarm.
Alarm.
So it won't acknowledge until, because can you see I means is on, A means is already acknowledged.
In here, this reset button and this 2 is a set function.
No.
No.
Reset is I off in the PLC I off. But in the text it will be there until I acknowledge, then only it will off.
I try to say again what you say. Reset is I click here, my motor speed dBx 0.2 it goes to 0.
Yes.
This is what I do with this button.
Reset button, yes.
But if I click here,
Acknowledge,
acknowledge,
it will clear the message from the list.
it will clear from alarm, it clear the status from warning or from error to become acknowledge.
Yes.
That's it only. But it will not reset the.
No, it won't reset. You can
Yeah.
try it with the stop button. Okay, you just reset.
Oh, I do this one first.
No, it's already acknowledged.
Oh, it's already acknowledged.
Yes. Okay,
Okay.
you reset first. You play with the last button, the restop button. You
This
press
one?
because the others all need to value. Okay.
Okay.
You on. Restop I means is on already.
Yeah.
Okay, you off the button.
Yeah, off already.
Okay. Because we are using set reset.
Right.
Okay. You reset first. Okay. Means means the alarm is energized. Then I already reset. alarm will still show here until I acknowledge. If I acknowledge, then only it will go off.
I get what you say. I assume this is a plant alarm. Say this is a temperature high. Now something temperature high. Give a high temperature alarm. So it triggered show the HMI the high temperature. What should do? So normally, which is if people ignore the temperature in the process, they just come here and click. They will not remove it because the temperature is still high. So it's acknowledged, but the real
No, you reset. Press reset.
I
Because reset is the one going to off. Going to off that particular bit. So I already acknowledged and I reset. It's still there. It means it's still on.
right, which is this is what happened now. The
Yes.
temperature is still high.
Still high.
You cannot reset it.
Cannot reset.
Because you reset, you go back to 1 again. You
Yes.
reset, you go back to 1.
Yes.
Unless the temperature is really too low already.
Yes.
Then you reset.
Okay, now you on. Now you leave it on. On. Leave it on. Okay, now you reset. Okay, it won't show 0.
And you can acknowledge.
Acknowledge can, but it won't go 0 until the error off.
Reset is happening inside the PLC, not in the SCADA.
Not in the SCADA. Reset is happening. Reset is to reset a particular address.
Particular address.
But it's depend on you. If let's say that alarm you don't want like set reset. When it's temperature high, alarm on. When temperature is low already, the alarm should be off. It means then you don't use set reset. You just use normal call.
Okay, what you say. It's common to have reset button.
Yes, because why that? Because then only we know when it's happened. What time it's happened.
Yeah, we want to lock it here. But I remember that to remove it from this page, it's the other way around. Somehow. It's like acknowledge, you will clear the
Error.
for example, this is a high temperature, red color,
Okay.
show up.
Okay.
If whatever,
It's still on.
not to say still on, say the high temperature go on already lah.
Go on. Okay.
Yeah, you go off already. So
Go
temperature
on
go
and off already. Okay.
Yeah. So you come here, you not do anything yet.
Okay.
There is a red color alarm.
Okay. Acknowledge.
You acknowledge first,
Yes.
then become blue color.
Oh, then you need to do some settings there lah.
Then reset again, then the alarm go away. Probably I remember wrongly. But anyhow, definitely this is an alarm reset and acknowledge lah.
Yeah, the same. It's just the name only lah.
Okay.
Just you
Yeah.
can play with the name. Yeah.
Okay.
Reset the alarm. Acknowledge all that.
But this is how it works lah. Okay. I think so alarm working already. This is working already, and we try the different functionality of the alarm. Okay.
Good.
Good.
Good. Okay. All good.
All good. Yes.
Okay. Now, save. Okay. I think this project you can save it. If all okay, you want to go to the counter. Okay, I will show you counter. What is counter? Very simple. Okay, go up. I will show you the counter.
I see.
What's that?
You want to stop
You can use the stop button, right? Push button.
which one?
One,
Second one, right?
third one. The selector switch.
So the switch.
The first selector.
Stop.
Now.
Question. Can we go to the mod parts?
Yes.
first?
Can.
Okay. Yeah.
Okay, so that's why I want to do what I want to do. Okay, we try to use the same one. Because I
Okay.
see the one cannot use Modbus. TCP
Okay. This one can I use?
can use Modbus RTU.
Okay.
Okay, so
Okay,
we
never mind.
do PLC to PLC.
Okay.
Okay, Now what we do, we go up, we try to use the same project here, go up, you off this PLC first, close the runtime close. Add new device.
Okay, here any devices, we cannot add a controller. Or
Can add the controller.
okay. You mean add the 1005?
Yes, this 1005 you add. It's either the 121C, the first one.
This one.
1511, the second one. Yep.
Version 2.9.
Yeah. Next, wait, not finished.
Okay. Delete it first.
Not delete. Wait. Don't delete. Okay, click here. Right click. Properties. Go down. Protection. Go down. Start the security visit. From there you can just do that. Okay. Next. Allow. Uncheck this. Next. Full access. Finish. Okay. Now, but now maybe try and see. But because this is a Profinet, right? You see, can work on. Okay, now what I want to do, you right click the same, go to you change this IP address. Yeah. Open this. Properties. Go to internet address. Put to 8, the last number. Just put 8 here. Okay. So we don't need to connect to the subnet, not connected. Okay? Because it's not Profinet configuration. Okay, close. What I want to do, you right click here. Yes. Okay. Wait. I want to download. Before that, I just connect. Okay. This one. Go to here. This one. I have one more slot. Okay. What? Because this IP address is same. Correct?
Right.
Then we left a conflict as well as which is changed to 8. Okay. Then we download the IP first. Okay. So now right click the PLC. No, the PLC.
This one.
Here also can right click.
Oh.
Download to device, hardware configuration. Let me check it because I also forgot.
So this is a 1512.
Oh, it's already 10, is it? Never mind, we change to 8 lah, later.
How come it did not detect the 1002?
Because you configured is 1005.
Oh, because I right click on the 1005.
Yes.
Okay. So it has a
Connect. Okay, finish. Okay, done. Close first. Now what we do? Okay. First we set up this device configuration. I forget to do one more setting. Okay, right click here. Right click here.
okay.
Properties. Go up. Okay, system and clock memory. Enable this. So this is the system memory, means like always on. This memory will be always on. This memory will be always off. And this one will give a pulse. On off pulse. 1 second pulse, all that. Okay, we need this for the Modbus.
Modbus always need
Yes.
clock.
Clock and always on. Not always needed. You can do manually also. Okay. We see later where we use. Okay. Yeah. Now, what I want to do, I make 1002 as a server and 1005 as a client. Means what I want to do is I want to read this temperature inside the PLC. Inside that PLC. Okay? That's what we want to try. Okay? Go to program block. Main OB. Okay, here we do in the main OB, no problem. Okay? Now, what we do? One by one, go to communication. But this one will take time. When you going back today?
Anytime.
Okay, go to open. I think this one will take like 1 hour. Okay, close. So others, go to others. Okay, Modbus TCP. Client. Take the client position. Okay, okay. Then here you put always on first. No, here. The enable. Yeah. Put normally open, always on.
Always on.
Yeah, the one just now we enable. Yes. The always true. This is the memory just now we enable, right? Okay. Now for this one, okay, we create an add new block. DB. You put Modbus. Okay. Make it smaller. Bring it to that side because all the data I want to put it here.
Just
No. Bring to right hand side. No. Here. Put it here. Okay. keep all. No, no, this one. No, okay. Okay. You put all this. For request I need disconnect. Okay, yeah. Whatever you see there, you just put. Later the data tab, I create it. MB data parameter. Actually, you need put disconnect MB mode, data address, MB data length. This is parameter only.
Sorry.
Only. The one you put connect. This one. So disconnect is boolean. Okay. MB mode is unsigned short integer. The data type. Yes. Unsigned short integer. Okay. Then the other one was unsigned double integer. Then the last one is unsigned integer. And this one is because this is a TCP/IP. So tcon t. I show you where it goes. Tcon tcon. You need to key manually. Yeah. Underscore IP
P.
IP, yeah. Underscore v4. Okay.
V4.
Yes, enter. First, use this. Then this one no need lah. Status maybe you can add status. Status. Status is a word. It's a word. Okay. Alright. Now you add all these here. The request no need the disconnect here. No, here, disconnect. Starting from disconnect. Request later you do. Plus MB mode. Because why what is MB mode? MB mode you choose what? It's the unsigned short integer. USINT. Later I will show you where I get all these. And I will tell you why I am using this also. One pass is the address, maybe the address. Is the data length, maybe data length, yes. Then the last one is connect. The last one. Just enough for it. The connect dot will take out. The connect, after the connect there's a dot will take out there. Okay. The dot take out. Just click here, don't enter. Just click here. Okay. Now for this also we create done. Okay. WDZ error, all boolean.
Okay.
Okay,
Yes.
you put all that here. Status.
Oh.
So for this, put normally open. Normally open. You put the timer. You put the clock.
Clock.
This one we clock, right? We enable the clock, right? Choose the 1 hertz. Yeah. Okay. Okay, I'm going to try this one first. Okay. Now you save this first. Okay, what is this all about? Okay, you close, cancel this. This one no need to attribute. The attribute no need to uncheck lah, because we are not using it first. Okay, you write. You go here. Go to communication. Okay. Description. You go down. Okay. Request is request the parameter level. So started clock again during the ongoing the request on and off, on and off, on and off. That's why we put a timer there. Okay. Okay. Go down. Okay. Disconnect. Okay, always is the zero lah. This number. This is a boolean, right? Okay. Always zero. If you want, then you disconnect. Okay, so we will do that. Here, select the mode for Modbus request. Okay, the mode is because every mode go through the Modbus. What is Modbus?
Roughly lah. Yeah.
Modbus, they have their own address.
Right.
Like read, write, read register, write register, read call, write calls.
Yes.
Okay, so this is the mode. Mode means which mode you are want to use. Read, write or diagnostic. Okay? Okay, you go to the MD mode first. MD mode. So we want to do what? Read, write. So if the MB mode, the value is 0, it means it's read. Okay, so what you do, minimize this. You open the Modbus. So the MB mode value, you leave it 0. Okay? Okay. Next. Okay, you go back here. Go back here. Go down. Go down, go down. Okay. Then the data go up. Go up, go up. Okay. MB mode. Okay. Okay. The data address, you click here. Go down. Okay. So the address must be between this only, all this address. If MB mode 0, this is the address.
MB should be stand for something like
Modbus.
Modbus. Okay.
Modbus mode. Okay, this is the data address. Okay. Okay, now go down. So we want to read what? This one all go up. You see, read output bits, read input bits, read holding register of the remote address, read holding register of the remote from 0 to this one. Okay. So now it depends what you want to do. This one is the input word.
Okay.
So this is a write, means this one all you can read. This one all you write. So this is the addressing. This is how the address format is. Okay? Okay? Now we want to read value is a holding register. Okay? Alright? Okay. So MB input just now we choose 0, right? The data line we put 40,001. Okay. Minimize this. We put data line 40,001. The address. Yes. Enter. How many address you want to read? Let's say I want to read 10 data. So one of that is temperature line. Okay. So this is the length. How many, starting from 40,001, how many data you want to read?
Okay, so this is
40,000 is because I want to read values.
yesterday I tried to check the Modbus configuration. It's a I didn't go into all this, but it's roughly what I see. I randomly open some equipment or some device, right? And then I can check the standard Modbus address. So if you open the long list, okay, then it will show this device. These are all if you communicate with Modbus. Then you have a list of Modbus address.
Yes.
ACC, whatever means what, this one means what,
But
this one means what.
that's a number, right?
Yeah, it's a hex number, I think it's a hex number.
X number, this is the one.
This is the one.
Yes.
So this 4001, we need to say
Is according to your device. In the
according to
device, they will tell you that 40,001 is that answer lah.
Okay.
Speed, because
Yeah.
you are reading. Reading means is the status word. 40,002 is the speed word.
Yes. So I think I just want to get a high level picture first. Imagining we are getting Modbus
Data from the
data from the
yes,
VFD.
yes.
One block is get one information.
No,
No.
one type of information, one type of data.
Type of.
Yes, means let's say the drive can give you words. Let's say integers, right? You can take integers. Let's say the one can give 10 integers. So in one block, I can read integer. That is integer is means this one integer. How many is here? Okay. Let's say you want to read Boolean, then you create another block. That one will be, of course, MB mode 0 is going to read, and starting from what number is according to the drive. So from 0 to 9999 is always the
Boolean.
Boolean.
Oh, you mean vendor normally they design the Modbus address, they always group in the.
Of course, because Modbus has a standard address. And from 0 until 999 is a, if not mix, is I think it's the output coil.
Oh, okay.
10,001 until 19999.
I think there's 4 type only, right?
Yes, 4 times is the main. Then you have some others also, some other functions. There's a main is coil.
I remember the coin very special.
Because it's a read coil, write coil line.
Oh, read coil.
Okay. Then read register, write register.
Okay.
Similar line. Output, input,
Okay.
and digital input, digital output, analog input, analog.
So if I want to, logically lah, if I want to get all the information from EFD, probably I need 4 Modbus blocks.
4 Modbus block.
Each of it I define first Modbus block is a
For
DI.
DI, yes.
Okay, then the mod is settled is I.
Mod
And
is
then,
settled. Then this one
address
is depend
list.
lah. Address depend on what is the address.
According to the D lah, it starts from where to where.
Yes. Then how many address?
How many is there? Probably it has a 20 status.
Yes.
It will tell you the length and the addresses from where to where.
Yes.
Then this is the
Then this is where, okay, you put the address first.
okay. This is
Let's say 5 right now.
5. Okay.
Okay. The connect, you open the connect. No, open here. Okay, because open is the what? TCP/IP function. This is where you put the what is the ID, what is the IP address, everything.
How to put?
Okay, then I'll show you. Okay. Interface ID is from the 1200. All this data is from the 1200. Okay,
So it's we call this a server or client. Okay. Interface ID, which is
wait, the one you go to the 1002.
okay.
Right click the 1002 properties. No, here we get it. No, system. Sorry. Right click property. System constant. Okay. You see interface. Hardware interface, right? 64. Okay. This is where I get the hardware ID for this 1002. If you are working with that, then you need to check on that.
Okay.
264.
Okay, put 64 first.
Yes.
Oh, this is something that not so easy to get.
Yes.
If let's say today this podcast is not communicating to this, it's trying to
That's why you
distinguish
see.
from a
That's
device.
the reason you must have the manual. Whatever Modbus want to communicate, the most important is the manual.
Okay.
From the manual you will get all this data.
Is the manual only can give all the data?
Yes, of course.
The manual only will give you sufficient information.
Yes.
It's manual in here's a question. Somebody need to want to set up communication. All he needs to do is go to the website, look for the device
Yes.
manual.
Okay, you see, this one is a serial communication. So you see here, from the serial communication, what I get? Local, the address there I need to put here. So this is the local ID. Later on, if I want to choose I want to do this here. Then communication, because this is the using RS485, right? Let's say I put 9600. The same communication address I need to, the data I need to put it here. But for this, we will be putting IP address. Okay. Then tell you where.
If you tell you this communication how to set, which is all the hardware and
So somewhere here, okay, you see this one, so it's a control command, see forward, reverse, okay. This is the address 1000 in Excel, okay. This is the address. If it is value is 1 means forward. If you put value inside here 2 means is reverse. Still using the word function.
so 1000 hash is the address for the Modbus. So this name is different to this serial name already.
Yes.
Okay.
Something.
But this is actually is an address. It's an address for the
Address when we configure this one we get IW258 address, similar concept for this.
Right.
So
this is a Modbus format.
Yes, in Modbus format. So like this, so you can see what they give you. In the 300 is the state parameter. It means you see like a 3000 the feedback. So this value only you can read only R. Can you see? So the first word is output frequency, second word is the reference frequency, third one is the bus voltage, power output, rotation speed, everything is there. So many.
Yeah, I mean,
You got the idea, right?
I got the idea. Like this one has a lot of parameter.
Yes, yes.
I just try to think, like, let's say if something is super simple, it's a simple thing, just like one variable.
Then one Modbus block. Then you need to, because this ID all I need to tell from where I take the data, because I can have multiple.
Yeah, so the concept this TCON IP I say this PLC we connect to two different brand of VFD, both also one controller, one VFD
Okay, yes.
So I want to have two different communication of Modbus, right? So at least then it means at least I have to have two block already. One go to this, one go to this and this.
Yes, yes.
And then here TCON IP before is
I know what you're concerned.
yeah, it's all the information.
Why I need, can I take all the information in one block?
Not exactly. I just want to know that how difficult to do this, like how to do this.
It's not difficult. All the difficulty is mostly the setting only here. Setting and what data you want to read, that is most important.
And you say that this setting, imagine the vendor is out here, he can tell you everything except on the spot.
Yes, if the vendor is not there, you download the manual, you go to the Modbus communication page, then they will show you what is the address.
Then they will tell you what is means by remote port and what is the number.
Yes, I think remote all don't have. The most important thing is they put ID.
ID.
But in Siemens they call interface ID. In that one they don't call interface ID. Maybe they call Modbus ID.
Okay.
So what you need to do first? You go to the help and need to understand what is this.
Okay.
Interface ID means what? ID is means what? Okay. For example, go to here. Go here. Go back. Go down. Okay. Under the connect. Okay. Click connect. Go down. Okay. What's that? Hardware identifier. ID means what? The parameter uniquely identify the connection within the CPU. Each individual instance MB client must have a unique ID. Connection type is what? 11 means it's a TCP. Okay, go down. This one is true for activate connection. Okay. Then the remote address, right? Under the remote address got 4 4 address. That is
So
the
it's
IP address.
IP of the
Yes.
device.
Remote port 502. Okay. If you're using TCP/IP 502. Okay. Then local port number of a local connection part. So port number 1 to this one. Any port means 0.
What is the local port?
No, local port means your port number of the local connection partner. The port number for the local connection partner, I mean your PLC and the device are the device part. So if you have a number, you can give it a number. If you want to choose any port, just leave it 0.
So
So it means some will have the port number, some don't have the port number. If they have a port number, you choose the port number. If they don't have the port number, you just choose any port.
So I think it's something to say like this. Important part is
Important part is the hardware.
this hardware
Okay.
from the manual.
Yes.
ID from the manual.
Yes.
Is it correct?
Yes. Connection type is not in the manual, is within the TI portal.
This is a
TI portal.
11.
Yes, TI portal. The true also is it within TI portal.
Yeah.
You won't get anywhere.
IP address.
IP address is okay from there.
You have to key.
Yes.
He have to key in his device first. Then
Yes.
I read the correct device.
Yes. Then the remote port, that is from the remote port. Port number. Then
So
the local port is your port.
so essentially, let's say this is time already. And then I have a block. I have a block, right? I have a Modbus block. 1CK.
Program block.
Okay. So says this is really connected. So it should say this Modbus time is become 1 or something like this.
Actually,
Next question, yeah.
actually,
How to extract
you need
the
to complete first then only you can.
Yeah.
If you ask me.
You need, I get what you said. You need to have a fully functional
Yes.
thing first. Okay, I know what you say. Yeah. Do you think this one can be fully functional or? Oh, okay.
Yes.
Yeah.
Because you want to take from there only. Now
Yes.
only we created this as a client. Need to set up that as a server.
Okay.
Then from there we send data. Here can receive. That's all.
Okay.
You go to the DB. Okay. So this ID you actually you close this. Okay, here also can connection reference identifier. Just leave it 0, no problem. Okay. Your ID you put 1 now. Just put 1. Okay. Then this one put 11 because it's a TCP connection, right?
Yeah.
Okay. This one put true. Okay. And the IP address of the client 192.168.0. IP address of the what client, your 01. Okay. Look, 502. Remote port 502. Okay, local port you leave it 0. Okay. Save.
Okay.
You download the right click. Go to download hardware and software. Both. Because why? Just now you remember I enabled the system memory, the block memory.
Yes.
That's why I need to download hardware and software. Okay, good. The error you just you go down all the way down. Okay. Now go to the PLC one. Go to program block. Okay. Go to add new block. No. 10 seconds. We go to main lah. In the main we do that. You close this one. Here we put the Modbus server.
Modbus server. Just now that one is this client.
Yes. Okay. Okay, running. You add one DB, global DB, then you key in the same thing. What you have.
Yes. Register also need.
Yes. Connect. Then NDR, DR, error status. Then the data type will tell you what is the okay, good. Okay, the disconnect is I think it's a boolean. It's a boolean, then the MB hole. Actually MB hole no need. Holding register. Actually actually this one together, you know. MB
Yeah.
holding register. No need take up. Because this is where we want to transfer the data.
So delete this.
Okay. The no need actually. Take up the register, take up. Okay, the connect, okay. Like just now like tcon I underscore IP underscore v4. Tcon underscore IP underscore v4. Okay, then the status would okay, and this disconnect, connect, and this one. Okay, the holding register only. Later. No, connect dot take out.
Okay. Okay. But one thing for sure, we say this way, right? Say today, this is a VFD, right? say Aviva. It's not to Aviva. It's to the another PLC, Alan Bradley. Say Alan Bradley that side, he do all the Modbus programming.
Yes, but he no need to do the server. He need to do the client.
Okay, say he do the client. Here, I need to do something also to send out the signal.
Yes, of course.
The VFD have to.
No need to do send out the signal. What you need to do there is need to tell the communication I'm using is a Modbus.
Okay.
Because there's a parameter
Because I
to
connect the part. So when I do configuration, I have to select Modbus instead
yes,
of
instead of Profinet.
Profinet.
There's some parameters to set if you're using Modbus. That is in the manual you have.
If I set down Modbus, it means this is the communication already. And
Yes.
the PLC
That is what here this one doing.
This one is doing. This one is doing change to Modbus.
Yes, yes.
Okay.
Okay. Now go to connect. Interface ID of this one. You right click here. I think it should be 64 also. Properties. System constant. 64 also. Okay, now use the 60. Use the 60. So 64. No, HMI 1. This one is 11. True. Okay, the remote address. Address 192.168.08. Okay, then remote partner is 502. Siemens is 502. Local port I leave it true. Okay.
0.
0.
Okay.
Okay, close. Okay, now you right click this PLC. Okay, only such a good. Okay. Now what I will do, the register, you go to this one here. You know what I said?
Okay.
You see, here is the data parameter. Means this one will read the value, correct? MB client is the read.
Okay.
Read the value when? From the data address, that is 40,001, correct? Okay. Then here is the data length, right? 10 length. Okay. Then this one is the MB data parameter where you save this that 10 data. Where you save. Okay. Okay. What do you
There
need?
is a destination here.
Yes, there's a destination here. Okay. So first we go back to this memory first. Okay. So this one is from where I want to send the data. Okay.
What I'm giving him.
What I'm giving here. Okay. So I need to send that. We choose 5, right? Just now the blank. Okay. I will put 5. So for that I need to add new block. You put Modbus data. Okay. Okay. Okay.
Oh, okay. Probably, okay.
Yes. Okay. You click here data. Just put data. Okay. Here you put array.
Array.
Yes.
So Modbus always use array.
Because I need to do multiple, right?
Okay.
Okay. Integer. Because I want to move some int. Just key int. Int from 0 to 4.
Change like this. Okay.
No, the bracket, don't forget. Okay. Enter. Enough. So we have 4 data. Hey, integer or real? The temperature is real, right?
Real.
Okay. Then choose real. Okay. Okay. Good. Enough. That's all. Go back to the main. Okay, here you put the what? Okay, not data block one bus data. One bus data. Is it? Yeah. Okay. Take out the bracket. Take out the bracket. Okay, just click here. No, take out the bracket, just click here.
Okay, I'm sending the whole array out.
The whole 5 data. Okay. Then go down here. I want to move the value, move the temperature value here. Take
Temperature move to the array.
one of the array lah.
Okay.
Then only there you can see. Just put the move. So can you okay, here move. Okay, this is here.
DB. Data types. Auto DB.
SCADA. SCADA. Okay. Current battery. Here. Move to the first array of the Modbus. 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 Data 0. Okay.
Okay, you look at it.
Got it?
Yes.
Okay, save. Think it should work. Okay, now what you do, you click here, the PLC, right click, download to device, hardware and software.
Let's do it.
Look,
Now it's reading 44 degree. 44 degree.
44 degree. Okay, so it should be 44 degree. You should get that.
In here.
Yes.
Right. Okay.
Okay, but first, okay, never mind. You minimize this. Monitor. Yeah, that's the one. The arrow. Monitor. I see got any error.
I'm true. Is it?
Error, what error? What error? 80BB. 80BB. You go here. Go here. You go to M. You close this. Server open. Click description. Go down. Go to the status. Status, go. Here. Here. Activate SMAD to the type of connection to connect parameters. Only passive connection. I think the other connection is not. Okay. Activate establish is false. Okay, never mind. We see what was the problem.
So the connect we want to change to false or
No, wait. Go to the data. This one got data block. MB server D. Open. Under. No. Sorry. Data block 1. You put the connect. Oh, I think must put 1. It's not true. Put value 1. Enter. Okay.
介绍别的 block.
Never mind, we settle this one because other block we haven't finished it also. Right click, download to device software. Okay. Okay, never mind. What we do, you go to the data, the 10 5 data. Okay, you put data, I mean Modbus data lah. Data read, okay.
Function block.
Modbus, and data, okay. Same thing, data file array.
This is inside here.
Inside the 1005.
Which is
Array, yes.
of view.
Real, okay, 1 4. Okay, go back to the main.
All this out. No need to call.
Here,
Data.
scroll. Data di Modbus, okay. Data, yes. This one you take out, this bracket you take out. Take out, just click here. Okay, just click outside.
Okay.
Okay.
So we are taking five data.
Five data lah. So, okay. Now you click this download hardware and software. Search.
Okay. You see amount.
Monitor.
Okay. Okay. This is every second.
Right. Okay, then it means I need to do some modification here.
Okay.
Okay, because of error. When it's off for error, 701, 702 means it can communicate. Okay? You go offline. Got some modification. I mean just for this lah. Okay? You click here, you put a branch.
The branch is here.
Okay, you click this. Put normally open. Close. Okay. Now here you put done. The Modbus done. This one you put it here. Okay. I just follow this one. Okay. You click error means what they try to do. This one request is always must be on. If there's an error, must off and on again. So I just need to always give the signal here. You put under here another branch. Okay, put normally open. Okay, put the error, the Modbus error.
Okay. Sorry.
Okay, the Modbus error. Put the Modbus error. Error. Okay, put it here. So if done means okay, whatever. Okay, put connect.
This is open.
Okay, click here, open lah. So whatever. Initially, this guy will give the signal to request. Okay. This one is okay, then the done will on, this one will continue. If got error, this one will on, so it will request again. You know, something like continuously request. Without this also I think can run.
Okay, let's try. Yeah.
Let's try. But here you put normally close. Just put copy this. Copy, put it here. Just follow the one video here.
Copy to
Copy here.
here.
Yes, paste. And so yes.
Copy.
No, copy this one. Copy this one. Yes. Here. But then later both change to normally close. If this one on, this one will request. So there is no need pulse. Put normally close. No, wait. Undo or delete. You can double click and change normally close. Yes. Okay, you see, initially this guy will send a signal to request lah. If it is done, then this guy will take over. If it is error, this guy will send a signal. Okay. Download. Because I want continuous signal lah, or I can do some other programming also here. This one will not an issue here. Okay. Monitor. Okay. Do I have error? Now what I do, okay, this one I think almost done. For data, okay. Now go to Modbus here. No. The data link. Monitor. Can I see any value here? Okay, not yet. Okay, no problem. Close this. Okay. Go to main. Something problem with this one. Monitor here. No, not this one. Wow. Mine, this one is error, right? I think this connect. Why?
Because we haven't changed the true fossil.
Wait, I check what I will do there.
I think this is a basic
Okay,
setup.
okay. Basic setup. Okay. I think one we forget already. The local port, remote port wrong.
Okay, so we go into the data block here.
Which one? I don't know. Data block is it? No, not this one.
No, this one. This one.
Okay.
Report.
Okay. Yeah. This one is 1002, right? For 1002, remote local port we put 502. This one remote is 0. Then 50.
Okay. And the other one is
Okay, activate establishment. Here put 0.
okay, one server and client has to be different.
Yes. Okay, server. Okay. Activate the rest is okay lah. The IP address is IP address. Put the IP address. 192.168.0 lah. Okay. You download this. Right click, just download. Download the device. Look. Okay. Now go back to here. No. Program blocks. The Modbus. Here, the remote is 500. This one is 0. Activate establishment. This one is 1. Put 1, not 2. Okay. Then hardware ID say okay 192.168.0.1. Okay. Download. mean, monitor here, we see what is the error. Or do I need to add something missing, what to do?
That's why I will
Wait,
But at least I know that you know that the error is within how to set up the pass.
yeah, it's just the error between, this one something here.
If this function block is set up correctly with all the parameters correct, then we use a DB to extract the data. We
Yes.
use an array to extract the data.
Yes.
Okay, I think I will call it as it is lah. I will go back and do some study on how to set up. Because I just try to know like if we want to set up a mod bus, what are the works have to be done, who have to give all the information, how long we have to do it.
That's the thing, so that's the
Yeah.
main thing lah actually.
Yeah.
Yeah.
And then okay, I think this is the answer is not so straightforward and have to further study to know in detail how to do this. Yeah.
Mod, first need to understand what is mod bus,
Okay.
then only we can do this.
Okay. Yeah.
But here you almost there, there's the need to, just some settings here, 1010 settings here.
Okay. Yeah. Okay. Yeah. I think that's fine because I have to move to somewhere else.
Yeah, need to go.
Yeah. I think okay.
Save here, whatever you done, you save. You can copy this file now. You bring pen and pen.
There's no USB-C.
Close everything and save.
C drive to USB.
Yes, thanks a lot.
Going back to yeah.
I have to go to meet my friend first.
Oh.
Okay.
Yeah.
Oh, thank you, very nice. Okay. Oh,
And
I have to use to take a picture.
okay.
Okay.
Take a picture of the logo.
Yeah. Very good. And have a cute memory.
That's good.
Okay. This is something I do like. Like, the boss has to be on the left or on the right, I don't know. Okay. Yeah. Look at the AS automation here.
That one I can edit.
Yeah.
Okay, good. Okay, thank you. Yeah, thank you, boss.
Yes.
Okay, finish already.
Yeah.
Yeah, thanks a lot, thanks a lot. Sorry, I have to move out.
Yeah.
Yeah. The class I
No.
really, yeah,
No.
it's online because I'm really watching it already.
The cable,
I didn't leave anything here, right? Yeah.
No, the USB cable.
Oh, sorry. Okay.
we have one.
Okay, yeah. Okay, thank you.
So, okay then.
Okay.
Just keep in touch and thank you
Right.
for choosing us.
Thank you. Very good choice. Everything is very good. Thank you. Thanks. Bye. Yeah.
The hardest logic 500 how?